nodules included countries like India, Germany, Russia, UK, Japan, South Korea, China. So as an introduction, deep ocean mineral deposits include chemical deposits, which are crusts and nodules, and hydrothermal deposits. They have been utilized in studies of paleoceanography, paleoclimatology, geochemistry, biogeochemistry, and oceanic chemical mass balancing calculations. They will be mined in the near future as a resource for critical metals to facilitate the transformation to a green energy future. Oops. These deposits occur in areas beyond national jurisdictions under the jurisdiction of the Seabed Authority and within exclusive economic zones of coastal nations. ISA currently has 170 member states plus the European Union. There are 5 kinds of deep ocean mineral deposits. Polymetallic nodules, also known as manganese nodules, form on the vast abyssal plains of the deep ocean. Polymetallic crusts, also known as cobalt-rich crusts, form on thousands of seamountain ridges throughout the global ocean. Polymetallic sulfides, also known as seafloor massive sulfide deposits, form at hydrothermal vents along 89,000 kilometers of ridges. Rare earth element-rich muds form on abyssal plains with very slow sedimentation rates. And phosphorites form along continental margins and on open ocean seamounts. I will talk only about the first 3 in this particular talk. For manganese and iron oxides, there are 3 types for the polymetallic nodules. Hydrogenetic, which means that all metals are derived from cold ambient seawater. Diagenetic, which means all metals are derived from pore waters of fluids and sediments, and mixed hydrogenetic diagenetic metals. The mixed type is characteristic of the Clarion-Clipperton manganese nodule zone and the Central Indian Ocean Basin nodules. Diagenetic nodules are really confined to small areas like the Peru Basin. Hydrogenetic are the most widely distributed globally, and they include areas like the Penrhyn Basin, where the Cook Island nodules are, and the West Pacific nodules. So ferromanganese crusts are all hydrogenetic, and there's another whole group of nodules that are hydrogenetic, and they're the most common types of nodules. And if they occur in the same water depths, they have very similar chemical compositions. The mixed source nodules have metals derived from sediment and metals derived from seawater. Diagenetic nodules, that's indicated here as forming below the sediment, but actually they form at the sediment surface. But there are diagenetic reactions in the sediment that release metals that are acquired by these nodules. The nodules themselves are not diagenetic, but the metals that they are formed through a diagenetic process in the sediment. Manganese nodules, they form on sediment-covered abyssal plains. They're small in size. They're composed of manganese and iron oxides with significant amounts of critical metals, which vary according to the nodule type. They form by precipitation around a nucleus by iron and manganese oxides from cold bottom water and or sediment pore water. They form in areas of very slow sedimentation rates, low to moderate primary productivity, and sources of nuclei. If any of those 3 do not exist, nodules will not form on the abyssal plain. This is a new permissive area map. These permissive areas for nodules are mostly within areas beyond national jurisdictions. And the ones shown here are the Central Indian Ocean Basin nodules and the West Pacific nodule field, the Clarion-Clipperton fracture zone area, Peru Basin nodules, these are the diagenetic ones, and Penrhyn Basin, which includes the Cook Islands nodules, group of nodules. And really the CC zone nodules and the Clarion-Clipperton and the Central Indian Ocean Basin nodules are very similar chemically, as are the Penrhyn Basin and the West Pacific nodules. Those are very similar chemically. Peru Basin are distinct from those two different groups. Through the International Seabed Authority, there are 17 exploration contracts in the CC zone, one each in the Central Indian Ocean Basin and in the West Pacific nodule field. Let's see if I can get this video to work. This video is from Moana Minerals contract area in the Cook Islands EEZ. Let's just move forward a little bit here. And this is the video of the seafloor nodules in their contract area. I've never seen anywhere else in the global ocean nodules so densely populated. They're just abutting one to the other. And this video goes on for several minutes, just showing this really, really dense nodule field. And as I said, these are 25, 35 kilograms per square meter of nodules, which is very rare. CC zone, Central Indian Basin would be half that concentration. Yeah, so here I'm listing 4 nodule fields. There's the 5th one, which is not on here, the West Pacific nodule field. But you can look at the Cook Islands, and it's very similar to that. For the manganese, Peru Basin is the highest in manganese, critical metal, and the CC zone is the highest, second highest, and then the Indian Ocean Basin, the Cook Islands. For copper, these are 2 very important metals, and they are what makes the CC zone so important, because the metals are so high, nickel and copper. They're both over 1%. The Peru Basin has the same nickel content as the CC zone, and Indian Ocean Basin is very close to it. My computer's taking control of itself. And for copper, the Indian Ocean and the CC zone are equivalent. So there's high contents of metals are different in the different types of nodules. The CC zone, Central Indian Ocean Basin, which are the mixed type nodules, are really essentially a nickel ore. They have high concentrations also of copper, manganese, and cobalt. The Peru Basin is really a lithium, manganese, nickel ore with lesser amounts of copper. Penrhyn Basin and the West Pacific nodule fields are cobalt rare earth element and manganese ore with lower concentrations of nickel. But their cobalt and rare earth elements are the highest in all of the manganese nodules, different types of manganese nodules. And let's see if I can move this out of the way. So ferromanganese crusts grow on rock surfaces at depths of 400 to 7,000 meters, all the way from the Arctic, which we studied these in the Arctic Ocean quite extensively, to the Antarctic. And they form pavement-like structures that are less than 1 millimeter to 260 millimeters thick. They grow on seamounts, ridges, and plateaus in areas free of sediment. The thickest continuous crusts occur along the outer summit margin of geos, large flat-top seamounts. I'll show you an example of that. They acquire elements from ocean water by absorption, oxidation, and co-precipitation by the framework manganese and iron oxides. The crusts grow at extremely slow rates, typically 1 to 5 millimeters per million years, as do hydrogenetic nodules as well. This is a new map of permissive areas, mostly occurring within exclusive economic zones. And it's the Northeast Pacific, just to name these, Northeast Pacific crust province, and the continental margin off of North America. The Pacific Prime Zone is the best known of all of the all the crust areas, and the 90 East Ridge in the Indian Ocean is moderately well known. Rio Grande Rise in the Atlantic Ocean is the best known, along with the Seamount Province in the East Atlantic Ocean. So In terms of the ISA holds 4 exploration contracts in this prime crust zone, and almost all of them are right over in the far West Pacific in this particular area. And let's see if I can get a better pointer here. Yeah, and over in this area of the prime crust zone. And yeah, and then there's one on Rio Grande Rise, and there's one in, uh, well, 4 of them in this area, and one in the Rio Grande Rise area. So this is a typical large geo from the West Pacific, and these are the types of structures that will be mined ultimately. This one is 56 kilometers long and has a large area above 2,500 meters water depth. And that's about the water depth from the shallowest part of a geo to 2,500 meters where crust will be mined. And that's the red and the orange part here. And this smaller map down here shows you the contract area for crust through the International Seabed Authority by China. And you can see the red areas here and down here are essentially the margin of the upper part of the geos. And this is generally where all of the thickest and best crusts are for potential mining. And so those will be exploration areas. And then part of those areas will be given up and some of it will be mined. Doesn't want to, let's see, will it go this way? Yeah, okay. This is a Jamstack Japan video. This is a flank of a seamount in the West Pacific. And these are very thick manganese crusts. This one here is broken, and this is about 20 centimeters thick through here. And they broke it off and sampled this particular one. This is a relative rugged seafloor. This is further up the flank of the seamount, shallower water, and it has a different topographic expression. So crust formation begins in the water column with iron and manganese colloids, and manganese oxides have a negative surface charge, and so they attract ions from seawater that have a positive charge, and they're incorporated in various ways into the manganese structure. Iron oxyhydroxides have a positive surface charge, and they attract ion complexes that are negatively charged or neutral, and they are incorporated in various ways into the iron oxyhydroxide structure. This is the simplified electrochemical model, which in fact it is a generality, and there are exceptions to this. One would be tellurium. Tellurium is usually associated with the manganese oxide, and that's because it occurs through co-precipitation, which has a stronger influence than the electrochemical attraction. So surface chemistry is very complex on these iron and manganese oxides. And these are the iron manganese oxides, and they can occur various ways with desorption and absorption, co-precipitation, and all of these. We're learning more and more every day because there's a tremendous amount of work worldwide going on using synchrotron radiation techniques to understand the incorporation of metals. Every metal has to be looked at differently or separately, and how they're incorporated into the structures here. We just did some work with thallium with the French scientists, and every metal is very interesting, and always finding surprises about how they're situated within these structures. So crust in the global ocean, looking at the prime crust zone in Atlantic Ocean mean composition, Indian Ocean mean composition. Manganese is the highest in the prime crust zone, cobalt's the highest in the prime crust zone, and so is nickel. For other metals in the Indian Ocean, for example, the rare earth elements are highest of the 3 groups. So these are some of the critical metals that occur in abundance in ferromanganese crusts. And some of them are quite rare, like scandium and tellurium. Tellurium is the highest of any deposit on Earth in ferromanganese crust. They average about 50 parts per million, 50 grams per ton in global ocean. Now, this just shows one being collected. This is where it was attached to the substrate rock. This is what, if you cut that in half, this is it. Started growing here 70 million years ago and was growing when we collected it. So seafloor massive sulfides, they precipitate from hydrothermal fluids up to 450 degrees centigrade at extreme variety of depths. Gray and black smokers are mostly composed of iron sulfides and sulfates, and deposits rich in copper are the ones that are great economic interest. The dead systems are of the greatest exploration interest, and vent fields are hydrothermal. They die and come alive on a regular basis. So this is the distribution of vent sites throughout the global ocean in spreading centers and in volcanic arcs. There are 3 ISA contracts in the Mid-Atlantic Ridge up in this area, and there are 4 on the central and southwest Indian ridges. There's soon to be a 5th one in the Indian Ocean, I think up in here, that India is about to get. So India will have 2 sites in the Indian Ocean. Basically, the principle of hydrothermal circulation is seawater goes along fractures and heads towards magma chambers and heats up, and then also acquires chemicals from the leaching of the volcanic rock. And with the fluids, these fluids that go down are returned because they become buoyant due to heating up. They can become, as they move back toward the seafloor, they cool by conductive cooling. And if that happens, you get under different temperatures, white smokers, lower temperature, and black smokers, higher temperature. They can also cool by mixing with seawater. And in that case, normally you get diffuse flow fluids, less than 120 degrees centigrade. And in all of these different areas where hydrothermal systems form at the seafloor, they have their own different biological systems. So these are some chemistry. There's a lot of different areas that hydrothermal sulfides and sulfates can form. The highest zinc concentrations are over 18%. Highest copper are over about 13%. They're about 13%, and high lead to 10%. But the precious metals are really amazing. They can be for silver in this type of deposit under continental rift, 1,000 grams per ton or parts per million, and gold can be up to about 15 grams per ton or parts per million. Very high concentrations. So these are essentially copper, zinc, gold, silver ores. And they can also have these other rare critical metals in various areas, more so in volcanic arcs rather than spreading centers. Yeah, some tonnages. We're going to look at some tonnages in comparison with land-based. These are our maps that I showed earlier. For polymetallic nodules, there's about 55 million square kilometers of area that they occur. And for ferromanganese crust, about 39 million square kilometers. Together, it's almost 95 million square kilometers of area. Now, nodules comprise, in terms of tonnage, about 210 billion tons, and crust 930 billion tons, dry tons. And they're obviously a major resource for critical metals. If we look at the crusts and nodules, we can calculate the tonnages through the global ocean and get these kinds of values: 219 billion tons and 227 billion tons for manganese, etc. Cobalt, 5.15 billion tons, and rare earth elements, 2.35 billion tons. If we look at those in relationship to the identified global terrestrial resource, which are listed here, for example, manganese would be 5.2 billion tons. So it's 44% more abundant in the deep ocean deposits than it is in the identified global terrestrial resources. 9 times greater for titanium, 206 times greater for cobalt, and 16 for nickel, 6 for rare earth elements. The different one is for the land-based is much higher for copper. And it's also much higher for lithium and bismuth. But generally, all the rest are higher in the deep ocean than in the terrestrial global resource. Thallium is 209 times higher. I don't have the numbers here for tellurium, but tellurium is 650 times higher. So key findings of the new work that we've done on the global distributions is that hydrogenetic nodules cover 75% of the permissive nodule areas. Mixed origin nodules, the ones that are looked at in greatest interest for mining, cover only 22% of the permissive nodule area. Diagenetic nodules, 3%. So whichever is mined, this all determines actually, which determines which associated elements will dominate on a global scale. The tonnage of crust is 4.5 times higher than we previously estimated, and it's a larger repository for manganese than is nodules. So resources of the future and challenges. Just to give you an idea, if we mine for manganese nodules, what's the size of the area that will be mined? 25-year mining operation would take about 25,000 square kilometers. And if all 19 ISA contracts were mined together, that would equal 475,000 square kilometers, which equals 0.86% of the entire global nodule permissive area, or 0.13% of the global ocean seabed. And that's over a 25-year period. Of course, this will never happen. All 19 will not start to mine at the same time, and it'll take very, very long time for more than a few mine sites to start operation. But this just gives you some kind of a scale of what we're talking about in terms of mining. So what's left over, after a 24-year mine site of 19 contract areas would be 950,000 square kilometers. That's 98% of the nodule permissive area. Plus, there are set-aside areas and unmined areas within each 25-year mine site. So it's really these numbers, this number and this number would actually be even a bit smaller. So the mined area is less than 2%, unmined area 98% global nodule fields over 25 years. So challenges for deep sea mining. Social license for seabed mining is a big one. Transparency is key for social mining, for social license acceptability, and sufficient understanding of ecosystem is key. And expanding funding for scientific research of environmental impacts thereby would improve transparency on understanding ecosystems. Improved engineering for mining, environmental safeguards, and elimination of sediment plumes. Engineering plays a big factor in making this environmentally safe. And I'll just mention something about that in terms of sediment plumes. Sediment plumes is always considered the #1 issue with mining of manganese nodules. Durability of mining tools, robots, underwater temperature, high pressure, high saline conditions. The durability of mining robots is unknown. We really won't know if they're durable enough to make this a business or not a business once they get started. Development of green metallurgical processing technology with a low carbon footprint is a key opportunity for developing these deposits. Mining and ore transport ships should have a low carbon footprint, and there's a lot of people, engineers, working on this today. So hopefully that will manifest. Key nodules key nodule collection without disturbing the sediment is absolutely key to acceptable mining of nodules. There's 3 companies that are working on technologies to do that. The one that's most advanced right now is Impossible Metals, and they have these machines that will pick up the nodules one by one, and artificial intelligence will tell them not to pick up the nodules with biology growing on them, and also not the nodules surrounding that biology. There will be dozens of these machines picking up nodules one by one, and each machine has lots of claws that will pick up the nodules and put them in storage. And so there's dozens of these, and one of the issues of doing this is that these will be continuous mining operations, because if you have 24 of these, 24, 25 of these going around, one breaks down, you pull it back up and fix it, you still have a big nodule operation going on. If you have a big crawler on the seafloor or two big crawlers on the seafloor and one breaks down, you have to pull it up, you lose your business. Pretty much your business is then non-operational. So this has not only the advantage of not disturbing sediments to a great degree, it will still disturb them a little bit, but it maybe have an advantage with the durability of the mining operations. So there's a lot going in right now looking at vehicle design with artificial intelligence, machine learning, deep learning, and all of this AI use. Mining without a sediment plume is key to environmental acceptance. Leaf nodules without biology, or with biology. Thank you.
Thank you so much, sir. Thank you. The session is now open for Q&A. Any questions or queries from the audience are welcome.
Dr. Hain, it was a very interesting talk. I just want to know, how did you measure the growth rate of the nodule as well as the crust? What methodology was the most appropriate you find?
Oh, I think for thin crusts, yeah, so there's many different ways to date them, but I think radiometric dating for thin crusts is really valuable. I think uranium lead has not been used much, but I think that's a really good technique as well. But yeah, beryllium isotope, if you have a thin crust, is probably the best way to go. Uranium series is if it's a very thin crust. If it's a very thick crust, you have only a few options, and they're all rather long options. And osmium isotope is, at the moment, is the best way to go. But you can also do it through paleomagnetics and through biostratigraphy. And the Russians have done a lot of the biostratigraphy, and the Japanese have a lot of the paleomagnetic dating. So generally, it's been osmium isotopes and beryllium isotopes have been the two key ways to do it. There are also some equations that have been derived to date them, and Halbach in his group designed one, and Frank Mannheim in his group designed another. Frank was with the USGS at the time. And so those equations are commonly used because it doesn't take any equipment, it doesn't take any special knowledge about doing beryllium isotopes or osmium isotopes. So a lot of people do it, and it's really kind of it's definitely it's got rather large error bars on using those techniques. I think the Mannheim equation is best because Frank Mannheim used a very large variety of manganese and iron manganese samples to create that that equation, whereas the Halbach one used just the marine manganese crusts and nodules. So Mannheim has, I think, a lot for, particularly when you're dealing with hydrothermal things, it really works a lot better. And so, yeah, that's pretty much it. There's some new techniques coming out in terms of radiometric dating. And looking forward to seeing those used more often.
Thank you. Yeah.
Any other question?
We have a lot of people connected online
Online.
from different parts of India. If we can just, because of the time running up, we can allow one more question.
Sir, behind you.
Very good morning, sir. It was a very insight to the polymetallic nodules what you have taken us. So in India also we have found the polymetallic nodules from the Andaman Sea as well as Lakshadweep Sea, but you are facing difficulties in some kind of exploration and resource estimation because these nodules what you are occurring in the Andaman Sea has a periodic occurrences on the sea mounts within the hard substrata, whereas in the Lakshadweep basin you are finding within as a hydrogenetic they are well within the sediment filled areas. So how can you approach, like for Lakshadweep we have to carry out a different approach, and as well for the Andaman so you have to go for a different approach. So can you please enlighten us how to move forward and to bring out a correct resource position so you can go for further exploration in that area?
Yeah, I mean, always the issue with the manganese nodules is what's the best way for exploration? Is there any mechanism from the ship itself that can map manganese nodules? And some of the technology is getting a little bit better for doing that, but generally it just requires. I think the best way to go would be with a fleet of AUVs that map the seafloor in great detail, and then you get a really good distribution of nodules. I didn't quite understand the first thing you said. I think you said manganese nodules were in the rock itself. In other words, it's
Yes, sir.
some stratigraphic.
In the
Is
Andaman
that
Sea,
correct?
you are getting the nodules above the sea mounts, sir, within the hard rock.
Sitting on hard rock.
Yeah, yes, sir.
Sitting on hard rock. Yeah, that makes it a little bit more. You're not going to be so there's not going to be so much contrast. I've read most of the work India has done on the Andaman Sea because I've always been interested in that area. So I know a little bit about what you've come across, and I think it's not much different for the most part in the exploration that's been done in other areas. But the Germans are doing a lot of really detailed work using swarms of AUVs for detailed mapping, so you really know absolutely precisely what kind of a resource you have in an area. And I don't know if that's available or not to be used in the Andaman Sea, but it's something you might think about.
So whether you can say some how these within the hard rocks these nodules can form, because what in the Andaman Sea you are finding these are the cores are having much more thickness. The core thickness is more compared to that of the crust.
Uh, so they're not crusts, they're actually nodules sitting on hard rock. Um, I would have to see a cross section of the nodule. What does a nucleus look like compared to
Yeah, yeah.
the iron manganese
Nucleus is
structure
mainly
around?
basaltic, sir. Basaltic to andesitic, the nucleus is there. Nucleus is mainly basaltic to andesite composition is there.
Is it big? Is it big relative to the oxide layer?
Yes,
Or
it's quite big. The core is quite bigger compared to the outer
yeah,
layers. Yeah.
that's typical of seamount type nodules. Seamount type nodules always have a very large. Really, that started as gravel on that hard rock surface, and then the manganese accreted around the gravel. And yeah, we see that a lot on seamounts, and you seem to be finding it on a ridge or something like that. Yeah, I don't know. Those aren't going to be very, I think, prospective for mining because there's too much rock to crust ratio, and you can't dilute the ore with the substrate rock or the nucleus material if it's a big rock nucleus. So I don't think those will be very prospective. Excuse me, for mining.
Okay, sir. Then thank you. We'll be in touch.
Mhm, mhm.
Thank you, sir. Thank you for enlightening us with your knowledge and expertise, and also for gracing us with your presence on this auspicious day. Uh, Sir, we are
Thank-
closing this talk now, and we'll
Okay.
move on to our next segment, We now move to the second plenary address of the day by one of India's highly respected individuals, Professor Subimal Ghosh from Indian Institute of Technology, Mumbai. Professor Ghosh is currently serving as the head of Center for Climate Studies and an institute chair professor in the Department of Civil Engineering, IIT Bombay. His research interest includes hydroclimatology, regional climate modeling, and understanding of Indian monsoon and its variability, mesoscale hydrological modeling, water resource systems, urban climate, and simulating land surface feedbacks to climate. He has more than 150 journal publications and is a fellow of the American Geophysical Union, National Academy of Science India, and National Academy of Engineering. He is a recipient of several prestigious fellowships and awards. Today, Professor Ghosh will be sharing his valuable insights on micrometeorological memory and pulse reserve dynamics of vegetation carbon uptake across scales. Professor Ghosh, we invite you on the stage to proceed with your plenary address.
Yeah, we can do that. I mean, anything is fine. Pointer, 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 pointer. Okay, okay, okay. Then I'll use my hand. Yeah, it's good as. Oh, pointer is then it's it will go this way. It will be no slides. Ah, no, no, that's fine. It is not working. The point, it's not pointing anywhere. That's okay. Point करने के point करने के लिए इधर ठीक है अच्छा ठीक है Good morning. I'm really honored and humbled to be present in this very important event, as well as to be invited as a plenary speaker for this event. I'm really thankful to Professor Ghosh for inviting me. Professor Ghosh requested me to give a talk more related to critical zone observatory, and I work mostly in the area of land and atmosphere. So essentially, this is the intersection between land and atmosphere, where we try to understand how land and atmosphere really impact each other. So that's sort of the thing which we normally do. Uh, so let us start with the very basic definition of critical zone observatory. Since I work in the area of climate, water, so we have to really deal with the global scale. But you know, but since my background is in hydrology, so I do not really cover on global scale. We take information from global scale, but try to look at river basin scale what's happening, watershed scale what is happening, and so on and so forth, and try to understand the physics, try to understand the processes, and so on. But what is very important is that when you are talking about water or hydrology, it's essentially the water cycle. It consists of subsurface, surface, atmosphere, biosphere, everything. And if you have to really understand the processes, since there is huge diversity in terms of land use, land cover, in terms of geology, in terms of everything, literally everything, in terms of human impacts and so on. So what is needed is that for understanding processes, we have to get the signal properly, and for that purpose, we need very specific focused uh, observations at a specific locations. And for that purpose, the new science which came up, of course, it's quite some time, the critical zone science, which explores how landscapes really evolve on Earth's surface. So it starts from below surface to trees. So that was the idea of critical zone observatory. But after that, it has been realized that it's not just the top of the vegetation, because vegetation also reacts with atmosphere. So essentially, there is no limit in terms of the vertical length. You cannot really stop at a specific location. A proper critical zone observatory should cover as much as possible. So let us try to understand from the land and atmospheric science point of view why critical zone observatories are really needed for the upper part as well. So if you look at my area, the area in which I work, I mostly work in the area of land atmosphere interactions. Sorry, this pointer is somehow not working, so I cannot show it, but it's essentially land atmospheric interaction. The first figure, which where you can see is that it's a very complex phenomena. It talks about energy cycle and water cycle, so it's a bit complex phenomena. And of course, we have been trying to understand what exactly is happening in land atmosphere interaction over last few decades. Then we need to understand. Or other Yeah, and then when it comes to carbon cycle, it adds lot of complexity to it. So it's really a complex phenomena. But the good part is that the scientists globally have really understood how complex is it and how important is it. And you can see a series of high impact publications which came out. But the first one came out quite some time back in 2004 by Costa et al. In Science, and it was mentioned that there are multiple land atmospheric hotspot, essentially where from land there is lot of atmospheric feedback. One of them is of course Amazon region, which is well known, but the other one is Indo-Gangetic basin over the Indian region, which was, of course, that finding came out, but even after that there was not much of attention from Indian climatic community to really understand land atmospheric feedback, because understanding of Indian climatologists was mostly between ocean and atmosphere. So land was kind of neglected, but since 2014-2015, then there has been a realization, yes, land atmospheric feedback is very important. But if you neglect land atmospheric feedback, you can see there are overestimation of UFO transpiration. There are a lot of issues, series of issues which can come that will really result into wrong finding, or sometimes uh, 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 you know incomplete understanding about the processes. Now, this is the paper which came out just yesterday. Yesterday night it was published in Nature Reviews Earth and Environment. Today morning I was just, and in the airport I was looking at it, and then I found that this paper just got published. And this is very interesting thing. The first thing, what are you talking about is eddy covariance network. So essentially the part of critical zone observatory that takes care of land atmospheric feedback, that measurements are through eddy covariance network. And if you look at this, you can see that from 1970s it started, and this is 2000, around 2000 this was the number of eddy covariance network. This is about 2015, and very recent 2025. Now you can see that number of eddy covariance sites that is now contributing to the FluxNet, the global network system, that has significantly increased. Of course, over India now there are few networks. So it shows that number of eddy covariance sites are increasing because of the growing importance of land atmospheric feedback. Now the question is that how can you really use them for understanding better land atmospheric feedback, and what are their need. Now, when you are talking about water and carbon cycle, this is extremely complex. But if we really want to represent in a very simple way, it's like this. We know that anthropogenic climate change is happening. So carbon dioxide concentration is increasing. That results into increase in temperature. That result into increased atmospheric water vapor demand. That results into increased evapotranspiration. Rainfall has been little bit irregular. So that results into heat stress on the plant, and then finally loss of land carbon sink, and this has a positive feedback. But at the same time, with the increased carbon dioxide concentration, what happens, that is known as carbon fertilization, that results into increased photosynthesis, and that results into more carbon dioxide absorption. So essentially how really vegetation balances both of them and what will be their resultant under a change scenario is a big science question and a big point of debate. Of course, climate scientists have run different models and they are finding that yes, but at the end of the day, because of positive climate feedback, because of atmospheric aridity, there will be problems. But let us try to understand. Now, when you are talking about water and carbon cycle, so if you look at it, you will see that in the last decade, there are I'm just showing four, that there are plenty of nature and science papers that came out only on this specific point, what exactly is happening because of land atmospheric feedback, how temperature is reacting with vegetation, how water is reacting with vegetation, how is it affecting atmosphere and the entire processes. So one of the work which I'd like to highlight is this one, the second one. What it said is that if you are talking about carbon growth interannual variation. So they say that when you are talking about trend of carbon dioxide growth, it is driven by carbon dioxide emissions. But if you take out the trend and if you take the interannual variations, it is driven by vegetation photosynthesis. So essentially how much vegetation is taking the carbon dioxide over the land. And now what they have found is that then they checked with the GRACE data of total water storage, and they found that there is a very strong correlation, negative correlation, and they said that okay, total water storage is actually controlling everything related to carbon growth rate. So we wanted to revisit this thing, this specific nature paper, because we found there are major limitations. The first limitations is this one: correlation is not causality. We know this, that correlation does not really tells us about causality, but we still use it, and those nature papers, almost all of them, used correlation as a measure of causality. And the second one, which shows the importance of critical zone observatories, is that global findings are not always true at local scale. For example, if you are considering trend in the gross primary productivity over India over the last 20 years, you will see that what sort of variations we have. So there are uncertainties across space, and correlation is not causality. So first let us try to understand causality. So when we talk about causality, that means we are trying to understand if we have a multidimensional system and we are trying to understand if X really causes Y or not. That's the hypothesis, or that's the question we are trying to address. How can we do that? One thing is that we can do experiment, we can increase or decrease X and find out what are the impacts of Y. And there are social experiment which was done like this, and one of the very famous social experiment which was done was by Dr. Abhijit Banerjee, Professor Abhijit Banerjee and Professor Esther Duflo. Of course, they got Nobel Prize for that. That is randomized controlled trials, and their paper was in Science. But that sort of things are not possible for our art system scientists. We cannot really do that. The other one is really perform numerical experiments, but we have to assume that we have full understanding of the physics and models are representing those physics. There are other methods which are data science based methods. One of the method, of course, we have there have been significant uses of that method is grandeur causality. So essentially it tells us in a linear framework if the information from X really improves the prediction of Y in the future. So that means past of X, is it improving the prediction for present X, present Y, and that tells you X causes Y. And then there are further methods. One of them is there is a group by Jacob Runge. So what they have done is that they have done a significant number of papers, and they developed a very good model which is known as Peter Clark Momentary Causal Inference System, PCMCI, and that method has been widely used because that method tried to address many of the limitations which were existing, but of course there are assumptions. So if you are looking at causal discovery approach, just a quick review. The first one is grandeur causality. In a linear framework, we are trying to find out if past of X is improving present of Y. And the second one is entropy method, which is information theory based approach, which is based on Shannon's entropy. So let us say if you are considering this is X and this is Y and this is past of Y. So what we are trying to understand is that the part of Y which is not driven by the past of Y, how much X contributes to that. So that means that much causality is causal information is coming from X to Y, which is known as transfer entropy. The third one is PCMCI, which is for multidimensional, where first method is Peter-Clark method, where it tries to shortlist some of the variables, and the second one is that they try to find out what is the causal influence of a specific X conditional on Y, conditional one past of Y, and other shortlisted variable. So it is more like a multidimensional approach. So there are methods. And when we applied that, what we have found is that what that Nature paper found from correlation based approaches are not really coming out of any of the causal approaches. So none of the causal approaches really support that total water storage completely controls the carbon interannual variations of carbon growth rate. But then we started, this was done by one of our former PhD student, and then we started asking, okay, how robust are these causal approaches themselves? Let us try to understand. So before that, of course, we did some regional variations, and what we found is that except tropical evergreen forest, none of the regions really shows that total water storage has a strong direct causal influence on the carbon growth rate. Then what we did, we found that even causal algorithms are not robust. For example, if you consider 4 independent random variables normally distributed and then apply this kind of causal approaches with a sample of 100, you still get some of the spurious links. Then what we tried to do, we tried to divide the sample into subsampling approach, and then from each subsample we try to find out the percentage appearance of different causal links, and based on that we have developed a statistical index known as cust index, some spuriousness index. And then when we did that, what we are finding is that, what we have found is that this approach is able to identify the correct links. That's the first thing. Second thing, what we did then, before applying any of the approach which is available, we wanted to test it. So we have considered more complex nonlinear dynamic processes for, or systems like Henon to Henon system, Rossler to Lorentz system, and so on, and we found that this method is working well. And then again we applied, and we found that yes, it is not coming. Total water, you can see TWS to CGR, there is absolutely no link. So what we have found is that we have to be very careful when we are doing any kind of, based on correlation, if you conclude anything, we have to be very careful. The conclusions may not be robust, and for this Nature paper it's like that. Then we applied it to India, and what we have found is that for India things are even more complex, because when you are talking about total water storage, if you are just considering soil moisture, which is small part of the total water storage, of course when monsoon rain happens, the shallow rooted cropland takes that water, and that their photosynthesis is getting affected. But when it deeper soil moisture, what happens is, deeper groundwater, what happens is that you are doing pumping, groundwater pumping, and then apply irrigation. That helps. If there is no groundwater pumping, that there will be a different kind of condition. So essentially it is driven by the human land water management, which makes it even more complex, and that needs even more finer understanding. So what we started doing is that, thanks to one of our collaborator, Dr. Sandipan Mukherjee, who is from GB Pant National Institute of Himalayan Environment, we started working on one of the flux tower which is there in the pine ecosystem over Almora. When we started doing, of course, what we have found, we wanted to work at a very high resolution temporal scale as well as spatial scale. Of course, it's a local scale. The temporal scale was 30 minutes resolution. So we wanted to see that if you are considering weekly variation and 30 minutes variation, how much this 30 minutes variation is contributing to weekly variation. And when we did that, what we found is that for many of the variables it's quite significant, it's 30 to 40%. So essentially if we really have to understand low frequency variations or even weekly variation, we need to understand what exactly is happening even at a diurnal scale, even at hourly scale or sub-hourly scale. So they do matter. And then when we started looking at it, what we have found, so I'll explain a little bit about this, the way we are doing it. So there are 3 indicators. One is net ecosystem exchange, which is the carbon exchange. This is the respiration of the plant, and this is the latent heat flux, that is the evapotranspiration. And these are, and below hemisphere are the meteorological variables. This shows that how each of the meteorological variables are sending causal links to the upper hemisphere, which are the plant variables. And so of course these are complex, but one of the most important part what we are finding is that during the dry season, dry period, number of links are more, because under the dry season the plants are under stress. Why is it happening? For any natural system, what happens when it is under stress, what the system tries to resist the stress, and while resisting the stress they create more number of links, and this is what is exactly happening over this. You can see that more causal links are getting generated. In fact, I always give this example to my students that, let's say you are crossing a river, a mountainous river. If there is not much of current, you can go alone. You can alone cross the river. But when there is so much of current, you hold each other's hand to cross the river. The nature also works like that. And this is what we have found from this. And then we further checked, you can see that these are essentially monsoon time, where the stress is not that much. You can see that number of links are quite less, and you can see huge number of links are generated even September, October, November. And if you compare dry and wet weeks of September, October, November, you can see that dry weeks even have more number of links. So that shows that how micrometeorological variables are actually impacting the vegetation phenomena. Then we wanted to test another one, which is Sundarban forest. NRSC, National Remote Sensing Center, has a flux tower over the Sundarban mangrove region, which is a very unique flux tower. And we have got 2013 to 2015 flux tower data from NRSC, and we wanted to see, because we have a collaborator, Dr. Punnaslok Bhaduri from ISAR Kolkata, and he has been really measuring the pollutant concentration over this region, and what he has found is that in this 2013 to 2015 there has been significant increase in the pollutant. But if you look at the NE, that is the net ecosystem exchange, that was not impacted that much. So essentially we are trying to understand how did the Sundarban mangrove really resist that pollutants. You can see that how the pollutants have increased. You can see ammonium N by P ratio. So this shows that over the 3 years how the pollutants have increased. Then what we have found, this is true, we have found it over many other months. This is just for 1 month. What we have found is that when you are considering the highly pollutant months or highly pollutant years, what it actually generates more meteorological links. It is very interesting, and this was the mangrove forest. They need to investigate in more details, but what we have found is that if you are under stress, under pollutant stress, they are generating more number of links with the meteorological variables. They are creating more memories with meteorological variables to continue the photosynthesis, to maintain the photosynthesis, which was a very interesting thing. So of course it needs more investigation. Then we started with global, we went to local. Now we are trying to understand from local, can you really say something about global findings. So this is one of the very recent paper which was done by two of my students, Lina Khatke and Akash Verma. So what they tried to do, they tried to find out transpiration measurement over the plant. These are essentially sap flow measurements. Using sap flow measurements they can do that. So these are essentially the sites, sap flux net sites, which contributes to the global data set, and we picked up all of them, and we first tried with Delhi data. And what we have found is, this is something interesting. What we have found is that more than soil, surface soil moisture, the vapor pressure deficit is contributing more to plants evapotranspiration. So they are becoming more important than soil moisture because of increased temperature and also because of increased vapor pressure deficit. But remember, none of them really none of the sites are from India. So for India it's a different thing, which I will show. Now what we tried to do, we tried to understand the micrometeorological memory up to productivity using flux net products. So essentially whatever I have shown you, a recent 2025 paper where how different sites are contributing to a data set which is known as flux net data set. And to this flux net data set, when we applied this kind of transfer entropy and unique information, we are trying to understand if one variable is sending unique information, unique causal information to another. So let us look at this figure. You can see that how if you consider unique information that to vegetation productivity, that is coming from soil moisture, and unique information of GPP that is coming from vapor pressure deficit, and what we are finding is that most of the regions which are not really monsoon dominated, there the soil moisture plays, there the VPT plays a major role, but over Indian kind of regions, their soil moisture plays a major role. So essentially in monsoon regions, in the regions where which are mostly agricultural dominated, there soil moisture is very important. So for Indian region, land atmospheric feedback is important. For other regions, the atmospheric aridity plays a major role. And then of course what we try to do, we try to understand how. So essentially, if you are considering soil moisture vapor pressure deficit, they are also not independent. There are always connections between them, because high vapor pressure deficit means high evapotranspiration, soil moisture will reduce, and low soil moisture means low evapotranspiration, high vapor pressure deficit. So essentially it's a chicken and egg problem, but we try to understand that, which, if you are really modeling something, because we are now talking about AI, ML, data science algorithms, we need to understand these causal structures to understand how much memory you can look back to really develop a good model, and we found that both the memories are really very important. Then finally, the last part of the work, which is pulse reserve. So what we have talked about, it's more like over a longer period of data set, and we are trying to understand the causal thing. But this is something what is very important, because in Nature Plant, in 2019 there was a paper which came out. What it tells you that when after a rainfall, when soil moisture drops, the plant tries to store the soil moisture within itself in terms of vegetation water content, and because of that their vegetation productivity can be maintained, but after that the vegetation water content will drop, and this is known as pulse reserve, reserving the water pulse that is coming. So it was earlier believed that it is only there for arid region, but these are the people who said that this is there for all sorts of vegetations, and they have tested over the North America and Australia, and we tried to understand with the help of NRSC that is it there over India, and we found that even for Indian region this kind of pulse reserve concept really exists. We tried to segregate the rain fed and irrigated region, and then over the rain fed region we tried to find out, and we found out it really exists. But the most important part, then what we tried to do, we tried to again look back to the eddy covariance sites and trying to find out whatever they have got from satellite data, are they true at the eddy sites. And what we have found is that yes, they are true. Being it a mesic ecosystem or dryland ecosystem, everywhere this kind of adaptation of vegetation really exists, and whenever there is a pulse, vegetation tries to reserve the pulse so that they can produce better photosynthetic activities. So what I'd like to mention is that we get a lot of information from satellite models and so on, but final validation at different scales are only possible at critical zone observatories through eddy covariance sites and so on, and that's why that shows its importance. And and very recently Ministry of Arts Science of course has taken an initiative with Bharat Flux that will really bring all the flux sites together for a better data repository, and that will be really useful to understand many processes. So finally, in the summary, I'd like to mention that if you're looking at Earth system science, this is essentially blocks of systems which has subsystems, and they are all connected by links, and if there is a perturbation in one system, these perturbations get traveled through different parts of the system. And of course, but this has a serious implications in the sense, like if you are considering the present way, the way we look at the impact, what we do is that if you consider state versus stress, what we consider, we do not consider the feedback in a proper way. So whenever there is a stress, the system starts breaking. But in real system, what happens is that whenever there is a stress, the system will try to generate more number of links, which we have shown here at different eddy covariance sites, and it will try to resist. So it will go like this, and we will not be able to really see the uh, degradation of the system. But at some point of time, none of the link really resist, the whole system breaks down, which is termed as tipping point. We haven't seen the tipping point properly, but this is the real Earth system looks like this, and we have to understand this probably through more number of observations and more number of data science approaches. Thank you for your attention, and if you have any questions, I'll be very happy to answer your questions. Yes, yes.
We know the geosphere is also one important part of the critical zone, the geosphere.
Yeah.
And like when we are constructing or understanding the present day critical zone processes, we need to also know that how the past geosphere has affected the, or how it has helped to build the present critical zone. And there I want to have some, elaboration on that. Then when we are doing that, how much past we need to go to see that what was the geosphere at that time? Is there any like specific thing to that? Okay, we'll go up to only this time or behind that.
Okay, so if you have to really use any kind of causality approaches, it's very difficult to go beyond a certain time period because you have limited sample, and because of dimensionality, because you are essentially considering a system which has huge number of dimension, so you cannot go beyond a certain period. But what we normally do, we do in a slightly different way. We divide the time periods into different duration, and for each duration we try to understand the causal links, causal systems, and we try to understand where there is a change. When we understand certain changes, then we try to investigate using physics or using our understanding, our process understanding, that what exactly has been the change.
So like cannot exactly quantify that, okay, these many years or this much, that period of geological history. We cannot do that like Holocene
So
or
it
whatever.
depends on, I think, the most important part is that it depends on how many years observation do you have,
Exactly.
that two continuous observations. So at a longer time scale it's difficult, but if you have reconstruction, on the reconstruction you can still apply this kind of causal approaches with a caveat that yes, of course, they have their, this data itself will have their own uncertainty.
Thank you. Thank you, sir.
Thank you. Yeah.
Dr. Ghosh, is an excellent presentation. I just want to ask you a completely different perspective one question, because Delhi NCR is really very much affected by the pollutants and the particulate matters. So how your research on land and atmosphere interactions can put some solutions to these sort of problems, because what we have seen that Beijing is also having this sort of problem, and they have taken a lot of steps to get rid of this. So you have done a lot of good research on this land and atmosphere interactions. So is there any solution to this problem? Because in one point of your lecture, there was one research work where you have found that some of the flux put in the Sundarbans are also recording a lot of pollutants. So that is a very serious concern for all the mega cities and the metros. So if this research has some light to save the the metro cities from this sort of problems.
Yeah, so it's a complex problem. So I do not really work in the pollutant area, but there are people who are working those who work in atmospheric chemistry. What needs to be done is something like this. Let's say you can use Lagrangian approaches to really track the aerosols, from where the aerosols are coming or from where the pollutants are coming. So first thing is that we need to really understand what are the sources. Of course, we I mean, it's well known that it's a crop residue burning, etc., but we have to prove that. The second thing is that what sort of solutions can be given at the sources. I mean, just asking them to stop crop residue burning may not solve, but we have to, I don't know what is the solution. It's a social problem. It's a economical problem, social problem. It's slightly different problem, but is there any way by which the farms can be made ready using newer technological approaches, so that they don't have to really burn the crop residues, and at the same time that will be economically viable. They can really, of course, they need have to afford it, or we have to show that they are they can be easy, that can be easily done. That's the second thing. The third thing is that what we have heard, I'm not sure if it is true or not, there are some satellites which passes around 1:32 p.m. over that region to really understand that if there is any crop residue burning, etc. And somehow some of the farmers, they are very sharp, so they realize that it passes at 1:32 p.m., so they start at 3 p.m. So that cannot be detected. So there are issues, but we need to really use data and at the same time use technology to understand the problem at the source and solve the problem at the source rather than just cloud seeding and some other things which are being tried. So that's my opinion, but I can be wrong as well. Thank you. Okay. Thank you.
Thank you, sir, for this illuminating and thought-provoking presentation. May I now invite Shri LMS Mora, sir, Deputy Director General and Regional Mission Head to Western Region GSI, to kindly come up on stage and felicitate our esteemed guest with a memento as a token of our appreciation. Thank you, sir. Thank you once again. Respected dignitaries and esteemed members of the audience, we will now take a break for high tea for approximately half an hour. It is arranged in Convention Hall on the upper ground floor. During this interval, we warmly invite you to visit our poster session just across the hall and exhibition in the Exhibition Hall 1 and 2 in the basement. We have showcased a variety of fascinating displays presenting an array of insightful and engaging exhibits for you. Please reassemble in this hall by 10:30 so that we may continue with the day's proceedings. Thank you. ये मैं यहाँ पे रख
Check one, two. Hello, hello, hello. Hello, hello. Check. Check, check one. Hello, 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 hello. Check one, two. Hello.
क्या बोर्ड सब थोड़ी करना है लो ना
geoscience research. The keynote for this session will set the framework for understanding diversity in the Precambrian terrains of Northwest India. To guide this session, we are honored to have with us Dr. P.R. Golani, former Deputy Director General, Geological Survey of India. Dr. Golani is a distinguished geologist, widely recognized for his contributions to base metal and gold exploration. He is the author of the noted book Assessment of Ore Deposit Settings, Structures and Proximity Indicator Minerals in Geological Exploration. His research spans mineralogy and ore deposit studies across regions. Sir has also been involved in informing Union government in policy planning for strategic minerals. It is my honor to announce that Dr. Golani will not only be chairing today's session but will also be delivering a keynote address on the theme Diversity of Metallogenic Setups in the Precambrian of Northwest India. Our co-chair, Sri Sandeep Kumar Roy, Deputy Director General and National Mission Head 2 of the GSI, has extensive experience in polar and mineral exploration studies, including being a member of the 27th Indian Antarctic Expedition. He has conducted research on glaciology, ice sheet dynamics, and quaternary climate changes in Antarctica and Svalbard, alongside exploration for base metals, REs, and tungsten across central and western India. His work is reflected in numerous national and international publications. I now request Dr. Golani sir and Sri Sandeep Roy sir to kindly join us on the stage and preside over this session. May I also invite Dr. K.R. Ansari, Director, Geological Survey of India, Western Region, as the rapporteur to record the proceedings of this session. We now invite our keynote speaker, our chair, to deliver his talk. Sir, the stage is all yours.
Very good morning. Rajasthan is a very well-known place as far as the mineral deposits are concerned, and I believe that it's indeed never possible, I would say never possible to deal the wealth of Rajasthan, mineral wealth of Rajasthan to speak in 20 minutes or something like that. I must add one more thing. She has given a very liberal uh, opinion about my expertise, but I would say that I am basically a field geologist. I still feel like going to field and observe the rocks and try to understand. Now, as far as Rajasthan is concerned, knowing fully well that it is not possible to cover the entire Rajasthan, I have selected only southern Rajasthan, and within that too, I have selected four styles. The first being the granite pegmatites, followed by iskans, VMS type deposits, and lastly, something new in Rajasthan and always interesting in Precambrian geology, that is evaporite type setup. Now, if you see the entire nation, India, southern nation is known for greenstone belts, so also the eastern cratons. But when it comes to Rajasthan, which is comprised of Aravalli craton and in the eastern part it being Bundelkhand craton, it is essentially a sialic crust, but well tectonized and well metamorphosed. So we have all sorts of generations of melts, intrusions, and, but we have much less intrusions as far as the Archean terrain is concerned about the basic volcanic hosting greenstone belts, like in southern India or in eastern Bastar and eastern India. So here, being a shalic terrain, we have plentiful of granites. So I chose that it is better to start with granites. Now, mineral potential of granite and related pegmatites can be discussed in two segments, one related to pegmatites, other related to granites. I start with the granites. We have late Archean granites, but they have developed only the skarns, not the mineral deposits as such in Rajasthan. We have plentiful. And interestingly, some of the intrusive granites in Aravali supergroup, they turned out to be basements with new dating and with detailed geological mapping for which Geological Survey of India is known, as well as from academia. It has been found that Aravali Craton, Aravali supergroup rocks in southern India in type area are essentially boarded on a very shalic craton, very so no not much granite pegmatites are there in intrusion. So that remains a area of lesser interest. Now most important thing is that granites occur basically other than late Archeans, three ages granites are there. The one in the Delhi fold belt, it is Sindra Ambaji granite, that is 0.9 GAH. And the 0.9 to 0.8, the second being about 7.5 GA to 8, that is Edinburgh type suit. And one more thing, still younger granites that have come through geological mapping, not much dating is done on that, is that the basement formed by Edinburgh granites is for Punagar and Sindre type of rocks in the western Rajasthan, west of Delhi fold belt precisely. And in that one you will find that they are intruding that younger sediments, that is Punagar group. That means there is another third phase of granites. And if you see the three granites on regional map, I will come back again to that map. Okay. So this is the Delhi fold belt. It is a double fin shaped belt, narrow square being here. So one which is here, the granite says Sindra Ambaji is this one. It's the median part of the Delhi fold belt. And the other one at the margin is the very large profuse intrusions, what we call as Edinburgh type of granites. They are far more in abundance and from batholis. They are 0.75 to 0.8 GA in age. They are more prospective. And the one the granites that you are seeing here, Degana and around areas, Didwana, Degana and little to this one. They are very important granites from tungsten point of view and from lithium point of view. So these granites unfortunately are underlain by a vast alluvium of Thar desert, generally wind blown sand. So not much information is available. And if you ask me, I will say it is hardly 5% of the exposures which are with which we have made the map. So what do we do now? If this is the situation, we have done extensive studies in Degana. And yesterday, my younger colleague, Dr. Suresh Kumar, has presented his work. And before that, I feel proud to tell that this was one of the first deposit, low-grade deposit, which was worked in pre-independence of India. That is by Heron and other persons in Second World War, First World War, Second World War, and much of the mining was done there. Very little is left to see a good quality or good ore of tungsten. It's only float. That has also been, colluvial also has been excavated for that. So where do we go? We have to learn our knowledge from this place and apply where it can be used fruitfully. So this is actually the Degana granite. Yesterday it has been shown, my colleague has shown you. Most important thing is that there are intrusions, phyllites and quartzite sequence, which is younger sequence of Punagar group. They are intruded by granites in this portion, and you see breccia formation, you see granization, you see the load is mostly in the quartz veins, northwest, southwest trending, and sometimes it is north-south also. So these are the quartz veins which have been mined for tungsten, and hill is a very steep-sided hill. It's just like an Inselberg which stands out prominently in the vast alluvial tract. So here you can see the things and get knowledge and try to apply wherever little exposures are there. These are the field features. This granite, you see phyllitic portion, this is granite. So a breccia is extensively developed. It's a very forcefully injected type material, the phytomagmatic, something like that, which can be visible at different places. And potency of granite is often measured in respect of the merolitic type of activity cavities. So here you see at top, what you say as cupola or top portion, you see this merolitic features very often. And these are greasons. Lot of work has been done by on greasons and granites. So these things are generally towards the upper part of the exposed Inselberg type of hill in Degana. Now, when you see these veins from close quarters, it is almost at top of the hill. You see it is showing some arrangement. The top part, the central part is the quartz zone, and you see some specks of wolframite. It's not working.
Yes, it's working.
Okay. Is it okay now? Is it okay? So here you will see that it's a central vein is essentially of quartz, and the marginal parts are zinwaldite, mica, and then these are the greasons. So this is the anatomy of the lower type of quartz veins. This is a photograph I could get from one of the person who has done yes, somehow got hold of it. Originally the load was like this, wolframite type load. And then you see in the large parts of the photograph, you see several zinwaldite zone. That is absolutely almost at the top. So zinwaldite rich zone is there. And I would like to tell also that initially the work was done on tungsten. Lithium was what not known. Now that economics has changed, lithium is there in the form of zinwaldite, though it is a low grade. But it has revived the interest in a Degana type of granite. That's why I believe that it needs to be focused. There is one new work which I thought would be useful to part with first time I am parting with. Rajasthan state government has seen that this zone is infested with the skeletal fluorosis. So they conducted some programs for groundwater as well as for fluorine content of the waters. So this I could get hold of 62 boreholes in the alluvium, and I could get the subsurface geology of that by vertically projecting this. The projection which has been made is about 40 meters from the present surface, and the fluorine content has been done largely by Rajasthan Groundwater Department, Rajasthan, as well as by RF and others co-workers. I got about 40 analytical data from their paper. I plotted those data and then look what type of geological map we get in the otherwise a desertic plain. You see this one, Degana hill is only this much. I think this is, I would like to show it from here. This is Degana hill, solid one. And the blue is the borehole data, bedrock data. It is 40 meter to 50 meter down. So if you have a conservative estimate and then plan it top, it's a regional boreholes. So you can have a body which is much bigger than what Degana is known. So I believe that the potential of this type of setup is highly undermined. So what is next, more important even than Degana, I believe, is the area between Didwana, this is Didwana, and this is Degana, that is this granite. Here, the fluorine analysis are extremely high. This area, the water is not potable, you cannot drink it. So fluorine, as you understand from yesterday's lecture, and we learned from past references also, fluorine generally is contributed by fluoride. So if fluoride is there, and I am getting tourmalines and lights in the known occurrences exposed areas. So I have all the reasons to say that these two factors, occurrence of granite in conjunction with fluorine, high fluorine, is a very prospective area. So for me, it is not Degana we have to clamor over. We should go in between Degana and Didwana. Another very important thing, yesterday Dr. Catherine has spoken in clays and evaporites. You see, we have old maps in India. That is about 100-year-old topo sheets something. It was supposed to be a lake. This one was supposed to be a lake. This is much more difficult to operate. This is a lake. And now if you see the present sheet, only the southwestern fringe of the lake is water. Otherwise it is a dead lake. So sediments are fully filled in this one. This is a very potential area for clays, especially for lithium, which easily is leached. Among others, lithium is easily leached, and it gets combined with the clays and heterotic clays. I would specifically speak. Heterotic clays can be found in this one, and this is a very big area. This can be a deposit as well because the substrate, the lake is very big. So also, unfortunately, Nirvana has been drilled by 155 boreholes by AMD. Now, what happened? AMD was not, perhaps unmindfully, they never analyzed tungsten, they never analyzed fluorine. So that's why the database, which was grid pattern database on 200 meter by 200, I could only extract that what lies beneath the Didwana lake and the salt pan of Didwana lake. So here it is actually a 15 square kilometer is another solid granite. So this area, this granite, Didwana granite, in between Degana and this one, this small granitic, linear granitic one, these are the most prospective area. I believe that we have not explored our land properly as far as the concealed track is concerned. If concealment is to be addressed, this is the place where the country needs, because tungsten doesn't have any replacement so far. The properties of tungsten metal is such that so far there is no foreseeable replacement. So we have to focus on that. So with this, I come to pegmatite. Again, this is same figure I am showing because now I will be discussing about pegmatites. One thing, pegmatites are developed wherever the metamorphic grade is amphibolite grade type metamorphism. Otherwise, pegmatite do not develop. Secondly, they are to be influenced by the substrates, micasis and other things. Second point. Thirdly, the spread of pegmatites in this Bhilwara mica belt. This is one of the famous mica belt which has been worked in Second World War time, First World War time. This spread need not necessarily mean the orientation of the pegmatite bodies. And third important thing which I find from the literature is that pegmatites in Rajasthan are rarely more than 100 meters in size. And if you want to have a deposit, you ought to have a little bigger one. I believe Tanko pegmatite is about 500 meters. And so also the green bush pegmatite is about 1.5 kilometers at a stretch. So big deposits are to be found from the big bodies. Or we have to go subsurface to see the extension of concealed pegmatites. Now another thing is that this area is known only for, not for LCT type pegmatite, it is mica bearing pegmatites, cesium and beryl of course does remain with that always, but it is not a gem quality emerald. Beryl is associated with this one. Now what is most important is that as far as the lithium is concerned is the Delhi fault belt. Now look at there is one fault or lineament, now it is considered to be a fault. That's Kaliguman. K is Kaliguman. This is an emerald belt. And it's not merely emerald which we are looking now. We are looking for lithium. So this whole belt, whatever geochemistry is there, it is turning out to be LCD type of pegmatites. Okay. Now this LCD type pegmatites, lithium is developed, minerals are developed in the form of amblygonite, in the form of spodumene at Z1 mines, in the form of lepidolite. But since they are very small, so I don't think at this juncture we can say that they could be economically very significant. Nevertheless, the belt is very big, the area is very big to explore. Maybe someday we are able to strike a real good long pegmatite with all these minerals. I can show the location of lithium bearing pegmatites. This is Siroi. This one Siroi. This L is lithium bearing. Here also a full zone of lithium bearing pegmatites, including Z1 pegmatites. Apart from that, as yesterday it was mentioned in the inaugural speech, Rajasthan is Museum of Minerals. So most of the museum is influenced by pegmatite minerals. So what we see uranium bearing pegmatite, tantalum bearing pegmatite, bismuth bearing pegmatites. My senior colleague Dr. Das Gupta has found it bismuthite with a very high content of gold in Narada, as well as Dr. Parekh has reported from central Delhi fold belt, just west of it. So apart from that, we have emerald bearing. My colleague has worked extensively with shellage of BRGM, and we have a good report of that. And then you see, you go further to the west, then you get a tungsten bearing. So tungsten bearing things you get there. Now there is supposed to be a relationship between skarn type deposit and granite directly hosted by the highly differentiated granite. So Degana granite I consider highly differentiated specialized granites that I just spoke. Now I'll come to the skarns. I think the next is skarns. These are the minerals because it's a very nice place. Rajasthan is a very clear cut exposures are there. You see this is the typical mica bearing pegmatite. Mica is there. You see clevelandite, and you see tourmalines in this one. This is garnet within the pegmatites, and when it is emerald bearing, where Mr. Garkhal and his colleagues have worked along with the BRGM, you see there is a thin zone of phlogopatite rich zone. When it comes in contact with ultra basic rocks, a phlogopite zone is developed, and it is this which is the pay zone for emerald, good quality emerald. And otherwise, the ultra basic rocks, they show you magnesite development during alteration. Now this is the lepidolite from Shivgam area, Siroi, which I showed you in the map. And there are two incidences where gold wires are reported from pegmatites. One being from Seeker by my younger colleagues from GSI, and the other one is from, in British time, it was reported from west of Ajmer. And this is the Amazonite. Amazonite is again a pegmatitic body containing Amazonian feldspar. It's a lead feldspar. It's a direct proximity indicator of the mineralization. And we find that there's a relationship at our mineralized bodies. This occurs there. This is the map I was yesterday referring during interaction with Dr. Khetri. This is the very detailed work done. The only difference I have difference with the mapper is that the magnesite which is shown here in tremolating marble is actually the cap of the ultra basic body which develops tremolites very often. If a mapper is there working in ultra basic rocks, I have seen myself, you see a lot of tremolite, but when you dig it, you start getting green color of serpentine bearing things. So this magnesite is nothing to do with the pegmatite generation. It's antithetic. Now when you come to this portion, this is magnesite. Then I'll read it because this is from my paper. The lepidolite is this one. This fine dots is lepidolite, and tourmaline is of two types: elevated series tourmaline, wardite and indigolite. They occur here. Spodumene occurs in the central part, this one. This is your spodumene bearing quartz plagioclase muscovite pegmatite. And the granite per se is in the only in the this northeastern part. And what other you think? This is the barrel, squarish. This rectangular things are barrel. They are at the contact of two different types of pegmatites, notably the one being quartz, plagioclase, tourmaline, muscovite, and pegmatite without spodumene. Okay. So this is a very detailed map he has made on 1 to 1000. It's surveyed map, so accuracy is very, very high. This is done by our senior colleague, Dr. A.K. Datta. Now, skarn type. When we talk about granites, then definitely skarnization is to be addressed. It is again the Delhi fault belt. Delhi fault belt is known for median area. You see Sendra Aramco type of granites. And then you will see that this is the wollastonite deposit, one of the largest deposits in the world. About 5 million ton deposit is there. And apart from wollastonite, you see the typical skarnite assemblage, that is pyroxene, feldspar, pyroxene, garnet, and calcite bearing assemblages. So skarns are of three types. One is zoned, other is tabular, and third one circular. Now here is the map. You will see the regional geological map. In this one, this Pindwara area is very, very critical. In this one, it is this place actually, what we are discussing. And this is my younger colleague Khande. He has mapped it. It's a tabular skarn. You get all skarnite mineralogy, what you see in typical skarns. And this is the map. I've been permitted, thanks to Volcam India Limited, they have permitted to publish this map. You see the skarn zonation, zoned skarn map. So this is a granite, this is a garnetite, this is garnet, pyroxene, and calcite. This brown is calcite, and the one which is deep brown is actually feldspar, pure feldspar. So this is the map, and these are the mine workings, so I have avoided those things. But this is one of the finest, well-developed skarn, I would say, in the world. These are the pictures. Being a field geologist, I am always attracted towards good exposures. So this is the intrusion of granite in the calc silicate. This is the garnet pyroxene skarn with calcite down. Here it is the folded one. It is because the Sendra Ambaji granites are syntectonically placed. This is, if you see these rhombs, in the top portion, there are rhombs of clear calcite. Calcite is a very important member of skarn mineralogy. And here is what is wollastonite. This one is wollastonite. This is showing relationship with garnet and pyroxene. And this is the rafts within the granites. VMS setup, actually the very important thing is that the submarine volcanics should be there, and there should be some sediments as well. There should be period of quiescence. All those things we witness in this part of Rajasthan. What we see, the mesosulfides are of two metallogenic categories: copper zinc versus copper lead zinc. And my colleague is here who has extensively worked on copper zinc. Mr. Kemani has worked there. I was part of his team. And what you see is there are two tectonic zones. One is western domain, one is eastern domain. So in those zones, one is having copper zinc type mineralization, the other is having copper lead zinc type mineralization. The difference in the host rock is that one is photophyretic basic rocks, and the copper lead zinc is actually bimodal volcanics rift related. So lead isotope data also we have done. You find that the one with photophyrites are less iridogenic, and the one with the bimodal volcanics are more iridogenic. So it supports our field observation, field mapping, as well as the isotopic consideration. They put them on a right perspective, copper zinc versus copper lead zinc. This is the geological map, and the zones, western zone, eastern zone I was referring. This is actually the eastern zone, bimodal volcanics. This is Deri Ambaji area, and this is actually the western zone. This is the area which has given copper, zinc, gold, as well as recently, we are working in National Center of Excellence, Bangalore, about the critical elements, particularly selenium, indium, germanium. We have some good results, but it is too early to speak more about that. Let us work more on that, and then maybe that which is very common, because having more sulfur, 90% more, 90% plus sulfides we have found in Dhanwa, Ajari areas. So sulfur has direct connection with the selenium and other trace elements. If you have more sulfur, you can expect this one. In fact, the crystal abundance of selenium is dependent upon, is derived from the content of sulfides. Oh, what is most important is that it's a very highly magnesium alteration facies are there. This is my map. I have mapped in Delhi. So these are the coordinate zones, and then you see chloride biodate zone, quartz muscovite zone, felsic volcanics, least altered, and then basic volcanics. And metal donation, I feel proud to tell that this map was made before the metal donation was known in the economic geology and other things. One of our old colleagues, they faithfully mapped it. Our GSI people are good in mapping. They mapped it and found that there is a ratio of lead rich versus zinc rich. So this is one of the earliest map from Rajasthan, but we don't know the importance of that. Interpretation may be different, but the fact remains there is a metal donation in this one. These are the field photographs. The relationship, phenocryst ground phos relationship is there in the top one. You see chloride chloride zone. You see timolite zone. You see pinitized chloride, and you see dalmatianite when it is in contact with the gabbros and cyanitic intrusions. And this is another very unique thing I have never heard from other parts of VMS deposits. Being member of the global member of the IGCP 502, I could see that no one has described it, but this is a zone where we get two pyroxenes, OPX, CPX, and calcic garnet, and giving a temperature of 600 degrees centigrade, 75, 600. It's a very rare thing. We only see this one in this place, and it is not at one place, 200 kilometers away at Kalapar also we see the very same thing. These are the massive sulfide ores. The only place where we could say it is a stranger zone is this one, Pipla area. And this is the pepperite facies. These are the minerals we have got this one, and some minerals, rare minerals in VMS deposit with my colleagues at Center of Excellence. This is the last part of this one. Maybe I have exceeded a little bit more. I'm sorry for that. So this is a very, very funny map. It's a very interesting map. In comparison to other parts of Rajasthan, here you see it is host and gamma-like situation, host formed by basement, that is pink color. Then you see basin fills, then you again see basement, then you see basin fill, then again you see this one. So this is a zone of dislocations, primordial dislocation, first order dislocations that have developed these things. And these fills have been, these dislocations have been cross-cut, segmented by the cross faults, and you see a situation where lacustarine system is developed, and that eventually led to evaporites. How it is there? Let us see the I spoken. A very important thing which I have never seen any part of Rajasthan, linear bands of conglomerate, they keep on moving to 75 kilometers long, maybe beyond where Dr. Shekhawat has mapped. So these conglomerates, and one conglomerate body, Lasaria, is 70% conglomerate, 25% arcos, nothing else. It means this is a very special condition of basement. You see, they are all paraconglomerates. Boulders can be as big as 2 meters across, and they are just from the shoulders have been dropped in the lacustarine system. And you see graded bedding in conglomerate, a rare phenomena. And you see there is a seismicity that you see conglomerate followed by thin sediments, then again conglomerate. So basin must have been very active seismically. So high magnesium assemblage I have spoken. I need not say this one evaporitic evidence. Normally evaporites are described from the late Paleozoic all over the world. Whatever literature we understand, 90% are covered by that. Very rarely you see Precambrian evaporites from Australia, William group, or from South Africa and other areas, and from India we have got some evidence. All evidence are that high magnesium carbonates, serpentine talc bearing marbles, magnesite, microclinite sediments. You see macroclinite sediment with dolomite. This is thanks to Dr. Shekhawat who has mapped it. Then later on we understood that this is something different, nothing to do with the intrusive microclinite. So this is very important. Then karst topography. Karst underground we get cavities. 24 meter long is the one we have got during drilling. Then poikilotic dolomite is very important. This was also discovered, found in Salumbar area by Dr. Shekhawat, and it is more in Ghagri area, where the percentage could be 50% poikilotic dolomite in the system. And then pseudomorphs of anhydrite, and then Hopper structures, which are very characteristic of evaporite. You see the magnesite layers, you see pyroxene in carbonates, whatever I have spoken. This is the rhombohedral dolomite. This is the poikilitic dolomite. The last one is the stellar type habit, which is pseudomorph after probably after anhydrite. You see layers of carbonate, impure carbonate, then possibly anhydrite replaced zone like this, and this is the solution breccia in we got at Hinglaj Mata area. This is the tourmalinite. This is the field photograph. This is the outcome photo. This is the there is one thing which I like to speak. Tourmaline, graphite, and carbonate, albite. They are contiguous in this area. That's the typical of evaporatic setup. And then you see tourmaline is right in the ore body, green tourmaline, in Bukia, gold bearing Bukia. I have spoken this one. The most important features is that you in Ghagri the tourmaline composition is different, Bukia composition is different, and Baratalao composition is different. So when there is a difference of composition in so many things in a very small terrain, it means most likely we are dealing with non-marine type setup, unlike the marine setup where homogeneity is more. This is the diagram. The Gagri data are after Fariduddin and his co-workers. The trend is povanderate trend. This is typical of the meta evaporites. And then in Dravite is shown by blue color, and Chinese evaporite, that is Lauding province, which is very well known for borax deposits, it falls in between the two. So we are surely in evaporatic setup. This is the last slide I sum up. The permissive tracks, from my point of view, are granite related 3000 square kilometer. I have shown the map. Pegmatite related is very big area. So that area I have computed comes out like this. Birwala mica belt is 14,800. SDFB comes around 7,500. Iskan type deposit 2000 square kilometer. VMS type 1150. Evaporite type setup 750. That's all. I'm sorry for taking a little more time.
Excellent. Sir was taking us to the field as if we went to the field and visiting every different geological setup. So that is what the whole, as a teacher, he was teaching us sort of. Nice, sir. Excellent. And can we take few questions from
Sure.
our learned audience? We can take few questions, please.
Yes, please.
The one in the center.
Dr. Catherine wants to say something.
Does this work? Yes, it does. So thank you very much. Really good review. That was really useful. About the pegmatites, I think the first thing that I will say is that actually quite small pegmatites, a few tens of meters thick, can actually be economic if they are unzoned albite spodumene type. So I've seen those being mined. But you're quite right that Tanko is much larger and it's much more complicated. It didn't start out as a lithium mine at all. I've been in Tanko and it's fiendishly complicated. So it's much more like the pegmatite that you showed the example of that has spodumene in the central part. That pegmatite, from what we saw, it's steeply dipping, but we couldn't see the area with spodumene in. I just wondered what's the kind of three-dimensional shape of the spodumene area and its sort of relationship to the pegmatite, and how large is it? And then my other question is, how old are the evaporites? Sorry, so two questions.
Okay, I must have told before about evaporites, but let me first take your question first. It is true that pegmatite, whatever are reported, are very small. And the Second World War time, it was something like cottage industry, some people, small mining that they were doing. And it was local people were very good enough to understand where to look for the mica books. But whatever literature, I have plotted 300 pegmatites, taking coordinates from Cruikshank and others, and about 20 emerald-bearing pegmatites from the inventory of the State Department of Geology. All those things I could put on a grid map. And I could see that the bodies, whatever are described, are really very small. You can see the scale is hardly 20 meter, 15 meters only in the map for the 1000 map. So I fully believe, as an exploration geologist, if the substrate is small, you cannot expect big deposit. So minimum which I see is a very well-known body, at least usually 100 plus meters. And one thing which is there is a exploration gap, that is that we have never thought what lies beneath the marble I showed, that magnesite bearing marble. We have never gone there. We have never had the idea that we should go down. It may not be important for beryl, or it may not be important for mica, but lithium is important, worth enough to go down. We have not done that. This is an exploration gap. Second thing, the evaporites are lower proterozoic, Aravali supergroup. So lower proterozoic vanishment is more rather than preservation. That's why I chose that I should say this one. And before I close, I would say that this is repository of gold, 200-ton gold. But I never related with the formation of the gold. Like something like Jiaoding in China, you have got 3,000 tons in granitic terrain, but the gold has come from something else. Like Arlene, gold is developed somewhere else, but residing in early structures, something.
Thank you. Any other question? Yes. We can take one more, sir. One more question. We're actually running
Thank
a
you,
bit
sir, for
late.
this is good presentation. As usually, you show very good presentation. One more question regarding fluorine. So, for BIS standard for fluorine is that if it is 1 ppm, then it's okay for drinking water. Beyond that, it is not usable. And what is the content of fluorine there? What you have shown?
Fluorine is generally above 1. Okay.
Yes.
That's why state government thought that wherever tube wells are there in the run, they should be made red, that don't drink from this. Okay. So that was the initiation of the project, and the project was a bedrock project. We should take cognizance of the data, and bedrock project in association with European Union. So
Yes.
2017 they have submitted this report. I could access that report and did this. It is more than 1 ppm else most of the places.
So this is for water and for
this is for water. This is for water.
And for hard rock, the average concentration is around 300 ppm. So that part is also to be seen whether this rock is really
data, those data I do not have. In fact, how can you have those data when the exposures are not there?
Yes, sir.
Main thing is that.
Yes,
so we have to devise a method whereupon we can get some information. That is why precisely I have done. I thought water is very important. Everywhere you get water. So that's why I use this data.
Yes, sir.
I fully agree with you that hard rock data should be done to the extensivity to learn from those things.
Actually, may I come in between? Dr. Golani has given us lots of insight for the exploration for us to do. So we can think about this, and we can always interact with Dr. Golani after
yes,
this.
Sure, I am available.
I think with this, we thank Dr. Golani for his excellent presentation and interaction. Thank you, sir.
Thank you.
We are running a bit late in this technical session, so we'll try to just hurry up with the other presenters. We have we have a total of 15 minutes for each presenter, so we will try to restrict. We'll request them to restrict up to say 10 to 12 minutes for presentation, and just keep 1 or 2 questions or 2 to 3 minutes for interaction, if it is okay with them. Thank you.
Thank you, sir, for the deep and insightful talk. That was very enriching, I'm sure. We will now proceed with the technical presentations for this session. We have 8 presentations, and I request each speaker to adhere to the allotted time. Also, I would request our chairs. Sir, this is my request to you to kindly moderate the presentation timings from your side for this session.
Okay, we'll do that, no problem.
So you can proceed with the presentations now one by one.
Okay, the next presentation is on metallogenic fluid evolution in volcano-sedimentary sequence of Eastern Mahakosal Belt, Central India, to be presented by Sri P.S. Mishra. PS Mishra is not here.
Sir, I think sir has not arrived here maybe. We can proceed with the second one.
Anyone else is there in this group? P. Saini or Sri D. Pandit? No.
No, sir, I guess they are
Okay,
not.
we go to the next. This is on, the title is Ore Chemistry and Fluid Inclusion Study of Structurally Controlled Copper Cobalt Mineralization in the Fatehpura block, extension of the Khetri Copper Belt, Western India. Sri Alok Chauhan.
Respected Chair of the session, Dr. P.R. Gurani, sir, respected co-chair, Shri S. K. Ray, sir, and also heading the exploration activities in GSI, respected mentors of the GSI, uh, uh, distinguished guests from abroad. I'm Alok Chauhan from JSI and presenting from where to start is this? It's there and this is the pointer. Okay. Okay. So this work is basically what we have carried out a G3 exploration in K3 copper belt. And what the purpose of this study was not to model or something, and what the control of mineralization, just to know what is the control of mineralization so that we can proceed in the strike continuity and else. So I'm going to present that. This next one is, okay. So this is the location of the area where pointer is this. So we are in the Rajasthan and most boundary of Rajasthan. This is here, and this is North Delhi fold belt, and location is over here. This North Delhi fold belt, a generalized map which has been basically based on GSI work and then modified by several later workers. So this is the K3 area where we are having the HCl mines, working mines, and basically the Proterozoic sequence of Delhi supergroups. Means the green one is the Ajapur group, the blue one is the Alvar group, and later in the K3 we have two intrusive granites in the vicinity. So basically these are Alvar and Arjapur groups are like Proterozoic, like we are having arenaceous sequences of quartzites, and then in Ajab group we have cysts. So, and there is a prominent lineament over there, that is a K3 lineament, that is also called as their Babai Tondo lineament, where albitite line it is also called. So some have been, our authors are relating it to mineralization, although it is not related to uranium mineralization in this section. However, in the southern area in Kandila here, it is also some AMD is also working for uranium mineralization. So that's the study area. Although the regional maps have been modified, but I have taken a map of this district resource map of this GSI, as it is clearly some of the lineaments are very clear over here. So these dots are K30 copper mines. First we'll look on the Google imaginaries. So this acute fold and right fold is of relief groups, and we can see these lines. This is HCl mines over here, K30 mine. Then this is Kolian mine, and this is Chandbari mine. So these are locations. With respect to that, we are around 10 kilometer east of this. This is the study area. And later on, based on this study, we have working on the extensions area where some later workers have drilling done the scout boreholes over here, and we are also finding that the study is going in the right direction. However, the same thing which I have discussed, this is in similar, only this map I have put it that this is the Babai toned down linear. There is a major lineament, and also this is also a lineament over there. This is our study area, and these are the two scout boreholes are also falling within the same line. So that's one thing. The methodology is just like what we do in UNFC G3 presentations. Like first we will do, we have carried out detail mapping, then we have planned some boreholes, and then those samples of the core samples we have analyzed for petrographic studies, fluid inclusion and EPMA studies, and we are trying to correlate what is the control of the mineralization. So again, that is the DM map prepared by us. We had the advantage that we had earlier, two boreholes in 1970s, B. Sharma et al. Have drilled 5 boreholes, out of which 2 boreholes were positive. And then we have planned our boreholes based on the intersection of those boreholes. However, for planning of the boreholes on the mineralized zone, the rock was not available on ground and it is actively cultivated. So therefore, we cannot put any channel or there. So if we would have put a channel over there, that would be negative because it is actively cultivated and leaching is there. So those would not have been means giving us the true picture. Although we have only put one channel where there is a breccia is exposed, and that was positive. So this was the earlier boreholes. This was vertical borehole that was abandoned earlier. So based on this, we have first put up the first borehole. Then based on the intersection of those only, because we didn't have any surface control, so we keep on doing towards this southwest, and all the boreholes we have successfully intersected the mineralization. Just a look for the field photographs where this yellow one is the massive quartzite and this feldspathic quartzite is there. This is starting from this feldspathic thick quartzite is there, which is also flaggy sometimes. QMS is on the eastern parts, and then this mainly in the K3 area. What the host rock is supposed to be cyst and feldspathic or amphibole quartzite we call it. However, this cyst, what we are telling as host rock, this is not exposed, and I could not put up field photographs over there because this host rock of pure quartz biotite cyst is not exposed on the ground. What we have done, we had boreholes, dug wells samples. Based on that, we have put this cyst, and also this is only a tentative F2 axial plane because the exposures are not here to be take the data. And one albitite I was discussing about is this. See, albitite is exposed over here. However, this albitite alone is not a host rock if it is not on a favorable structure. So that is one thing. And another is this is a hydrobrictia exposed over here. Why we are thinking it's hydrobrictia, I will discuss it later. So the main point is that we have drilled 4 boreholes, and all the four boreholes have intersected some considerable mineralization. Only 2 photographs I have shown. Is why I have shown only 2 is that just there are 2 types of mineralization and 2 types of host rock. One is quartz biotite cyst, where the sulfides are chalcopyrite, pyrrhotite, and this one pyrite, chalcopyrite, and pyrotites, and they are following the foliation planes. And another one is breccia related, which is breccia, and here only dominantly chalcopyrite is there, and I could not find even a single pyrrhotite or pyrite. Might be there in some small proportions, but there is only chalcopyrite over there. So that is how, just to understand the mineralization, I put this. So these are 2 host rocks are there, which are potential targets for this. So this we have considerably good values like 11 meters, 0.6 in the first borehole, then 14 meter, then 9 meter, then 5 meter in the second boreholes also. We have plenty of loads, 4 copper loads, then third one, and the fourth one borehole, although it has intersected only 1 copper load. However, it is worthy as it was intersected 3% of copper, which is this massive copper is there within the calcite vein, and also some albitites are also there. This has yielded a 3% of copper, and these are the results of the previous boreholes, which we have considered for planning of our boreholes. And on basis of these 6 boreholes, resource of 3 billion ton of copper on cutoff of 0.2, and the grade is 0.6 of copper. So
may I come in between? I'm sorry to come in between. Like you have hardly 5 minutes left, and Please try
Sure,
to
sir.
come to the ore chemistry and fluid inclusion, which
Okay,
is
sir.
actually
So
your
what
main
I have
question.
shown the two photographs earlier only, so just old photography is also matching with that. The first one is the which is foliation parallel, and the C and D photographs are telling that pyrrhotite and chalcopyrite. This chalcopyrite has been exolved from the pyrrhotite, which I will discuss with the photographs also. And the last one is of the breccia, where chalcopyrite and pyrrhotites are there, and also it has been supergene arrangement is also going on. Some digenite is also there. So these are the fluid inclusions. We have got three types of fluid inclusions: primary monophase carbonic fluid inclusions, secondary this primary aqueous biphase inclusions, and secondary aqueous inclusions over there. So these are the primary ones from which the quartz veins of cyst, and these we'll discuss with the later photographs also. So we have plotted these over this salinity versus this homogenization temperature, and we have received some of the plots from the there. So what observations are there, that this samples, this QBS plus quartz vein, this appears to be like CO2 was there. So this trend, if we have taken considering this Wilkinson diagram, so CO2 was there in the primary solutions. So it is denoting boiling plus low salinity fluid, and then there is breccia. Brescia is there, which is telling that what I mean to say is the primary was along the foliations, and later on it mixed with the secondary fluids, and then there was a isothermal mixing where the temperatures was not increasing, and that chalcopyrite was exhaled from pyrrhotite, and therefore we are getting only chalcopyrites in the breccia related setting, not the pyrrhotites are all. So that has been exhaled, that is there is a mixing due to fracturing, and these are the two controls over there. So that's I want to show with the fluid inclusion this one. And also the EPMA study is also saying that these are the first one is chalcopyrite grains, pyrrhotite and chalcopyrites which has been exhaled are also identified in this EPMA studies. And then minor proportions of silver grains, acanthite and chalcopyrite is also there. So when we plot a cobalt and nickel ratio, which is characteristic to find the genetic connotations, so our chalcopyrite samples is falling over the hydrothermal deposits, and pyrrhotite, this pyrite samples, is just marginally towards the sedimentary. Oh, and one more thing I want to say is that the cobalt was more enriched in the pyrrhotites than in chalcopyrites. So pyrite is so in this area the pyrrhotites are also equally important. Although we have not calculated the resources for cobalt, however, because there are some certain constraints of the some partings are there, so it is not falling on the definition of a load. However, these are associated with chalcopyrites, therefore a potential for the spherotites are also potential for cobalt mineralization.
We have 1 minute left, so
Yeah,
kindly try to
just to
conclude.
yeah, so just one or two slides are there. What's not going next? Next कैसे होगा? Next नहीं हो रहा है क्या इसमें सर? Next नहीं हो रहा है क्या इसमें? Next pointers नहीं हो रहा ना? अच्छा इसमें से होता है. So just two slides are there. Conclusion and thanks is there. Next thing. Escape करने का था. हो गया. So this is the conclusion that we have identified two host rocks, which is quartz biotite cyst and breccia, and the another one is we are this is a major F2 fold axis, which are the control of mineralization, where this host rock and the combination of the regional structure and the host rock where we are getting this, we are getting mineralization. On the basis of this, we have searched in the extensive this extension areas where we have planted some 2 scout boreholes, and this first one has intersected some 23 meters of copper lode, and the second one is also intersected 13 meter of copper load. That's, and we are also doing G3 over here. So what our study was mainly that the control of mineralization, I think we have successfully in this particular segment, this particular area, we are successfully identified the control of mineralization, and the two scout boreholes having at a distance of 4.6 kilometers, that is also positive. So I think this is the study what we did. Only the challenge is the valley is around 2 kilometer, 1 to 2 kilometers wide, and there is 40 meters of soil cover. So only to plan the boreholes and a small variation in the strike would be result in a borehole failure. So that is the challenge. Otherwise, so this is our study. Thank you.
Very nice presentation. Actually, there is a problem with the pointer, we apologize, and we have requested them to give another pointer if possible, because the presenter is having a problem synchronizing the pointer and is presenting. So it is taking a little bit of time from that side. We apologize to the speakers. We can take one or two questions. Yes, please.
And from your prospect area, you have estimated reserve around 3 million ton, 0.45. What
Yes,
is the
sir.
reason
Yeah.
why?
Reason is that what I just forget to mention, those were the reserves of K3 copper mines, and those are very deep. I think would be around 1 kilometer depth. We are only drilled. What I have shown is only first level boreholes.
Okay, that's
So
fine. Okay, fine. You have done fluid inclusion study.
Yeah.
What is your opinion about the genetic type of this? Is it a part of Khatri, or it is a different mineral system altogether?
See, as a field geologist, I actually not studied K3 well, because our is to trace the mineralization where it is going on. So we are just focusing on where it is going on. So that one borehole by one borehole we are proceeding. So we are not working on modeling. Just the control of mineralization we want to just understand.
No need to do modeling. Simply from petrography, what is your opinion? Whether it is a porphyry type or a different type?
Yes, slightly porphyry it is giving something, but alteration for that we have to something was matching towards the porphyry also, but we are not done some alteration studies. Like this.
Alteration is not matching. Your fluid inclusion salinity is less than 10. It cannot possible in porphyry type copper deposit nor in ISHC type deposit. Then what is else? What is this?
See what as
time is short, we will discuss the
okay.
Okay, Dora, one thing I would like to add what he has told. We have taken Roger Iskiro and others in field. Dora. There is another albitite which is older. We found with the Roger Iskiro and others, we were moving with the Joseph Australia. It is, and they say it is IOCG, and correct, he attested, yes, whatever characters I am saying, it looks like that. And you know, he is a good exponent of IOCG. But his topic was essentially for fluid inclusions. But you need big area to study about the mineralization styles rather than a small area. Okay, fine. Okay, we can go to next. If any questions there, we can go to next.
Thank you, sir.
Thank you then. If there is no other question, thank you. Thank you for a nice presentation. So with that, we go to the next presentation. The topic is geochemical and genetic controls of vanadium mineralization. These days we are having a lot of vanadium exploration. So vanadium mineralization in the Proterozoic carbonaceous phyllites, Arunachal, Himalaya. Presenter is Sri Hiruj Salkia. Sri Hiruj, 10 to 12 minutes will be okay for you?
Yes, sir. It will be various as sorts.
Nice, so nice of you. Thank you.
A very good afternoon to all, respected co-chairs, the dignitaries, and all the delegates. So today I'll be speaking about this vanadium mineralization and its enrichment in the carbonaceous phyllite of the proterozoic metasediments of Arunachal Himalaya, and the geological processes and the factors controlling its enrichment within the carbonaceous phyllite. And thirdly, how to target the zones within the carbonaceous phyllite for further exploration. So here, as we know, the vanadium nowadays is a critical metal, with its increasing industrial importance in the global markets, especially in the steel and energy storage technology. So as a strategic importance, we need to have a resource security. And with the rising global demands, it highlights that we need to identify and develop our domestic vanadium resources. To research objectives, we have in the geochemical controls for the vanadium mineralization within the carbonaceous phyllite, then the genetic controls on the vanadium enrichment, and we will just, we have to propose a genetic model for further future exploration. Okay, if we go by regional wise, as we know that in Arunachal Pradesh already various exploration in every stages like G3, G4, we have taken up vanadium exploration, mainly in the carbonaceous phyllite of okay, mainly in the carbonaceous phyllite within the proterozoic metasediments, mainly we can call as a Khetabari formation or some Siang formation. So like that yellow dot, if you can see that yellow dot, this is where our current work is going on. And the other black dots, these are the occurrences of the vanadium where already resource has been estimated and established. So with the present study, we will be targeting the carbonaceous phyllite of the other geographic distribution, and we will go for this how it is being controlled and the factors for its enrichment within the phyllite. This, if we go then this characteristics of this metasedimentary sequence, then the metamorphism related to the tectonic and in the Himalayan orogeny, it is very significant, and the impact is that these metamorphic processes due to Himalayan orogeny, it has influenced the distribution and the remobilization of the vanadium and its enrichment in either some iron phases or in some silicate phases. So like in a particular area, we have carried out some field work, and within the carbonaceous phyllite, we have tried to we differentiate the various variant of the carbonaceous phyllite. Like we are having this soft variety, the extreme left, we are having the soft variety, then a compact variety we are having, then this iron-rich carbonaceous phyllite, which we can say is a subset of the compact, this variety. So coming to this soft variety, it's a very fine-grained and pliable texture with high organic content, with less degree of lithification. Then this compact variety is more denser relative to this fine grain. With the pronounced metamorphic effects, we can see the cystosity, and even we can see some silica veins, and with some ferruginous material also. Like in the iron rich, you can see that the color itself just speaks how the carbonaceous phyllite in that particular unit. And this presence of the iron mineral, and in this part of the carbonaceous phyllite, we are having the highest enrichment of the vanadium. Coming to the metallurgy and approach, we have collected representative samples from the various variants of the carbonaceous phyllite to capture the various texture, composition, and its vanadium content. Then we have attempted a statistical analysis to identify the relationship among the major and the trace elements and the factors controlling for its vanadium distribution. And in the geochemical whole rock analysis, we have tried for the quantitative determination of the elemental composition, then identification of some redox sensitive elements, which will give a clue for the vanadium enrichment and the factors controlling it. In the lab studies, we have performed some SEM and EPMA for the distribution of the and the behavior of the vanadium. And in the chemical testing, this is a semi-qualitative flame test we have performed, where we have determined the vanadium oxidation state in a +3. So here, what I would like to state this, we have just attempted a preliminary test, but likewise, we are in progress for a chemical leaching test, where we will try to evaluate, and we'll try to come out with a output like out of the total vanadium concentration, the +3, +4, +5, which will be contributing more. So with that, we'll be attempting. The work is in progress. We also attempted a correlation matrix heat map to visualize the correlation coefficients among the elements for the iron, vanadium, chromium, nickel, titanium, silica, and alumina. The color coding here itself says about how the elements are geochemically linked. Here we can say, where you can see this vanadium, it's showing with the iron. There's a strong, we can say it's a strong positive correlation with the iron. Then again, with the chromium and titanium also, it is showing a positive correlation. And with the silica and alumina, it is showing a low or negative correlation. Then from the EPM and the SAM analysis, what we have observed, like mainly we have got the vanadium enrichment within the iron phases. And these iron phases within the carbonaceous phyllite, it occurs at either a dissemination or in some ways of winlets in anastomosing manner. So here, what we have attempted in SAM analysis, like this point is not working, this is a part of the carbonaceous phyllite where this bright color is the iron phase. So here, what we can observe here is like, if you can appreciate this red color, these are all the vanadium. And we can see that this vanadium are occurring over the iron phase. And this green color are all the alumina. And we can see here that this vanadium, this red color is not over this green color, and even on the carbon. But in some parts, we can see the vanadium is also occurring with the carbon. Here, again, we are having another photograph here, where we can see that these are all these bright phases are all the iron phases where we have got the vanadium enrichment. So these are some of the images where these are the iron phases, where you can see here this iron, it is the higher level, and this red color is signifying the vanadium, and this blue color is the titanium. And you can see the relationship of the titanium and the iron, titanium and this vanadium, how it is correlating. And here we can see this vanadium, and this iron. And you can see that with the with increasing of this vanadium, we can see a slight depression of this iron. So we can say that it's a substitution to where it is being captured by this vanadium.
2 minutes to go.
2 minutes to go. Okay, sir. Just a small attempt for the this component analysis, to where we can see the 80% of the total variance of the principal component. The main elemental factors were the iron, titanium, chromium, nickel, and vanadium. And this element loading, we can see that these are all closely associated. Then we have calculated the correlation coefficient, vanadium versus the iron, where we can see this iron-rich variant. It's on the higher side relative to the soft, where the this coefficient is small, and overall this carbon content is also higher on this side and lower on this side. So these also some evidences that this vanadium is fixed within these iron phases. And this and later this secondary enrichment of vanadium, which has been distributed due to some during the metamorphism mediated by the metamorphic fluids. And again, we have attempted for this average vanadium litho variant wise also. Here we can say that the average vanadium is higher on the iron rich variant. Then this vanadium oxidation state, the preliminary this flame tests were conducted samples. Already I have discussed in the earlier slides. This also supports the redox conditions, the geological process. And the significance, this iron oxide rich lithologies, it has favored the vanadium fixation and this favorable environment for the economic mineralization in future. So coming to the genetic model, we have not come to the final conclusion as our work is still in progress. So the primary analysis, we can say that the vanadium was fixed within the carbon or in some iron oxides also. As we have got some positive correlation between iron and vanadium and also positive correlation of vanadium with the fixed carbon. And these ratios were also evaluated with nickel, chromium and titanium, where we can say this vanadium was enriched during the suboxic to reducing environment, and this titanium is showing the hydrothermal influx. The secondary enrichment, we can say that during the Himalayan orogeny, due to some metamorphism, the remobilization and re-enrichment of the vanadium, it was redistributed and it got trapped within the iron also, or in some aluminous silicate minerals also, and within the carbon also. That's why we have, I have mentioned here, association with micas and clay minerals also. The future is research. These iron oxide lithologies are to be prioritized as a primary exploration targets. Redox active zones with metamorphosed sedimentary terrains are also to be taken care of, and obviously applicable to the similar geological settings in the Himalayas, Arunachal Himalayas mainly. Then further we have to carry out some or further detailed EPMA, LISCPMS, or carbon isotope and chemical leaching, which I have already discussed earlier. And thereby we will be going further for the precise identification of some vanadium bearing mineral phase and further characterization of specific mineral phase. Thank you. So this is all about my speak about this vanadium.
Nice.
So it's open for discussion and for suggestion, please.
The best part, in spite of the pointer problem, he has presented within the time frame. So we can quickly take on one or two questions. Nice trying in correlating vanadium with the iron phases. So that's a very nice attempt. So we can take one or two questions if, yes, definitely.
Sorry, sir?
The absolute amount of vanadium in these three different phases of your carbon.
Okay, sir. Sir, in the iron,
can you give the numbers?
Yes, sir. In the iron rich variant, the vanadium concentration is around, in what the samples I have collected is around 14,500 ppm. And in the soft variant, where the concentration is, it was the correlation was 0.35, it is around 2 to 3,000. And in the this compact
So
variant,
you are saying this high is because of iron enrichment?
Yes, sir. As per the present study.
So, but you have not yet, as of now, identified the phase in which the vanadium is.
No, sir. That's because the work is still going on, sir.
So it might be absolutely not related with the iron. It's
yes, sir.
Something
maybe,
else.
sir.
Because the number of samples for your correlation coefficient, how was the number?
So it was 32 samples, sir. 32 samples.
All together, all the three variants. No, each.
Yes, sir. No, together, sir.
So it's a small sample correlation. So it's a small sample correlation. It might not be exact correlation also. Anyway, so you will have to find out the phase, and only you can actually take a concrete view.
Yes, sir.
What is the reason for this enrichment?
Yes, sir. We are working on it, sir.
Thank you. One quick question, yes. Sir.
That graphite, yes, sir. Actually, this graphite is this carbon, what we have seen in the carbonaceous phyllite, it's a graphite only. Like both, it may be inorganic or organic also, sir.
No, actually, you have proposed both the models actually. You have supported the sedimentary origin as well as the metamorphic origins until and unless we
Yes,
have some carbon
that is a
isotopes
secondary,
analysis.
sir. The metamorphic is a secondary, sir.
It can be remobilized also.
Yes, that's why I was talking about the remobilization only.
Yeah, but the confirmation is only from the carbon isotope. Have you carried out?
Yes, no. We are yet to be done this carbon isotopes.
And the data you have shown actually it is from Khetapadi formations only or somewhere else data you have incorporated?
So mainly it is from Khetapadi formation, the data where I have collected. This is from the Sito area.
Okay. Because we have also reported some bands in Tawang area, Lumla.
Yes, sir.
You might have seen that area.
Yes,
there,
yes, sir.
Okay. Thank you.
Thank you, sir.
Okay, I
Okay,
think,
sir.
thank you so much.
Thank you, sir.
Thank you very much. Okay, we go to the next presentation. It is, the title is Secondary Enrichment of Jhamarkotra Phosphorites, Aravali Supergroup, Rajasthan, India, Petrographic and Geochemical Evidence, to be presented by Sri Rajiv Kumar.
Sir, I think Rajiv Kumar sir is also not there.
Anyone from the authors, any other author is available? Sri Rajiv Kumar and group. Okay, then we can move on to the next presentation. The use of zirconium hafnium indicator to assess the rare metal potential of intrusive granitoids in the Dudhi Naisik complex, Sonbhadra district, Uttar Pradesh. It is to be presented by Amrita Sarkara. Sarkar, I think. I thought there is one more title. I deliberated in my mind. It may be Sarkar or Sarkara, maybe. Anyways, my apologies for not interpreting properly. But yes.
Good afternoon, everybody. Today I am going to talk very briefly about the use of zirconium hafnium indicator to assess the rare metal potential of intrusive granitoids in the Dudhi complex, Sonbhadra district of Uttar Pradesh. This proxy, the zirconium hafnium indicator, is also used to determine the evolutionary sequence of granitic magma. So this is a pilot study where we have used this indicator, zirconium by hafnium ratio, as a proxy to determine the rare metal potential of the Dudhi granitoids. This is a preliminary study where we have used the whole rock concentration of zirconium and hafnium concentration to determine the rare metal potential. So what is granite fertility? So granite and its associated late stage products like pegmatites have high potential for concentration of rare metals and critical elements like lithium, beryllium, niobium, tantalum, and so on. The formation of rare metal deposits in a granitic system is a result of fractional crystallization and fluid magmatic differentiation. So what happens in this process is the incompatible elements like the rare metals are excluded from the major mineral structures, and they thus get concentrated in the residual melt. This entire process of magmatic crystallization, the sequence of evolving magmatic granitic magmas can be tracked by geochemical indicators, and I have used this zirconium by hafnium indicator as one of the geochemical proxy. There are various other geochemical proxies that's been used by various researchers to determine this granite fertility, petrochemical indicators like the alumina saturation index and the silica content are very primary indicators of a fertile granitic melt. Geochemical indicators like rubidium by strontium, potassium by rubidium are used by different researchers. Towson et al. In 1987 introduced a granitic rare metal index where they have used a multi-element approach. They have used fluorine, lithium, rubidium, strontium, and barium. Now, Zerensky et al. In 2002 used the zirconium by hafnium indicator, the zirconium by hafnium ratio, which is considered a very reliable, basic, and a robust model to determine this rare metal potential. Empirical studies done in their case study, they have determined a evolutionary sequence from granodiorite to biotite granite to leucogranite and the extremely evolved LIF granite, which is accompanied by a systematic decrease of zirconium by hafnium ratio. So why do you use, what is the, how do this zirconium by hafnium indicator is a better geochemical proxy than the other geochemical indicators. The proxy is a highly effective indicator of granite fertility due to its direct and systematic approach where we can determine the degree of magmatic differentiation and their potential for rare metal mineralization. So during the crystallization of granitic magma, zircon crystallizes at an early stage. And they have this, the zircon crystals preferentially allow zirconium in the crystal lattice relative to hafnium, which results in a concentrated, which results in an elevated concentration of hafnium in the residual melt. So as the granitic magma evolves, the zircon by hafnium indicator decreases progressively, which thus gives a very robust and very preliminary indicator to determine the magmatic differentiation, and as the highly evolved magma has a potential for rare metal concentration. So this is the study area. The study area is DGC, Dudi-Gneissic complex, which is the westward extension of the Chotanagpur-Gneissic complex. These are some field photographs. As we can see, the preliminary lithologies exposed in the area are the K-feldspar gneissic, the K-feldspar gneiss, porphyroblastic K-feldspar gneiss, biotite gneiss, and some migmatites. The intrusive granitoids, which are also known as Dudhi granitoids, are mainly of three variants: biotite granite, tourmaline granite, and K-feldspar granite. Leucogranite is also present, is also recorded in the area, but it is not observed very extensively. We have seen the presence of allanite, as you can see in this photograph, in K-feldspar granite, which is a rare element. So I'll talk very briefly about the petrochemical characteristics of the granitoids of DDC based on the major oxide geochemistry. Petrochemical analysis of the granites of DGC indicate that most of the granites are silica saturated and meta to peraluminous, and they are mostly falling in the Ferroan field. Tectonic classification plot after Batchelor and Bowden indicates a syn-collisional to post-collisional tectonic setting of these granitoids, which is related to the Son-Narmada lineament zone. So as we can see in this petrochemical plots, these are the sample locations. These are the samples which we have collected, and we have used this model to determine the alumina saturation index. Highly evolved granitic magma are predominantly meta to peraluminous. They have an alumina saturation index greater than 1. This granitoids, this gneiss and the granitoids of DGC are evolved from a S-type sedimentary type of magma, which can be, which we can understand from this graphs. Now, coming back to zircon by hafnium indicator and how we have used this. So zircon by hafnium ratios are near chondritic in most magmatic granites. They are approximately around 35 to 40 in most magmatic rocks, but a highly evolved and high silica rocks have an anomalously low zircon by hafnium ratio, which is approximately in the range of 15 to 30. The intrusive granites and the pegmatites of the DGC, the zircon by hafnium value is in the range of 22 to 55. The K-feldspar granite in the area shows zircon by hafnium values lower than 30, indicating their potential for rare metal concentration. Tourmaline granite records a zircon by hafnium value of approximately 36, whereas biotite granite in the area shows elevated zircon by hafnium value of greater than 55. So based on this zircon by hafnium indicator, we have tried to establish a evolutionary sequence where biotite granite is the least evolved and K-feldspar granite is the most evolved. Now tourmaline granite generally in magmatic systems are considered to be highly evolved, more evolved than K-feldspar granite because of the formation of the tourmaline in later magmatic stages. But using this particular geochemical indicator as well as other geochemical indicators, it is shown that K-feldspar granite are more evolved than the tourmaline granite, which can be because of the presence of boron in parental magma, which can be influenced by the parental magma. The quartzo-feldspathic later stage intrusion, the pegmatic veins, which are highly fractionated and highly evolved melt, they are the last stage of formation, have a zircon by hafnium indicator less than 22, and thus indicating their potential for rare metal mineralization. So these are the two predictability models used by Bullard et al. 2016 and Zerensky et al. So now Bullard et al. Have used both zircon by hafnium indicator and niobium by tantalum indicator to determine the rare metal potential. So when we have plotted our data, it can be seen that most of the biotite granites are fallen into the barren granite zone, whereas the granites, the K-feldspar granites which have Zr by HF ratio greater than 30 and a niobium tantalum ratio less than 5 is falling in a zone where there is potential mineralization. I suggest this last slide. So where is the pointer? So this model is used by Zerensky et al., where they have used zirconium by hafnium and the ratio and silica. So when we plot this data, we can see majority of the samples, granitic samples, are falling in the barren granite zone, which are mostly biotite granite, and some are falling into this rare metal mineralized zone, which are predominantly K-feldspar granite. These samples are pegmatitic samples, the late stage pegmatitic intrusions, where there's a silica content is greater than 65 and the Zr by HF ratio is less than 22. So they have a potential for rare metal mineralization. Now, field evidences, if you can see, there is not much surface indications of rare metal mineralization in Dudhi granitoids. We have seen some presence of scheelite as minor streaks, but using this model and other geochemical indicators like rubidium, strontium, europium anomaly, negative europium anomaly, and others, they have a potential, the later stage pegmatic veins have a potential for rare metal mineralization, which requires further study in the area. So in conclusion, I'd like to say that this is an ongoing study. We have used the whole rock composition of zirconium by hafnium, and we are using this indicator for particular zircon grains also to corroborate the data. Though there are studies which have shown that if you use the whole rock composition of zircon by hafnium content as well as a particular zircon grain, the general trend is similar. So this is it. Thank you. Thank you, everybody.
Thank you, and we for the excellent presentation, and within time, definitely 1 minute before time rather. So we can start the one from the back of the auditorium. We'll come back to you.
So obviously, it's a very good presentation. I have a query that zircon by hafnium, as it is obviously a differentiation indicator for the evolving granitic magma. Similarly, as you have shown here also, niobium by tantalum, that is also a very good indicator of this. And another very important thing that in the niobium tantalum, as we are finding out for the rare metals or rare earths, so we know that in the fluorine or chlorine or in this domain, so these RM will be there much more than your this ZR and HF like that. So if niobium and tantalum can be used with this ZR by HF, so
what
that
is
will
your
give a
question?
very good result.
Your question, actually. It is a suggestion.
Just it is a
Acha,
suggestion. I
Sir,
am
we
not
have used
questioning.
that where we have
I
found
am
the
not questioning.
niobium by tantalum ratio is less than 5, which is also very potential. That niobium by tantalum ratio being less than 5 is also very potential for rare metal mineralization. But there are certain limitations of using niobium by tantalum for Hohenlohe analysis, that they are very susceptible to hydrothermal alteration. Whereas zircon being the zirconium by hafnium indicator been trapped in zircon grains, and zircon, as we know, are very they don't alter to further later stage hydrothermal intrusions or a later stage any other metamorphism or anything. So
Yes.
that is one of the.
We can take one question from the front. Okay, you can.
Sir, I can't hear.
Switch on the mic, please.
Yes, sir, no issue, sir.
You have reported the occurrence of actually this ratio.
Yes, sir.
Proposed by Jarsky et al.
Yes, sir.
But you see the range proposed by Jarsky et al. It varies between 19 to 30 is considered the most viable and most fertile range.
Yes, sir.
Most of your samples got out of this range.
No,
how it is?
sir, most of the samples which are biotite granites are greater than 30. Whereas the K-feldspar granites and the later stage pegmatic intrusions are less than 30. And Zelensky et al. Have also mentioned that some pegmatic veins which have less than 15 or 20 ZR by HF ratios are very highly evolved and thus have high potential for rare metal mineralization. No, sir, silica. This is the model I have used. It is according to Zelensky et al. It should be more than 65%. Okay. Sir, I'll have to see it then. I'll have to see it.
Okay, thank you. Can you get the microphone in front? Just
Thank
a
you,
minute.
sir.
For your excellent idea. One of your field photo shows it is a mixed some assimilation patches like that. Have you taken that consideration while you?
Sir, that's biotite by this is. Sir, please continue.
Because your binary plots are showing very scattered plots. That
Yes.
means something mixing indication is there during sampling. What I feel.
Yes, sir.
One another, it is only suggestion.
Yes, sir.
Your ZR is analyzed by XRF or ICP-MS? Because
Sir,
your
XRF. XRF.
Then one is be analyzed by XRF,
yes,
which can be done by
yes,
ICP-MS.
Yes, I understand.
And
this,
your HF is analyzed
yes,
by ICP-MS.
Yes,
then
sir.
why you are considering
that
that
is
two
that
different?
That is a limitation which we will be which we will address when we will use the the zircon grain ZR by HF ratio. So if that we'll use it, that's a work in progress. And when will we do that, we can corroborate this.
Another suggestion I can give.
Yes, yes, sir.
You better collect sample in field.
Yes.
Then you study very minutely detailed petrography first. And mineral wise you characterize, then going before whole rock.
So the problem is the mineral.
Had I been in your situation, I would have been done like that.
Of course, sir, of course. But surface evidences are very rare in
I have
DGC.
seen, I have worked there also. Adjoining
Okay.
part of the Mahakosal I have worked. So I have seen Dudhi granite.
It's very rare. We only find scheelite, and that also very less streaks. It's not very prominent in that area.
Because whole rock analysis is something, its protocol is very complex. We don't know from where it is coming, and it is very difficult. The three different methods are being used for analysis. So better to have characterized with help of minerals. But idea is very noble.
Okay, thank you, sir.
Definitely, either you can say it is yes or not, you can say it.
Okay, sir. Thank you, sir. Thank you, sir.
Thank you, Professor Dora. Anyone else? Thank you. Okay, thank you so
Sir, you
much.
can ask me later.
Sir, would you like to ask? Sir, question. Okay, thank you so
Thank you.
much. So we go to the next presentation. The title is Unified Multi-Acid Digestion Method for Simultaneous Determination of Base Metals, Silver and Cadmium in Geological Samples using FAAS, a streamlined approach for mineral exploration in India, to be presented by B. Sirisha.
Hello. That is sorry. No, that's fine. So good afternoon, everyone. My name is B. Sirisha. I'm working as a chemist in Southern Region, Hyderabad, Geological Survey of India. The topic I'm going to present today is about a unified multi-acid digestion method for the analysis of base metals, silver and cadmium in geological samples using flame atomic absorption spectroscopy. My co-authors are PVVR Sharma, K. Shivshankar and P. Srinivas Rao. So the background behind developing this method is that geochemical analysis is quite important for the mineral exploration projects. So traditional methods involve two different digestion techniques for the analysis of the base metals and silver and cadmium, which is time consuming, laborious as well as resource intensive. So our aim is to develop a unified digestion method for the analysis of base metals along with silver and cadmium without compromising with the quality of our analytical data and also thereby increasing the throughput of our laboratories. In this unified method, we are minimizing the utilization of the hazardous reagents, which will be having a positive impact over the environment. And this method we have coupled with the flame atomic absorption spectroscopy, which is a very cost effective technique which will give reliable quantification for these elements when compared to the advanced instrumentation techniques like the ICP-MS and XRF. So, before going into the methodology, let us first see why these are called base metals and what all elements we are going to analyze by this method. These are called base metals because of their high chemical reactivities, their abundance availability in the earth's crust and their economic as well as the industrial importance. So our aim is to check whether this method is suitable, reliable and it has good performance for the in-house unified method for different kinds of geological materials like rocks, soils, sediments and minerals and ores. So for any geochemist while developing a method, there are few challenges which we are going to face. The first challenge is the highly stable silicate matrix. All these geological materials have a very stable silicate matrix and the normal acids like the hydrochloric acid and nitric acid will not be able to break this highly stable silicate matrix. In order to attain this, we have to use a mixture of acids. The second challenge we are going to face is the matrix interferences. These geochemical samples have a very complex matrix in which the elements are ranging from the percentage to ppb levels. So the elements which are present in very high concentrations are going to interfere chemically and spectrally with the FAA analysis, thereby suppressing the signals of our target elements. The third problem which we are going to face is the analyte specific issues. As these are highly reactive metals, they have different kind of behavior in different kinds of acids. For example, silver in the presence of high chloride media will immediately precipitate forming silver chloride. And some of the elements are volatile. So when we are applying aggressive dilution temperatures, they are going to evaporate from our dilution medias. So in order to address problems like this, in our method we have used a combination of two acids. One acid is the hydrofluoric acid and the second is the reverse Saccharidge. Hydrofluoric acid is the only acid which can react with the silicate matrix that is present in our samples and convert it into silicon tetrafluoride, which is a volatile gas and which will escape from the dilution medias. Now these target elements, once the silicate matrix is broken down, is liberated. So the next acid which we are going to add is the reverse Saccharidge, which is not a single acid but a combination of two acids, hydrochloric acid and nitric acid, in the ratio of 3:1. As from the ratio itself, we can see that the nitric acid is present in excess concentration. This is a very powerful oxidizing agent, so it will readily attack with our target elements, forming soluble nitrates, which can very easily be analyzed using the flame atomic absorption spectroscopy. So this aggressive chemistry, as we are going to use the hydrofluoric acid, since hydrofluoric acid can react with the borosilicate glass that we are using, we have to conduct this experiment using the dilution vessels, Teflon beakers. Now in this slide I have shown the different materials, equipment as well as the certified reference materials that I have used for development as well as the method validation of this method. Now let us quickly go through the methodology of this method. In this any geological sample that we are receiving, we are going to powder it to less than 200 mesh, and 0.2 gram of this sample is weighed with the help of an analytical balance and is transferred into Teflon beakers. To this we are going to add both of our acids, reverse Saccharidge as well as HF, and we are going to heat these samples on hot plates for 200 degrees centigrade till the incipient dryness is obtained. Incipient dryness means reducing the volume to minimal, like the sample is reduced to minimal concentrations, minimal volume. Then to this sample, we are going to add 5 ml of 5% nitric acid to reconstitute all our elements into solution. For that we are going to heat these samples for 100 degrees centigrade for 10 minutes on hot plates. Once the samples are removed from the hot plates, we are going to cool the samples and make them up to 20 ml with the help of 5% nitric acid. These samples, once made up, are allowed to settle down overnight, and next day they are going to be aspirated in flame atomic absorption spectroscopy. So once we have developed this method, we want to check for the reliability and the application of this method for different kinds of samples. To confirm these, we have performed few of the key validation parameters over this method. The first validation parameter that we have performed is accuracy. We have done it by doing spike recovery method. In this method, what we have done is that we have prepared a elemental standard of known concentration, and we have spiked this known concentration over the certified reference material. Then to this sample we have applied our methodology, and we analyzed the samples using the flame atomic absorption, and we have calculated the recovery values. The recovery values that we have obtained are well within the acceptance criteria, which shows that the method which we have developed is very accurate for the analysis of these elements. Now the second validation parameter that we have checked is the precision, which is nothing but the repeatability. To verify the precision, what we have done is we have taken 6 replicates of the CRM samples, and to all the 6 replicates we have processed them through our methodology, and we have established the percentage RST values for all the elements of our interest. These percentage values, if they are below 2%, then the method is supposed to be precise. As you can see from the bar graph that we have established, for all these elements, the percentage of RSG values are well within less than %2, which indicate that the method we have established has good precision. Now, after these two, we are going to establish the sensitivity of the method that we have developed. This we are going to do by measuring the LOD and the LOQ of this method. So LOD means limit of detection and LOQ means limit of quantification. To do this parameter, what we have done is we have taken 10 process blanks, and these 10 process blanks we have applied our methodology, and we have aspirated them using the flame atomic absorption spectrometer for all these elements. For these 10 values, we have done the standard deviation, and 3 times of the standard deviation that we have attained is equal to the limit of detection, and 10 times of the standard deviation is considered as the limit of quantification for each of these elements. As you can see from this table, that the LOD and the LOQ values that we have attained indicate that the method is highly sensitive and suitable for the trace level analysis of all these elements of our interest. Now, after establishing the sensitivity of our method, now we are going to see the linearity of our method, which means that the concentrations at which our method is linear. So, to establish this parameter, what we have done is that we have taken all these elements in the concentrations ranging from 0.5 ppm to as high as 30 ppm, and we have established the calibration graphs for all these using flame atomic absorption spectroscopy. So, and from the calibration graphs that we have obtained, we have calculated the R square values. All the R square values that we have attained for all these elements fall within our acceptance criteria, which indicate that our method has linearity over a wide range of concentration ranging from 0.5 ppm to as high as 30 to 40 ppm. Now, the fifth parameter that we are going to check is the measurement of the uncertainty. The measurement of uncertainty tells you about the confidence with which you can present the result, irrespective of the different kinds of the uncertainties that are present in our method, as well as the CRMs and the glassware, etc. Using that formula, we have calculated the uncertainty of all these elements, and the values that are obtained for geological samples are well within the limits, which show that our method, in spite of all these uncertainties, can give very confident results. And the last and the final protocol that we are going to perform for our method is the robustness and the ruggedness. In order to check this parameter, what we have done is the certified reference materials for all these elements. We have taken different varied weights of these certified materials from 0.1 to 1 gram. On all these samples, we have performed our methodology and we have calculated the recoveries. The calculated recovery values are well within the acceptance criteria of 90 to 100%, which indicate that our method has very good robustness over a varied sample weights of 0.1 to 1 gram. So, from all the results that we have obtained on all these validation parameters, we can summarize that the unified dilution method that we have developed for the analysis of the base metals and silver and cadmium has good accuracy, good precision, is very robust, and it has very good sensitivity levels which can detect over a wide range of concentrations. And this method, to check the method applicability of this method, we have analyzed many certified reference materials for all these elements, and we have established the data. The values which we have obtained by this method are very close to the certified values, which indicate that our method we can employ for all these elements over different types of materials to get very accurate results. Now, the key references which have guided me over this work are presented to you. And I thank everybody for giving me this wonderful opportunity.
That is one of the very excellent presentations. Very confident and excellent presentation on analytical chemistry. So we can take few question, one or two. Yes, left side one.
Hello.
Yes.
As you have said that this silver is sometimes not means analysis. They make some difficulty in base metal analysis.
Yes.
So that's a solution for our problem also, because sometimes like in EPMA also we have identified some silver ores in minor area, but still the results are not there. Might be this has a practical
yes, this method we have verified exclusively for silver.
For silver, if you analyze this with the earlier method, then I think
this is more beneficial, and in this recoveries for silver we are getting even in the lower ranges and as well as the higher ranges. So you can definitely employ this method for the analysis of base metals along with silver and cadmium.
Okay, so only comparatively, if you will do what is the earlier methods, this one, and what is this?
The methods which I have compared is
some comparative studies, if it is there, like the same sample, that would, I think, we boost the confidence of the geologists also.
Yeah, in this presentation I have not included, but I have definitely done the comparative studies over different kinds of CRMs exclusively for
question,
silver.
Please. Thank you for your suggestion.
Thank you, Sirisha, for nice presentation. Actually, what Sirisha has described, the earlier methods what we are using in our GSI actually. Basically, there were first aquarius and additions methods were then subsequently The reverse aqua regia also came down. And now we are using some triple acid digestions method also.
And 50%
Because
nitric acid method was also employed
yes,
for
yes, that
sometimes for
was
silver and
also
cadmium.
because as the geological terrain gets different actually, matlab, so we face a lot of problems in analysis of these base metals actually. So sometimes in some areas like triple acid digestions methods may not give that much of recovery, but in few other areas it may give. So depending on the geological matrix, the problems which we are facing actually, for that betterment, I think the work she has done is excellent actually. And
Yes,
the one thing actually, Saab has told regarding the silver analysis, because regularly we are not doing the silver along with the base metals, but these methods can be utilized in a prominent way so that other elements other than the base metal like nickel, chromiums and the silver, and in fact sometimes iron is also asked along with that one, so that can be really useful for that. Considering the methods which we are presently using in our GSI. So I think one more things I must add here actually, the standards actually she has used from the different variety of formations. So that proves the validity of that method actually. Yes, we can go ahead with that method. So thank you Sirisha for doing that.
Thank you so much.
Yes, one more we can take.
Yeah. No, sir, we have not yet.
Why not?
We will look into it, sir.
No, what look into it? Do it tomorrow.
Yes, sir.
Or the
Sure.
next week. Or the next week. Please
No,
patent
this
it.
is actually a very excellent method for analysis of base metals, sir.
Is it a novel method, right?
Definitely,
It's a
sir.
novel method? It's a novel method, no?
Yeah, it's a novel
so
method.
Then why don't you patent? Do patent it, please. Next week.
Sure.
Right.
Thank
Thank you for the suggestion. One more. Any more question or?
Sure.
Yeah. I have a query. Like this is an excellent method, but you use how many point in calibration curve?
5-point calibration curves, sir.
Excellent. That I wanted to hear.
And it is not like based on the based on the value we are expecting in our sample, we would increase even the points.
So
Like for if we want to go for the higher ranges of calibration also, we would definitely do it. In establishing the linearity, I have taken the standard from 0.5 ppm to 30 ppm. There are almost 8 to 10 points in that calibration graph.
That's okay. So,
So it has an excellent linearity over wide range of
and I
concentration.
wanted to know at how many points you use in the calibration curve.
5
That determines your everything. That is the
Yes,
backbone
yes.
of this
Yes, sir.
analysis. Secondly, this whole method is on the sample preparation.
Yes.
So, with this sample preparation and ICP-MS as your instrument, will it give a better result? Just a.
No, it actually depends on the concentrations what you are going to see, sir.
Say lower level concentration.
So lower level concentrations we can attain excellent results using ICP-MS. But when we are going
Better
to
than this.
Yes,
Yeah.
maybe. But when we are going for the higher levels like analysis of minerals
you
and
can
ores,
come
where we
into
are expecting percentage level of elements. All these elements we are going to expect them in the percentage level. So in such a condition, doing analysis using flame atomic absorption spectroscopy is the best method.
Thank you, sir. Thank you so much. Very good.
Compared to the other heavier elements actually, because ICP-MS techniques we best reserve for the higher elements having the higher masses actually, so there is a less interferences there. So when we go for like copper or other things by ICP-MS, then there will be a lot of interferences will be there actually, polyatomic interferences. So that's why that technique is not best reserved for base metal analysis, sir. So we can go for the all the trace and ultra trace elements.
Yes. Thank you so much. till it is single peak hopping, it can take care. Thank you so much.
Thank you, sir. Thank you.
So we go on to the next presentation, Degana Granite, future possibility of substantial enhancement of tungsten, lithium, rubidium resources by Dr. L.S. Shekhawat, sir.
Distinguished chair and equally distinguished audience. You see, the ये होगा ये हाँ हाँ बट इसको दबा के करना पड़ेगा मैडम इसको हाँ हाँ so if you look at I invite your kind attention please first दीजिए first पहला दीजिए इससे पहले का कैसे आएगा yes. See, the topic is quite, I think, it's eye-catching. Since this Degana area is already on the auction, and GSI has carried out G2 level of exploration here. So let us see what's there in the store. I think I can skip. Everyone knows here where the Degana is, and of course other tungsten occurrences in the Rajasthan. Now this is the map, geological map. It was mapped by S.S. Jain Sahab, a very hard-working geologist. It is partly modified during recent mapping of G3 and G2 level of explorations. Some professors from university also, they have also produced their maps. There is some difference. Nevertheless, point is, क्या मैडम चल नहीं रहा है ये? This is the last one, I think, lecture. So we still have time, good time, huh?
We have one more.
Okay, one more. Okay. So here, this is the Degana Pluton. It has some components. This is the main component. This is the coarse grained granite. Then there is yet another granite which is porphyry, and this is fine grained porphyry. This particular lithology, it is differently referred, but my topic, this topic will be concentrating on this particular lithology only. So here it is the top, near top, this temple is there. Then this particular lithology is variously referred, as I said. Someone called it Grison veins dominated brachia. Someone called it explosion brachia. I prefer to call it the kind of brachia or similar rock which is produced by hydrofracturing. So Dr. Golani referred in his address that this particular Degana granite is a specialized granite, agreed. Now the difference comes. He said it is highly differentiated one. My focus is on that this particular feature which hosts tungsten and lithium mineralization, this is the result of the first boiling. Again, first boiling happens when only 10% of the Pluton's Pluton crystallizes, and there is X solution. Why? Because of the adiabatic cooling, that is coming of the granite to the cellular levels. That is the main reason, and that leads to just after 10% of crystallization, X solution of the hydrothermal fluid. Another important point, why it is a result of hydrofracturing related to the first boiling only, uh, a topic very close to the Professor Dora. He was referring to the salinity of the hydrothermal fluids. So here salinity of the hydrothermal fluids is 12 to 20%, 22%. And you see, if we look at the granites in other parts of the granites means tungsten bearing granites in other parts of the world, there the situation is, it is again what Dr. Golani said, highly differentiated specialized granites having large concentration of granitophile elements. But their hydrothermal fluids have only low concentration of salinity. It doesn't go to the level of 22% or more than 15% anywhere. So this is another in fact evidence to support that this particular feature is the result of hydrofracturing related to the first boiling. Now this is the conceptual model, very famous conceptual model after Burnham. So here if you see, this is the, if you see from here, this is depth. So within 2 kilometers this granite intrusion is. Initially most of it is still fluid. Then only 10% crystallization is there, and just after 10% there is X solution, and that X solution, that in fact fluid which rose to the sides and on the top part, when the pressure, superincumbent load and pressure of this fluid, that balance disrupted, this explosion brachia forms, and these kind of vertical veins, vertical fluid veins forms. And here also we have vertical these Grison veins in this particular area. Here also if you see, it's vertical. So now if you see, the borehole plans of the Geological Survey of India, they have not targeted this particular lithology. Only in my opinion, only one borehole. Okay, I shall show you the subsurface. So topic is that further possibility. Now if you see, this is from the Professor Pandyan's paper. Now if you see that particular brachia, the conceptual model, he shows it a bit inclined. So although most of the workers have said it is highly differentiated granite, Professor Dr. Chattopadhyay of Geological Survey of India, they have a paper in mineralogy and petrology. They said that the granite, its kind of mineralogy and its kind of other characters, they suggest it is the result of depressurization. So what I mean to say, again, rising to the top, near top of the Earth's surface, and that has caused the exsolution. Now, if you see, this is from N.K. Sood Sahab, again a very sincere and hard-working geologist. So he has taken samples. This is the temple I referred to. On either side of the temple, you can see. So here the concentration of tungsten. So this is the north. The trend of this particular concentration is nearly north-south. Trend of the boreholes are north 50 east. So again, this particular anomaly is not fully addressed. Again, this is about the lithium. With respect to temple, you can yourself see. Again, now this is our latest geological map of Geological Survey of India. You can see the borehole, this particular borehole, that is borehole number 4A. That has gone through this particular lithology. Otherwise rest of the boreholes have nearly missed it. So I shall be coming to the section. Of course, data is of Geological Survey of India. Now you see this particular borehole 4A. You see so many tungsten values, anomalous tungsten values, and cutoff is 400 ppm. Number you see, number. Again, the reasons behind this particular level of resources were calculated up to 342 level, because earlier some kind of mining was there, but again this particular hydrothermal breccia or hydrofractured rock, which is here this much thick, they have not been mined earlier also. So for that, again there is possibility of adding resources from the datum which has been taken by Geological Survey of India in their resource calculation. This is with respect to another important element, that is lithium. Again you see lithium, lot of lithium bands correlatable to this particular our 5 number. 5 number, they say grazenite granite with quartz veins. This is the same lithology I am referring to. This is again with respect to rubidium, and this is the last slide. You just have a look at it and try to think over it. So thank you very much. This is the presentation and I expect questions.
Thank you, sir, for excellent insights and the possibility of augmenting resource by more exploration. Exploration actually is always dynamic, and level by level we can go on adding resources as the exploration matures to almost mining stage. So we'll quickly take a few questions if.
Yes, yes.
हाँ ये सब इसमें ये जो आपने देगाना का जो बताया ना तब अभी, तो इसमें और बालदा का जो ग्रेनाइट्स एंड जो टंगस्टन मिनरलाइजेशन है उसका, इज देयर एनी similarity or correlation between them, because there also it's grisning and shear zones and all this mineralization is confined to that zone only. So is it
Yes,
possible
yes.
that both are
Sir,
having the same?
before I answer your question, you have been HOD of Western Region, spearheading all the activities and exploration geologist yourself, you please comment the possibility, whether this possibility exists or this possibility doesn't exist.
No, it's a very interesting one what you have presented. I really appreciate it, and it's a really
Okay,
good thing.
thank you. Then
But
yes.
but on the same lines, I think because Balda was done quite long ago. So, but I have seen that Balda mineralization, and because I have not worked there in detail, but I think that it has to be seen in the same lines what you have presented in Degana. That's what
Sir, Balda difference you said, it is again a academic question. Here you see, as Dr. Golani Saab has also said, fluorine. He in fact devoted good time on fluorine or fluoride content of the water, anomalous content of the fluoride. We don't have boron here.
But fluorine in Balda also, fluorine has, I think, Dr.
Fluorine is
Gulani,
there,
yes,
but
yes, it is
boron
there.
is
It is there.
tourmaline is equally there.
Right, right.
If I am allowed to say, I can throw some light on what he says. If you remember that Chore has mapped a lot in Rajasthan, very hard-working geologist. He has told that Iranpura granite never intrudes Punagar or Sindret type of formations. So now the question comes, Iranpura granite is basement for these two younger topmost formations, topmost group of the Delhi sequence. That is Punagar in Pali area and this one. So means these two granites are different of younger age. I told that is still younger. So there is a correlation between high fluorine bearing, tourmaline bearing granite at Balda, which has a well developed region, and also age wise. Degana also come in the same range. So we should try to see the younger granites. Unfortunately, the younger granites are westernmost. Sendra is median of Delhi fold belt. You go to the margin of the Delhi fold belt, Iranpura type granite. Iranpura Kent itself is the where the name has come is also at the margin only. But if you go further to the west, which is concealed, you get the very important granites. That is the thing where WR can think over of intensifying their search for.
That's what.
So boron, it's a academic, but what Golani साहब said equally true. आपने भी कहा फ्लोरीन दोनों जगह है, फ्लोराइड भी दोनों जगह है. यहाँ पे हाँ एज वाइज इज सिमिलर, बोरोन बोरोन. और रिसेंटली साहब डॉक्टर पंडित, डॉक्टर मनोज पंडित of Rajasthan University, he has published a research with in association of foreign this thing. So he made a presentation on the ages of different granites. So I also happened to hear that audience I was also in the audience, and you see that kind of at least picture I had about the granites of Western Rajasthan. So far as modern dating techniques concerned, and the results which he presented, I have situation is changed altogether. So kindly go through that paper. I also requested him to please provide. तो देखिए साहब, if you have time, थोड़ा सा गुलानी साहब के है 2 मिनट. हाँ, okay sir.
बोलिए बोलिए सर.
In fact, Dr. Golani Saab was director PSS. HOD Saab was our beloved Kirmani Saab. So you see, he tried his best how to enter Degana again. And of course, being his friend, being his junior, I was also part of the discussion. So यार कैसे घुसे यार इसके अंदर, मैं बहुत इंटरेस्ट इनको यार देख के आएंगे क्या करेंगे. Now he requested his personal friend into Hindustan Zinc Limited, who was the last owner of that Degana lease. कि साहब कुछ डेटा दीजिए, आपने कहाँ तक काम किया है, हम गवर्नमेंट एजेंसी हैं, हम ऐसे ही काम कर देंगे कि जहाँ ऑलरेडी काम हुआ है एक्सप्लोरेशन का वहाँ कर देंगे तो हमारी फाल गिर जाएगी. सो प्लीज प्रोवाइड अस द डेटा. ही ट्राइड हिज बेस्ट, he could not locate the last exploration carried out by them in the Hindustan Zinc Limited. So Golani Saab got the promotion. He went as HOD of the GSI Turning Instrument. I was regional mission head, mission 2. So I had the problem in my mind. Then I went through the entire literature with respect to the Degana, and I came across a report of Khan and Lal, hydrochemistry. आपने बहुत इम्पोर्टेंस दिया उसका. Hydrochemistry, groundwater samples, some results were there with respect to tungsten also. So once we plotted that, we thought now this is the basis. And I planned boreholes 200 meters from the main exposure in the soil covered or in the say aeolian sand covered portions. So 200, nearly 30 boreholes, vertical boreholes. Idea was we shall be having the sample only. So once we have the sample, we shall be able to know whether it is a specialized granite or not. So once we know that it is a specialized granite, then we can go for the adjoining area. Main area में क्या है हमें पता नहीं है कि कहाँ तक एक्सप्लोरेशन हुआ, हम जा सकते एडजोनिंग में तो जा सकते हैं. तो इस तरह से ये काम चालू हुआ. तो आई एम वेरी हैप्पी that this particular block is on auction, and let us hope this someone will have it, and we shall have tungsten and lithium and rubidium mining activity again, and niobium also in the Degana area from 1913 to nearly 1990. Now let us hope from 2026 to onwards. Another very important point, sir. You see here rubidium, unlike tungsten and lithium. So here I showed three components, three different granites. So the granites which are tungsten bearing, that is grazinite granites, they have less rubidium than the ungrazinite granites. So that's why you see resources of rubidium, वॉल्यूम बढ़ गया तो रुबिडियम का रिसोर्सेज 15 मिलियन टन है और टंगस्टन का रिसोर्सेज 10 मिलियन टन है और लिथियम का रिसोर्सेज 5 मिलियन टन है. So thank you very much, sir.
Thank you so much, sir. We can continue this discussion during the lunch time. It's almost there.
Thank you.
We have the last presentation of this technical session is titled as such, Structural and Lithological Controls on Orogenic Gold Sulfide Mineralization in the Audi Formation, Mahakosal Belt, Central India. Implications for Proterozoic metallogeny. To be presented by Sri Vivek Kumar Maurya. He is there?
Sir, we have not received their presentation yet.
Okay.
So I think they are not here. They have not arrived yet.
So that's fine
sir,
with us, no problem. So
sir, I now request the chair and co-chair to kindly present their concluding remarks.
Okay, on this, firstly, I believe that when I am seeing the sessions parallelly going on, I believe the audience here is good. This is a good part that people are interested in mineral deposits and how to search and where to search, and what are the presently we are thinking about the mineral deposits, particularly in concealed terrains, and some good presentation on geochemistry, fluid inclusions, and Dr. Shekha was insightful thing. What he was referring was very important because Hindustan Zinc had one idea. It was leaked to us, told to us by our friend that if we mine the entire granite, how much will be the grade of tungsten? So I remember it was coming around 600 ppm or so. So 400 ppm or so. So 400 ppm granite and about 80 million ton, something like that. Oh, it is up to depth. At what depth you want to go? Surface level. But I find that from the later work, which was carried out by, there was a very good project by Bedrock Geology. Bedrock, the name is Bedrock only, by Groundwater Department for water as well as for bedrock. Their system is that as soon as you get the fresh rock, you end it. So those data are available, and I request HOD that this particular discussion which has taken place, it has opened new vistas for exploration and lake sediments also, which was unfortunately not done by AMD, and for the dead lake also, hectoritic type clays also, and it's a huge area. It's not that 1 square kilometer lake, it is about 15 square kilometer lake. It makes a deposit grade material to search. Structure is very big. So similarly, there should be more work, geophysical work, to be carried out in conjunction with what is known to us. I know that 40-meter down is granite. So geophysicists let them calibrate their method, and then where borals are not there, they can do it. Granite is or substrate is something like that. So maybe that this is a huge area. Permissive area is very big. So we have to otherwise plunge into the concealed tracks. So this is one of the foremost track, I would say. We should plunge in and put some resources. It's always a intense deep pocket is required to do it, but we must do it. And maybe Sandeep can say something.
Thank you, sir. We'll because almost it's lunchtime. We'll summarize. I'll just add on with Golani, so Dr. Golani, sir. The presentation, this technical session was on advances in understanding of ore formation, exploration, and resource challenges. So the keynote address by Dr. Golani actually was a sort of a primer to all GSI, Geological Survey of India, and other exploration organizations as well, to look at the areas where still it is potential, still it's very difficult to get those areas in Rajasthan, but then still there are a lot of areas and a lot of places where we can concentrate our next exploration program. So that was excellent. And on the same note, the Degana exploration and the granites, what and Dr. Shekhawat sir also shared his experiences and insights. Again, adds on to whatever exploration has been done till date. Degana, while doing the exploration in Degana, we had a lot of experiences and a lot of insights from where those experiences will be is definitely useful in other places where when we do the tungsten exploration. In this technical session, very quickly, we saw some very beautiful and good presentations. One from the chemical side that was really excellently presented, very confidently on a unified multi-acid digestion method. Really enhancement and fine-tuning of the chemical analysis, which is one of the backbone for our exploration in the country. And then the use of these proxies in zirconium, hafnium, and the other oxygen fugacity proxies, which can be used to test the fertility of the granite and thereby narrowing down the exploration of the critical minerals, because the list is more. Previously, there used to be those major minerals. Now there are 24 critical minerals to cater for. So then these proxies are coming very handy along with the AI, ML, and remote sensing and other things. So this petrography, proxy, chemical analysis, so all these things actually combines to the understanding of the ore formation, the mineral systems, and thereby addressing the resource challenges which we are finding day in and day out. So with that, we thank our all the presenters, including our keynote speaker, Dr. Gulani, Shekhawat sir, and all others for their excellent presentations, and to our all learned audience, our ex-HODs and all ex-GSI seniors, our present ADGs and others present here. Thank you so much. And with that, we conclude this session. Thank you so much.
Thank you, sir. Thank you for the concluding remarks and sharing your perspectives with us. I now request Shri Vijay V. Mughal, Additional Director General and HOD Western Region WR, to kindly come on stage and felicitate our respected chairs. Thank you, sir. With this, we formally conclude this technical session on ore formation and exploration challenges. I extend my heartfelt thanks to all participants, speakers, and delegates for making this session truly enlightening. And now it's time for a break, as I would like to invite you all to assemble in the conventional hall at upper ground floor, where a lunch has been arranged for your convenience. Please feel free to gather outside and let's reconvene at 14:30 hours positively. Thank you. प्रेजेंटेशन देनी है आप सबको प्लीज़ बता देना मैं थोड़ा लंच करके आ जाती हूँ आई तो ये TS4 में अभी उनकी प्रेजेंटेशन डाल देनी है ठीक है ये मैं रख के जा रही हूँ ये है टेक्निकल सेशन 4 ये प्रेजेंटेशन है उनसे आप पूछ लेना कौन से नंबर के 1 2 3 4 5 और बस इन्हीं नंबर से आप सेव कर देना ठीक है ठीक है ये हो गया बाकी लोगों को भी आप बता देना कोई और भी अगर हो तो उसको भी बता देना अगर कोई देने आया तो आप बताओ हम लंच करके फटाफट से आ जाएंगे थैंक यू सर थैंक यू सो मच Geological Insights for a Thriving Earth, the Critical Zone. The keynote of this session sets the perfect tone for this theme, the changing rivers, dynamics and resultants, by the eminent Professor Rajiv Sinha from IIT Kharagpur. To guide us through this session, we are honored to have two distinguished chairs with us. Our session chair, Supriya Kumar Saha, Additional Director General and HOD, Northeastern Region GSI, has extensive experience in geological mapping, geochemical surveys, thematic mapping, and mineral exploration across India, from Kolkata to Andaman and Nicobar, Maharashtra, Lucknow, and Shillong. His work spans a wide range of commodities, including gold, rare earth and refractory minerals, base metals, and apatite. And he has contributed notable publications such as Geology and Exploration for Gold in Kitari Adyal area, Bhandara district, Vidarbha region, Maharashtra. Our co-chair, Sri Sanjay Kumar Das, Deputy Director General, Odisha, is an experienced geoscientist with extensive contributions to geochemical and geophysical mapping across India. Sri Das has authored notable works and has been instrumental in major national programs under Mission 1 and Mission 1A, contributing significantly to baseline geoscience data generation. May I now invite Sri Supriya Kumar Saha sir and Sri Sanjay Kumar Das sir to kindly come on stage and preside over this session. May I now invite Sri Rohit Gaur sir, Senior Geologist, Geological Survey of India Western Region, to join us and assist in documenting the proceedings of this session as the rapporteur. It is now my privilege to introduce our keynote speaker for this session, Professor Rajiv Sinha, one of India's leading faces. Professor Sinha is from IIT Kanpur and is a leading authority on river dynamics and large river systems. His research on hydrological processes, geomorphic diversity, flood risk assessment, environmental flows, and sediment management has shaped major river management strategies in India. A significant part of his work includes the geomorphic and stratigraphic study of paleochannels in the northwest India, offering vital insights into river evolution and its link to the Harappa civilization. The founding head of IIT Kanpur's Department of Earth Sciences, he has authored over 200 publications with nearly 12,000 citations and is the recipient of several prestigious honors, including the Alexander von Humboldt Fellowship, National Mineral Award, and SS Mayer Award. Sir, with great respect, we invite you to the stage to deliver your keynote talk on the changing rivers, dynamics, and resultants.
ठीक है ठीक तो था just fine. नीचे वाला Yes, उसको उस पे जाना पड़ेगा. Okay. Okay, that's fine. I can manage. You have a changer or something, or there was a changer here, right? Okay, don't worry, don't worry. Okay. Okay. Good afternoon, everyone. And thank you, the Geological Survey of India, for inviting me here for this talk. I work on a very different time scales, modern time scales primarily, but I believe this topic would be of some interest to some of you. This is also a very difficult session to speak on. Most people have just come back from a very, very presumptuous lunch. So I would try to keep you awake if possible. The topic which was given to me was on the changing rivers, dynamics and resultants. And I've worked on the rivers for a very long time on various time scales, from about 100 to 100,000 year time scales to a modern time scale. For today, I have chosen the work which I have been doing over the last decade or so on the modern time scales, on how the rivers have been changing through time, particularly at the Anthropocene time scale, although the term has not been accepted by the geological community, but it exists anyway. So why are rivers important? I think most of us know this. Rivers have always been the backbone of the ancient civilization as well as the modern civilization. They secure our freshwater requirements, or they have for many, many decades and for many, many centuries, and also for the prehistoric timescales. It is a system which is one of the most essential of the natural resources, and yet constantly threatened by the human activities, and stand to be further affected by many of the interventions, many of the other processes, resource exploitation, etc., and so on. So if you need to create a sustainable society, I think water conservation, river health considerations are going to be extremely important for the modern society. Before we get to that, I thought of including this very fundamental slide which explains what actually drives the river change. The rivers, as most of us know, are conduits of water as well as sediments. And this was one of the very famous model by Lane 55 model, which tells us that it is the balance between between the hydrology part of the water, which is again stream slope and stream power, and the sediment part of the system, which ultimately governs how and which direction they will actually change. So if you look at the natural drivers of the water or rivers, basically, or river runoff, they are basically the same hydrological cycle parameters: precipitation, evapotranspiration, Q surface, Q snowmelt, groundwater flows, etc. So here, the climate is the main driver of the river runoff. But if you look at the sediment production and mobilization, and that's where the geology and climate, they play an integrated role as as a main driver for the sediment fluxes, basically. So what has changed through time is that we have seen, even at a historical time scale, that the fluxes of both water and sediment have changed through time. What we are trying to do is to understand what are the drivers of this change through time, natural versus as well as anthropogenic drivers, and what are the impacts of these changes which we see, which are visible on the river morphology, river dynamics, river processes, and so on. That's what I'm going to do in the next few minutes. Why is it important? Because it decides the future trajectory of the change. We need to know that because we need to then make modifications for our river management strategies, make modifications on the structures which we have built, and of course create how the future rivers will actually going to look like. So this driver, this balance between the sediment and the water part has to be maintained. If you don't maintain that balance, either the river will degrade or it will aggrade, basically. That's basically what we have learned from this very basic model. The other point I wanted to drive before we proceed on looking at some examples is that we also need to understand the difference between the river behavior and change. Uh, River behavior is the natural capacity of the adjustment of a river. River is a dynamic system and they keep on changing through time anyway. And therefore, when the river is changing, in such a way that the basic reach scale geomorphic attributes are maintained, we call them within the ambit of the natural behavior of the river, right? They are maintained. But then when you talk about the whole scale shift of the river, which is way beyond the capacity of the river to adjust, that is basically when the rivers are changing. And these eventually brings about a very new set of forms and process relationship. So it is very important for us to understand or differentiate the river behavior from change. What is the natural behavior of the river and what is the change which have been imposed upon either by the natural drivers like climate change, for example, or by the anthropogenic drivers, etc., and so on. So whenever, typically what we do is that what we understand is that whenever a big change in the system happens, we talk about a breaching of a threshold here. So there are natural thresholds which are operating within our system, rivers included, and they cross the threshold when the change goes beyond a certain limit. So there are, for example, this is a threshold, a geomorphic threshold to define when the river will develop, for example, a gully or when will not develop the gully. So likewise, many processes of the rivers are defined by such thresholds. Our job as a geomorphologist is to identify these thresholds and make sure that we don't cross this threshold, for example, through time. Then why do we and how do we do that? Our approach generally is to develop the process response framework. This is an example of a process response framework which try to identify the interlinkages of the river processes and the feedback loops, for example. So if you start with a flood discharge of a river, for example, it will lead, if you exceed that threshold, it will lead to the bank erosion hazard. It will then lead to more sediment production. It will then lead to erosion, river width changes, river migration, and all of that. So these are the processes which are triggered by exceedance of the threshold of, let's say, a flood discharge. Similarly, if you exceed the river sediment load threshold, you will then lead to changes in river bed level, and the conveying capacity of the river will change, and therefore it will lead to other hazards like river migration, mobility, super elevation, flooding, etc., and so on. So this is just one example of a threshold or a process response framework, and if you understand this framework, you can then try and develop what is obviously called as the morphodynamic modeling, for example. So morphodynamic modeling of the river is typically based on such kind of process response framework. So let's see. These are some of the examples of the rivers in the Himalayan foreland which have been changing through time. Many of these rivers have changed through time. They are very dynamic. They are mobile. You can see some examples of the shifting of the bank line of the Gagara, Sharda, Kosi, the 2008 example of the Evolution shift, Rapti. All of these rivers are known to be extremely dynamic. What we have been trying to do over the years is to try and see how to quantify that disturbance in the rivers, how to define these disturbance or dynamics with reference to some kind of a reference condition. So for this talk, I have chosen 3 topics: flood risk and vulnerability, river morphodynamics, sediment dynamics, excess versus extraction, and then we'll try and see how we develop the effective river management strategies to reduce these river-related hazards and so on. So the fundamental point is again that how do we strike a balance between the human needs and the river ecosystem protection? That's basically the fundamental point we are trying to examine. So I'll start with this very famous case of the Kosi River. Everybody knows Kosi River, which flows through the North Bihar, comes from Nepal and Tibet, and then eventually drains through the plains of Bihar. What you look at here is how the interventions on the river, particularly in terms of the Kosi Barrage, which came up in 1963, and then the embankment, which came up around the same time, 55, 56, they changed the entire behavior of the river, with the river which was sweeping across, building a large-scale landform. The mega fan, as we call it, has now been confined to flow within the channel or within the embankment, and that has resulted into a huge change in the dynamics or in the morphodynamics or the morphology of the river, as you can see from the successive maps here, for example. So all of these long, all of these channels which you see here, the paleo channels which they recorded and documented the long migration history of the Kosi River, they're all defunct now, most of them, but then they do get activated 2 times. I'll show you an example in a minute. And of course, the interventions have also modified, the river in a big way. And one big example of the disaster such kind of morphodynamics can create is obviously the August 2008 avulsion, for example, which we know of, on which on this day the big river like Kosi moved by about 120 kilometers in just one shot. It swept across a very large population, affected some 3.5 million people in the whole state of Bihar and of course Nepal. And so we looked at the causal factors of that avulsion, and it was very obvious to us that the construction of the embankment and the subsequent aggradation of the river bed, creating what is called as a super elevated river, created that avulsion, through time. It crossed the threshold of the flow along the river, and it basically crossed and breached the embankment, and eventually caused that big avulsion, which we talked about. We verified that with further analysis. We've mapped the entire river. We looked at the river stretches which are super elevated. So when the river is super elevated, instead of flowing along the river, basically it starts to breach the embankment, and basically the lateral gradient of the river actually becomes larger or higher than the longitudinal gradient. So that's basically is a fundamental problem. So therefore, the points, in case of such rivers which are highly impacted by such interventions, the river mobility, river morphodynamics, and the resultant floods are not controlled only by the hydrological or hydrometeorological parameters, but also because of the local geomorphic conditions. So, for example, this event happened at a very, very low discharge, almost 1/10 of the defined river carrying capacity, and still it impacted a large number of people, and of course created a very large scale landscape event. So this is what I call as a landscape forming event. You can see that an entire new landscape was created because of this major avulsion. So we tried to model this using a simple topography driven model, and we actually simulated the avulsion path, which actually matched quite nicely. And you can see on the right hand side, you can see the modeled path of the channel and the actual path of the channel, which actually coincides quite well. So the advantage of these events therefore provided us to develop such kind of models. We actually tested that model on other points as well, and we predicted the avulsion pathways of the river at several points. We supplied the data to the local government, and they went and then those points, and hopefully, unfortunately, no further disaster happened after that. So that is an advantage of such kind of topography-driven model, which can not only be used as a postmortem analysis, but also can be used for predicting the future pathways of these rivers. Let's look at the other phenomena, the flood part of the story here. Flood is a major problem globally, India included. India is particularly vulnerable because we have a very large population density staying in the flood-prone areas, and therefore the damage and the vulnerability is actually very, very high in such areas. So and if you look at the globally, even if you are putting in a lot of investment on these rivers in terms of flood mitigation measures, the hazard and the risk are still increasing. And not just India, but many, many other parts of the world. Why does it happen? Because we are not trying to understand the processes which are behind these rivers. We are not trying to understand the correct management strategies. For example, levees, embankments are not the correct strategies for rivers like the Himalayan river, which are very high in terms of the sediment flux. So when you make an embankment, you confine the river, you grade the bed level at by 10 times the rate, the natural rate, and eventually the river starts breaching and flooding, for example. So these are usual problems, and of course we have started living very close to the river. River zoning concept is still in a very infancy stage. We need to implement that as soon as possible and so on. So therefore, it is not the river which is hurting you. You are actually hurting the river, and the river just gives you back in return, for example. So there are again modern technologies and ways to assess the flood risk and vulnerability. We have just initiated a large project on the Ghagra Basin, which is again one of the most flood impacted rivers in UP, where we looked at the entire time series data of flood inundation using the SAR. When we do this kind of flood inundation mapping, optical data do have a serious problem because they are not cloud penetrating. So we looked at the SAR data, which have a cloud penetrating capability. We looked at the annual inundation time series. Again, the idea was not just to produce a map, but to understand why certain reaches of a river are more prone to flooding than the others, for example. So these are just the maps, but then when we looked deeply into the issues, why certain reaches are more vulnerable to flood, we again realized that the sites, the locations which are more vulnerable to floods are again controlled by the local changes in river morphodynamics. For example, when we looked at the flood water level data and the discharge data here, if you see the correlation here, normally if you are increasing the water level, your discharge should also increase. We found that there are 457 times when the discharge and the water level data sets actually show opposite trends, which is unusual. And that is happening because you are changing the cross-sectional morphology of the river so drastically. In a span of about 8-10 years, the river bed is rising or incising by 8 to 10 meters. That's absolutely phenomenal changes. If you do not take that into account into modeling or calculating the discharges, you are obviously going to get very, very wrong results, for example, and so on. So therefore, the geomorphic and hydrological interactions need to be understood, which drive the flood hazard in a big way. The cross-sectional changes are one of the parameters, which are again driven by either higher discharge or higher sediment flux, for example. Again, back to the Stewart, the lanes model, for example, and so on. So that's one example. The second example again comes from the upper part of the same river, which is called Karnali in Nepal. And again, the role of the dynamic flood topography was very well illustrated in this paper by a group in Edinburgh, and they showed that if the data which you're using, the resolution of the data which you're using actually ultimately will affect the inundations you will get. So if you use, if you change from modeling strategies, if you represent the channel geometry better, then you can see that there is a 14% increase in the flood inundation areas. If you, for example, improve the dam resolution, you can see again you can do a further 9.5% increase in the inundation areas. And then if you again do some minor resampling effects, etc. So the question again is that when we are producing this kind of flood inundation maps, and if we are not taking into account the channel geometry, or if you're not using enough resolution of the data, you're likely to get very, very wrong results, for example, and so on. Again, the other point is that if you're also using different kinds of scenarios, for example, if you reduce the bed level by about 1.8 meters, you can see how much change will happen, minus 36%. If you increase the bed level, then again the simulation showed that your flood inundation areas will actually change. So what all of this is telling you that in all of these hydrodynamic models, we are supposed to to introduce these parameters of the local scale morphodynamic changes, and then only you will get the right kind of right kind of patterns. Let's very quickly move to sediment dynamics, which has been a very, very interesting and a very, close topic for me. We have two problems in the Himalayan rivers. One is the excess problem. We have excess sedimentation, as I told you, which leads to a lot of problems related to breaching, related to flooding and so on. We also have a problem of excess extraction, which is also called sand mining, for example, a huge problem, which again results into very, very serious problems of channel incisions, for example, bed armoring, ecology effects, and so on. Again, the question is, how do we achieve a balance between these two processes and achieve some kind of a sediment management strategies? So this I've already shown. I will not repeat it. There are many other examples apart from the Kosi where the excessive sedimentation in the rivers have created havoc. The Haridwar, Rishikesh, Uttarakhand floods, for example, Indus flood, for example, and recently, of course, the Dharali event, which happened in 2025, Himachal Pradesh, again. All of these, rivers which are flooding and creating disasters is not just because they have a high amount of water. They are creating hazards because the sediment concentration in these flows, the hyper concentrated flows, when that flows along the river, it has at least 10 times more erosive power than just the water. And that is what is creating the problem, what you see in many parts of the world. So these are some examples of the impact of the morphodynamics and sediment dynamics relationship which we looked at. We looked at the entire stretch of a Ganga river from Buxa to Farakka. We looked at where are the vulnerable reaches which are excessively sedimented and where the government should actually take the precautions to extract these sediments. We also estimated the volumes of sediments which are accumulating at reach scale parameters, and these are some data set which are primarily based on the planform mapping and also the UV based mapping, etc., and so on. And just to give you a sense, the total silt volume which we calculated between Buxar and Farakka was about 3,094 million meter cubes of sediment, which actually should be extracted, for example. And the extractable volume is again very high, 2,438 million meter cubes of sediment. To give you a sense what these numbers mean, it means about 600 million trucks of sediment load, which you're talking about. Even if you talk about the extractable sediment, we are talking about 350 million trucks of load of sediment which you're talking about. So it is not an easy job to do that. Even if you want to extract the sediments, the bigger problem is where do you keep them and what do you do with that actually. So it's not just, so we gave them, I am not discussing that, but we gave a complete sediment management plan to the Bihar government as well. And of course, they are still not implemented and so on. So last topic I wanted to touch very quickly is sand mining. Sand mining is again a huge problem in many of the Himalayan rivers. So one set of a problem is that where we have an excessive sediment, we are not able to extract them and use them. The other side of the problem is that we are extracting sediment from places where we should not be doing it, right? So this is one example of the Gaula River, a rather infamous river where the entire 33-kilometer stretch of a river is very, very heavily mined. And the impacts of sand mining has been very well documented. So I'll show you some quick examples. So this is what you have done, or we have done to these rivers. If you look at these rivers, the upper stretch of a river, for example, between 1976 to 2021, this is how the river has changed through time. The mining started in 89 in these reaches here. Look at the middle part of the river. River has totally disappeared from a nice multi-channel braided system. It has become a nala, which actually flows for, let's say, 10, 15 days in a year, and the rest of the time it is dry. So this entire reach has lost the complete morphology, biology, ecology doesn't exist anymore. And there is, of course, a very significant change in the channel morphology as well. So this is exactly the problem is. So we looked at many indices. This is a published work, so you can look at it. We looked at many indices. We designed new indices. We looked at, we mapped the multiple hotspots of these rivers. Unfortunately, the government has taken a hint from here. So they have now released this report, and they have basically going for a policy level decision on that, what to do with these rivers, and these policies will be then implemented not only on this river, but hopefully across the country as well. So that's the kind of impact which we need to bring to this kind of work. So these are the multiple hotspots which we created based on the platform data, and then of course we documented the entire, entire effect on these, for example. So you can see, look at this bridge pier here. I mean, many of you may be engineering geologists here. You look at these piers, they are entirely exposed because of the sand mining. How long they will stand, how long they will, they will be operational, only God knows. Look at the incision of about 11 meters along the bank. Look at the 4 to 5 meters of incision in the river bed. These are not isolated examples. These are examples. This is what you see in the entire 33-kilometer stretch of a river. This is what we have done to these rivers, for example. So these rivers are no longer a river. If anybody is coming from that region, he would know, you would actually start crying if you look at these rivers, for example. So based on this, we developed, again, this is what I normally do. I developed a process response framework. So if you are doing an excessive excavation from the channel, you will create changes in the base level. That will change your stream power, and that eventually concentrates the flow and then eventually incises the entire river channel, and you change the entire morphology in terms of river mobility, wet channel area, and of course the channel width, etc., and so on. The other major effect which happens here is the bed armoring effect, because you selectively remove the finer material, so the coastal materials are left, and therefore you lose the connectivity, you lose the sediment transport capacity of the river, and then you start eroding the river again. So the entire geomorphic diversity of a river basically gets disturbed because of one single process of excessive sediment extraction. So the idea should be that you should actually have a managed extraction. The areas which are aggrading, that's where the sediment should be extracted. So you need a very comprehensive sand mining policy on this. It is not that these policies are not existing, they do exist, but the ground realities and the ground implementation is actually very, very poor. So just to close, I hope I have kept the time. There are many, many examples of very significant morphodynamics of the Himalayan rivers, which are caused either by the natural processes or by the anthropogenic drivers. And this is where the river behavior and change need to be distinguished. Sediment dynamics is one of the major controls which affects the morphodynamics in a big way, resulting into either the floods or erosion, or into other problems of sand mining, etc., and so on. So excessive mining is bad. We need to develop a very comprehensive strategies, and I think the only way to understand these processes are to develop a process-based framework and then base our policy on that, basically, rather than blindly doing that. So ultimate idea is that the understanding of the river processes should lead to the improvement of the river health through time. So changing rivers are good, so they are supposed to change, but not to the extent that you change the entire system altogether. Thank you so much for your attention. I'll be happy to answer a few questions if there is time. Thank you. I can hear you. Go ahead. Mm-hmm. Yes, we have done the similar work on two other rivers, Damodar and Son as well. I didn't have time to show those results. I just focused on one set. But yes, generally the process works in a similar way, but we found that the impacts are different. For example, in peninsular rivers, many peninsular rivers, interestingly, the mining has actually expanded from channel to floodplain. And there's a very obvious reason for that, because these are sediment deficient rivers, right? Peninsular rivers do not supply so much of river as the Himalayas do. So after about 5-10 years of mining, the channel sediments actually, they get depleted. So they move to the floodplains, they move to the paleo channels and so on. So there we found rivers like Damodar and so on, the impact of the mining is much, much widespread. Here at least the impact is located or limited to the river channel. There the impact is way, way across the river into the floodplains, etc. and so on. So there are very large areas extending up to several kilometers from the floodplain, from the river channel into the floodplain are actually impacted by the river. So huge impacts. And the processes and the impacts are also different. So the floodplain, so there we found that the major effect is the landscape fragmentation. So the landscape gets totally fragmented within the channel as well as outside the channel as well. So that's a very major effect, yeah.
Do you have additional variables in your formulas or in the models when it comes to the Peninsula River and the Himalayan rivers?
Well, we have done, for the Himalayan river, we have done now a sediment transport model also. I didn't again show the results, but that is again getting published. But for the Peninsula river, we haven't tried the sediment transport model, but we will try that. But yes, I think we need to introduce some additional parameters when we try to develop the process response model, particularly because the processes are the disconnectivity between the floodplain and the river channel. That's an additional parameter which will come into the process response model, which we are still trying to develop that. Yes.
How do we translate these studies into a common man's language? Because they don't agree. If you say that your sand mining is killing your river, they don't agree. But
yes, I mean that's a very fundamental question, because end of the day, this is related to the livelihood of the local population. So first thing is that we need to define the timing and the limits of extraction of sand. We are not saying, at least for the Himalayan rivers, I am not saying that sand is an important commodity and we need that. It's an important resource material for which we do not have a replacement yet, right? So therefore we need that material. The question is that how much and how much and when. So what we found that these rivers have, for example, I didn't point it out, but even in this river, there was a time period which was the COVID time period, 2020 to 21. And it was surprising to see that in just two years, when the mining was not happening, river actually recovered very fast. So many of these rivers have a very strong and very high capacity or high resilience in terms of recovering. So all you need to do is to limit the mining to certain stretches and allow the other stretches to recoup and then move to the other side. So there are strategies which we need to tell them. So that telling has to be done to the policy makers as well as to the common people. We are attacking the first end right now. The NMCG of Government of India, they are now issuing directions to all the states to follow these guidelines, and then we will come down to the people as well at some point of time. Thank you.
Thank you, sir.
One more information.
We need a balance of each and every.
Yes, of course. Yes, that's exactly the point is.
Sir, one information.
Yeah.
On Kosi Mega Fan, one 5-minute video has been prepared by GSI. It was prepared when I was posted in Patna, and it is already uploaded in GSI portal. Anybody can see it and appreciate the work.
Very good. Thank you.
It was prepared based on your documents, sir.
Thank you. Thank you so much. I didn't know that. I'll also look at it.
That 5-minute video is there.
Okay.
That meandering Oxbow Lake.
Okay.
Oxbow lakes are clearly shown because drone photography was taken.
Yes.
And how wetlands are formed because of this. All these things are documented. One can see it from that.
Thank you so much.
So I would humbly request you to stay with us on the stage.
Okay.
So thank you so much for this insightful talk and sharing your expertise with us. May I now request Shri LMS Mora, Deputy Director General and Regional Mission Head 2, to kindly come up and felicitate our esteemed guest by presenting him a memento. Thank you so much, sir. We will now proceed with the technical presentations for this session. We have a total of 5 presentations, and I request each speaker to kindly adhere to the allotted timings, please. I also request our chairs to kindly moderate the session timings, the presentation timings for this session, sir. Okay, sir, you can now begin.
Groundwater sustainability challenges in Rajasthan, decadal analysis of recharge and extraction imbalances by Maria Dominic, Priti Pandey, Priya Kankar, Sharma. Who is going to present? Priti Pandey. Okay. So 10 minutes for presentation, which will be followed by 5 minutes of discussion.
No, please take the mic because once you move from here, the sound is not audible. I request you to please take the mic. He will assist you. No, please. No, it is not actually. You have to take it the other way. No, no, just yeah, like this. Just take it like this. And put it over your head like that. And you have to keep it somewhere. Do you have a towel or anything? Could you please tuck it here or maybe take in hand if you are uncomfortable. I think okay.
On it?
Yeah. Just let me check.
Hello.
Is it okay?
Hello?
Yes.
I'm audible. So my warm regards to the dignitaries and everyone present here from the different organizations in GSI. Myself, Preeti Pandey, scientist C. I'm from CGWB, Western Region, Jaipur. And as you can see, my topic of the paper is groundwater sustainability challenges in Rajasthan, decadal analysis of recharge and extraction imbalances. So CGWB is a pioneer organization working in the groundwater. So it's not moving here.
What happened?
I think some problem is there.
Just a moment.
This is the PPT.
Yeah, this is your PPT.
Slide mode.
No, this is the slide mode.
Okay, okay.
This is how he is going to show it over there.
Okay. So from here, it can be moved from here, no?
You can, yeah, you can use this mouse.
Okay. So this is the introduction part. As we are working here in Rajasthan, so I have taken the topic of Rajasthan. This is this figure 1. This is our study area. It is the map of Rajasthan, and it is showing the categorization of different blocks in the Rajasthan, having different categories as per dynamic groundwater resources assessment done by CGWB. This is the latest map of 2025, and as you can see in the index, they are overexploited, semi-critical, critical, saline, and safe areas. Actually, this legend is and these categories are based on nothing but the ratio of total annual extractable groundwater resources and the resources that we are extracting everywhere. So if this ratio is more than 100%, it means we are extracting higher than the replenishable groundwater resources everywhere, and then it is categorized, this unit is categorized as overexploited. And if it is less than 100 and it is more than 90, then it is semi-critical. Likewise. So as you can see from the map of Rajasthan, red areas are prominent. It means our state in the terms of groundwater is in risk zone. So because, why is it in risk zone? Because as you can see, in the absence of any perennial and big rivers, our dependency mainly in irrigation sector as well as industrial sector and domestic sector is on groundwater. So command areas are actually about 60%, 59 to 60%, and poor area that is quality tagged with salinity and fluoride is also much, that is 28%, and command area is very low, especially in the Indira Gandhi Canal areas, they are command areas. So the dependency on groundwater is high. That's why the condition of Rajasthan is very poor. Secondly, I would like to mention that I have not showed here in slide that how do we do resource estimation is based on the GEC 2015 methodology that CGWB is adopting. So from time to time changes in the methodology is being done, and assessment units in the Rajasthan are blocks only. So we have taken the decadal trend of the state of Rajasthan with respect to the net groundwater recharge and the gross extraction. And as I have said, the ratio of these two parameters is the stage of groundwater extraction. So over the decade from 2011 to 23, as we can see in the bar diagram, the condition of the Rajasthan is deteriorating over the years. So gross extraction is it consistently exceeds recharge, indicating increasing abstraction pressure over time. As I have already mentioned that there are no alternative sources of water here in Rajasthan, so dependency on groundwater is high. That's why we have already crossed the limit of annual replenishable groundwater resources, and thus we are extracting. And basically, what we are doing is groundwater mining. The gap is widening, and it signifies progressive aquifer depletion, and the groundwater is also declining in the aquifers. So this is this graph is showing the data from 2011 to 2024, and we have changed the methodology from 1997 GEC to 2015 GEC, but the condition is showing worsening effect only. So this is the objective of our paper, that is to evaluate the long-term sustainability of Rajasthan dynamic groundwater resources by analyzing decadal trends in recharge, extraction, their imbalances in recharge, and how it is resulting in the sustainability gap in the districts. So I have taken here the number of assessment units. Earlier, before 2017, there were 248 assessment units that were blocks on which we were categorizing and monitoring our dynamic groundwater resources. And later on, these units have been further bifurcated as per the administrative purposes, and now there are 302 assessment units in Rajasthan, including 7 urban assessment units. So from over the years, as we can say, safe means the category, the norms for safe units is that we are extracting 70% of what is recharged in the aquifer. So the units that are falling below that limit are categorized as safe, and that safe units over the decade have been decreased actually from 18 to 12%. And overexploited units, that is we are exceeding the annual replenishable groundwater resources are exceeding from 71% to higher figures. So what methodology we have used here for sustainability analysis is, first one is we have generated heat maps. Second, we have studied sustainability threshold and gap indices. And third, we have done the trend analysis. So first of all, talking about the special assessment heat map, what we have done, we have plotted the district-wise condition of the districts in which gap is higher or low, and then we will analyze in the next slide. The second is the sustainability gap. We have what the formula we have used is that gap is equal to extraction subtracted 0.7 means 70% of recharge basically, and the results will be like this. If the gap is positive, it means we are extracting more than the recharge, and that aquifer will be unsustainable over the period of time if the situation continues like this. If there is very zero to slight positive change, that the district or the assessment unit is on the verge of deterioration. And if it is negative gap, means recharge is exceeding the extraction over time and it is going towards sustainable. In the trend analysis, what we have done, we have plotted the linear regression method we have adopted, and we have acquired R square and P values. We will discuss later in the slide. The first one is the heat map. As you can see, as 2013, as 2015, these are all the years for the sustainability, and they are plotted against sustainability gap. And the red areas are showing more sustainability gap. And as you can see, many districts like Jaipur, Alwar, Jodhpur, Nagaur, they are consistently over the years, over the decade, they are in red zones, indicating that from over last decade, we are extracting more than we are recharging in these districts. But there are few districts like Hanumangarh, Dungarpur, Ganganagar, Banswara, they are having negative gap. It means recharge is exceeding. And this is the results for the second methodology we have used, that we have plotted the sustainability gap for each of the district from 2013 to 2024, that is for a difference of a decade. So as you can see, this red lines, they are indicating positive gap, and positive gap means that the condition of the district or assessment unit is worsening over the decade. And and this green lines, they are showing the improving condition. These are for the Alwar, Jhunjhunu, Jalore, Ganganagar. Actually, out of 33 districts, only 9 here are showing improving condition from decade, and rest are showing worsening condition only. So the third, we have nothing. We have taken the slope and R square value, and these are matching very well. That over the decade, this gap is increasing. We have taken here. Actually, we have plotted for every district of the 33 district, but we have taken the example of Sikar that is showing worsening condition, and here both R square and P value are supporting each other, depicting that yes, in the Sikar district, we are extracting consistently over the years what is their replenishable resources. So based on this, in our results, what we found that some district like Bara, Badmer, Bundi, these are significantly worsening, and there are some district like Ajmer, Bhilwara that are on the moderate verge. So improvement, they are significant in two districts, Dungarpur and Hanumangarh. One possible reason is there because there is surface water alternate source also there. So the conclusion of this study is that groundwater conditions in Rajasthan are in many of the districts, there is wide gap that is increasing between extraction and recharge. There is imbalance, and this gap of imbalance is increasing. And heat maps reveals that there is stress in the central, western, and northeastern districts. And trend analysis confirms that significant long-term deterioration in many districts, especially 13 districts, with the fastest worsening in these districts like Sikar, Badmer, Jaisalmer, Dausa, Churu, Jhalawar. And only two districts, Dungarpur and Hanumangarh, as per our study, is showing statistically significant improvement, though that improvement is also limited. So the combined result shows critical worsening groundwater sustainability requirement, interventions of management plans, demand side, supply side, everything, and people awareness, community participation for making the sustainable aquifers. Thank you.
Thank you for the very good presentation. Now I invite questions from the audience.
Yes, sir. Sir, our primary consumer in groundwater sector is irrigation only. Although industries and domestic purposes are also utilizing, but their proportion is very less.
What is the effect of that? Like how people are managing the deficit? The way the resources are
Sir, actually irrigation sector is using 87% of the groundwater resources. And as far as for domestic purposes and industrial purposes, they are actually, sir, this number is unaccounted. Whatever we get data from the government sources only, there are many sources of the groundwater withdrawal sources, that hand pumps might be there, they are unaccounted. But as far as we get any data, they are managing from groundwater only, sir. And what the PhD is supplying data from Bisalpur in the urban Jaipur, as you have asked in the study area, they are supplying from the Bisalpur, yet the deficit is there. In the demand and supply gap is there, sir.
So, Madam, in this context, I'd like
Yes,
to
sir.
know what are your message to government, how we can regulate this? Because unless there is a balance, that affects the quality of water, right?
Yes, sir. Yes, sir.
And the quantum of water too.
Yes, sir.
So, what are the suggestions, what are the regulations you have proposed, and whether those things are being exercised by the government, or we are neglecting your suggestions?
No, sir. Actually, the message from time to time is being given from different organizations, including we. But I think there is a missing link between the awareness of the people, because water is such a topic, water is such a thing that is being used day to day, and people think that it's my right, I can drill here and I can utilize the water, it's in my land, then it's my water. But actually it is a aquifer water, not your water only.
Exactly.
Since we need to sensitize community, we need to sensitize social, IC activities we carry out. Until and unless there will be awareness, then
Awareness, right.
it won't be possible, sir. And apart from this, sir, CGWB is having master plans also, that is area specific interventions. Depending on the geomorphology, aquifer, what is the depth to water level there, we have area specific plans that can be implemented and is actually being implemented in Jal Jeevan Mission also. Sustainability studies are done being based on our studies only. So the main thing is that we have to involve community, we have to aware them to make it sustainable.
In this township, have you proposed any water chargeability? Water is a rechargeable mandatory? Is it?
Yes, sir. Yes, sir. Actually, it's in the Rajasthan state government has made it mandatory that rooftops having area greater than 300 meters square, they should have rainwater harvesting structures. In our office premises also we have, but that should be lawfully intact.
Thank you. I will move to the next lecture. Now I invite for next topic is the impact of pre-existing carbonate cements on the efficiency and security of injected CO2. Kartik Patel and Achit Mishra. Who is going to present?
Sir, I think the presenters are not there as they have not submitted their presentation also.
Okay.
We can move on to the next.
Move on to the next one. Re-evaluating Acadia nilotia, a potential asset for climate adaptation and coastal sustainability. Sri Parvati S. and Pankaj Khanna. Who is presenting? Parvati S.
It's working. Okay. So this is the point. Yeah, you can move it backward and forward with this, and this is the cursor you can use as a pointer.
Okay, thank you.
Screens, please.
Good afternoon, everyone. I am Sri Parvati. I am a PhD scholar from Indian Institute of Technology, Gandhinagar. So I'll be presenting my topic, Reevaluating Acacia nilotica, a potential asset for climate adaptation and coastal sustainability, which has been a small work we had done during my PhD work under Dr. Pankaj Khanna, who is my PhD supervisor. So this topic literally talks about the impact of Acacia nilotica species, which has been widely seen over Gujarat and Rajasthan regions in the carbon sequestration potentiality and how they have an impact on the shoreline change. So I'll start with the global context. So I would like to say that like 15.6 billion tons of annual carbon dioxide has been absorbed by the world foresters. So we can say that the forests are an effective natural carbon sink. And approximately 40 percentage of carbon has been offsetted by this ecosystem, which we can say that it is critical when we talk about the net zero goals. And despite of their importance, 18.1 billion tons of carbon dioxide has been leaked back to the atmosphere each year because of the degradation and deforestation activities. So talking about the Indian context, the types of forest in India includes Himalayan dry temperate forest, Himalayan moist temperate forest, liberland sam forest and all. So we can see that the tropical thorn forest, which is seen in the cream color, have a significant amount of area under them. So these thorn forest has been vegetated by a lot of fabaceous species, which include Acacia nilotica, Procifus juliflora, and many more. So I'll be talking about the Acacia nilotica species, which have a potential high sequestration rate of carbon dioxide with an impressive biomass and soil organic carbon. And the main important thing is they are drought resistant and saline soil resistance. So my methodology that I had used here, I had integrated three set of data collection. Like I had used UAV data set, field measurements and satellite imagery. So I integrated all the three data sets to derive out how these have an impact on the carbon sequestration potential and the sea level shoreline changes. So using UAV data set, I had created the digital surface model, digital terrain model, and from that I had found out the canopy height model. And from field I had collected the field measurements, which includes the diameter, breast height, and the number of branches. So the main two parameters I had used to find out the carbon stock was the canopy like height and the diameter of the tree, and using the equation like allometric equation I had found out the above ground biomass, below ground biomass, and the total biomass, which intact gives us the carbon stock of that biomass. And using the satellite data, soil grid data set, I had derived out the soil carbon content, and also using the normalized differential water index, I had found out how the shoreline has been impacted by this ecosystem. So the study has been done on Bhavnagar district of Gujarat. In Bhavnagar, I had selected the Hada Bangalore region because there was a high dense canopy thickness has been seen in this region. And the dots that you see here were the representative samples where I had collected the diameter breast height. And this is a table which shows the diameter breast height where I had found out from the Hadab region, and this is the digital surface model and digital terrain model and the canopy model which gives us the height of the canopy for further carbon stock estimations. And the allometric equation I had used was by Chavan et al., Jaiswal et al., and Mishra et al., which has been cited by many more. So the allometric equation uses the volume and the wood density, where volume can be found out using the pi r square h equation, like it is a common volume equation. So the h which has been derived from the CHM, like canopy model, which has been derived out from the drawn data set. And using that we had found out the below ground biomass, and the total carbon stock from the biomass has been found out. So moving on the results, when this graph shows how the biomass has been increased by the increase in DBH with an R square value of with an R square value of 0.787, and how biomass increases with the height is having an R square value of 0.317. So we concluded that both DBH and height are the basic and the important parameters when we talk about the biomass and the which eventually leads to the carbon sequestration potential. And the model had an R square value of 0.967, which is quietly a fair amount when we talk. And the results that I got using the allometric equation, I had found out that the 0.5 kilometer square of area had sequestrated almost 0.62 tons of carbon. And when we talk about the soil organic carbon, we had found out that 263.97 grams per kg carbon has been sequestrated by this ecosystem. And when we talk about the soil pH, both the vegetative zone, like I had compared it with the control zone, so both the vegetative zone and the control zone had fairly neutral amount of pH, which talks that this ecosystem doesn't change the pH of the soil. And we had seen that the vegetative zone, like the acacia zone, had much more clay content than the control zone, which doesn't had any trees over there, which says that the clay content also has an influence on the carbon sequestration potential. And when we talk about the shoreline change, we can see that the acacia zone have sort of stabilized shoreline when compared to control zone when we compare the shoreline from 1998 to 2023. So I would like to conclude that these kind of thorny vegetation species can be included in the agroforestry projects and the RED Plus initiatives. And also these can be implemented to improve the soil fertility and stabilize shorelines of the, as like the blue carbon, like they doesn't sequester as much as blue carbon ecosystem, but they have a fairly good amount of carbon sequestration potentiality. So these are the references that I had used in this study, and I would like to acknowledge all the organizations and the institution which helped me to do the research, and thank you so much.
Thank you, Parvati, for your good presentation. Nice presentation, and it is very much required for the human society. Now I invite questions from audience.
Yes, sir.
Where you marked the coastal
Shoreline. Yes.
shoreline which was affected and not affected.
Yes, sir.
But the acacia, the vegetation was somewhere far behind the coastline, right?
No, yes, sir. It's almost near to the coastline.
No, the affected areas which you
Yes,
have
sir.
shown were just in the previous time period which you have shown was also like it's like a sandy zone kind of thing.
Yes, sir.
With a forest in the backdrop.
Yes, sir.
And the area which you shown as affected and not affected were also the same, right?
No, sir. One is a control zone where I couldn't find this species. The other one was the species, like my study area.
Okay, okay.
Yes, sir. Should I?
Yes, yes.
So
Here
this
only.
was the control zone.
The
where
green line is your control zone.
Green line is the 2023 shoreline.
Yeah.
The red line is 1998 shoreline.
But the change happened is between the red and the green line, right?
Here, sir.
Between the red line, you have drawn a red line. No?
Yes, sir.
There is a coast. There is a coastline.
Yes, sir.
And between the green.
This
and
green, are you saying, sir?
That you have marked a red line. No?
Yes, sir.
That is this shoreline which you said has changed, right?
Yes, sir.
Or it's say 19 and 2023 line. Okay, okay. Maybe I misread your image. Okay, I got it.
One more question from my side. Plantation is the common solution. Everybody understands its importance. But whether acacia has something more special? Why acacia? Why not other plants?
Because these species has like when we talk about these are invasive species, like usually people say that these Prosopis juliflora or acacia are invasive species, but when we take about this saline regions, so these ecosystem can grow in a faster rate, and they are drought resistant and saline resistant.
Okay.
So, but they do have demerits when we plant it on an agricultural zone or something, because it will affect the other vegetation from the sunlight and all, because it's an umbrella like canopy structure. But when we go to the coastal regions, we don't have much agricultural region under those. So,
okay, thank you. Yes. Thank you for a nice presentation. Next, we will move to the next presentation. Integrated morphometric assessment of the semi-arid Uttaranganga River Basin, Rajasthan, India, constrained by GIS, PCA and LULC analysis. Swarnendu Datta, Arindam Gantayat, Krishnendu Nath, Pooja Ghosh. Who is going to present? Arindam?
Swarnendu Datta is
Swarnendu
here.
Datta. Okay.
Okay. For cursor, use the mouse.
Good afternoon, everyone. Today I am going to present on our work on the integrated morphometric assessment of the semi-arid Utangan river system, Rajasthan. And here we have used the GIS datasets, and then we have applied the PCA and LULC dataset again to assess the sub water sets of the Utangan river basin. These are the major things we are going to discuss here. I am going to discuss here. So firstly, I will deal with the study area, then the objectives. Some data I have used all are open source available data sets. It is not working. Mic off. On. Is it audible? Okay.
Keep it closer to your mouth.
Okay.
Yeah, like that.
So river system, as we know, they are very dynamic and they changes actually over to the geological time scale. But river, it is very necessary to sustain the mankind. Here in the case of Utangan river basin, from the geological time scale, it has changed its course various some various times. So here we have used the very recent data set. I have used the Allospulsar dam of 2022. Okay. Then, as we can see from the dam basin, there are some major highlands in towards the south and the western part, which majorly controls the flow direction of the river. Utangan river, it is a semi-arid river basin. There are there are actually some constants due to the as during monsoon and after monsoon there are significant change in the water condition. So this actually affects the soil erosion and the flood pattern. Here we can see some Im some important cities and towns in the sub-basin of the Utangan river. So we have Hindon here and Bharatpur. So the here our main objective is to understand how and which of the sub-basins are going to more affected due to rain and due to change of course. Here we have subdivided the Utangan sub-basin, the Utangan river basin in 20 sub-basins, and the sub-basins were demarcated where any third order river is joining the fourth order river basin or the fourth order towards the fifth order. You can see towards our right most table, the highest, the trunk stream is of is fifth order river. By getting that, here the river system is majorly controlled by the lineaments, some ridges towards the southern and the western part, and there and the entire eastern part is of the flat plain. Okay. This is the main objective that I have discussed till now. The data set that I have used. Now, the methodology that I have used here, we have downloaded the dam, then we have delineated sub-basin, and then we have calculated the linear relief and aerial parameters. Then we have prepared the trunk stream profile, and along the trunk stream profile, we have demarcated the slope breaks, where the slope breaks, the youthful and the mature stages we have marked, and then across that we have made the profiles. Then from using these parameters along with our vegetation indices, we have calculated the NDVI, BS and the other soil index. Now using all these parameters, we have ranked the sub-basins. The ranking has been given to prioritize which sub-basin needs to be worked or needs to be managed at the earliest. This is the by using the different morphometric parameters I have created the maps. Here some the parameters have been written, so I have described the parameters by their full names. So there are different classes I have used on around 19 parameters. We have created the maps. This is the color is actually from the weighted average of that sub-basin, because different sub-basin we have some 44 to 40. This case, this is something a drainage density map or form factor map. Here I have taken the weighted average of that sub-basin to calculate the parameter. And this is, I have described earlier that two different zones in the youthful and the mature stage. This is, I have used the Sentinel data to prepare the land cover map. Here we can see that majorly there are 4 landscape parameters, that is some bare grounds, some build up. Majorly there are croplands and vegetations. The trees, the tree or grassland it is in, there is the Bharatpur sanctuary over there. Now, using from this data, we have calculated the different vegetation index, that is the NDVI, NDWI. We have calculated also the bare soil index and all. These indices have helped to demarcate, along with the morphometric parameters, to demarcate the which subbasins are required prior treatment first. Using the 19 morphometric parameters and these 5 vegetation index parameters, we have so here we have almost 24 different parameters. So here we have done the principal component analysis to reduce them. Here we can see the 4 factors from PC1 to 4, they contains almost 84% of the overall data set. So here among this we have taken factor 1 versus factor 2 plot. This we can see that if the number of rivers is higher, so the synergicity index for that case of basin is very much less. So, and here in this PCA field, I have tried to calculate that which are the basins are come toward the same clusters. This is the positive and negative PC cases. So for the PC1, the negative PC values are actually due to the coarser drainage texture, and the positive is for the finer drainage texture. So coarser drainage texture is there when there is some floodplains, but when there is some large hills or plateaus kind of things, so many small rivulets can actually start to form just after the monsoon. They actually merges with each other from small tributaries, then a stream. But for the coarse drainage texture, there the major trunk stream plays the major role here. So after so now here we have given scores of each of the 19 morphometric parameters and 5 of the land use the LULC parameters. So the priorities have been set in such a way that for the cases that there are where the number of river is large, higher, there the possibility of soil erosion is also high. So those kind of basins we need to manage at greater scale. So those basins were given as lesser marks, means higher ranks for our prioritization works. Similar for the LULC case, where the vegetation is higher, they can actually encourage the soil. So those subbasins require works less, whereas where there are more croplands or there are some where there are major settlements are there, so those kind of subbasin there are major chances of soil erosion and all. So now after combining these two parameters, we have demarcated four subbasins, that is subbasin number 5, 6, 16 and 17. For here these basins are majorly prone to soil erosion and flooding, and to support this we have done the cluster analysis where we can see the 5, 6, 16 and 17 number subbasin, that is 5 and 6 comes in very close. The 7 and 2 here you can see the PCA map. this, that's in the factor scale 7 and 2, the factor 1 and 3 map, they come in the same coordinate. Here, though they are in different coordinates, but they are very near to each other. So they are almost similar as our study suggests, and all other data supports our. So finally, to conclude that, by the help of the PCA, we have identified some controlling parameters. Like from the 24 parameters we have used, we have come to 4 specific PCAs that we helped, and then we have grouped the subbasin into high, moderate, and low categories. Those are previously mentioned, and finally, these results can provide critical inputs for prioritizing the defined subbasins and soil conservation, flood management, and groundwater recharge. Thank you.
Thank you. Thank you for very good presentation. Very good attempt using softwares. Now I invite questions from the audience. Okay, sir.
Yes, sir.
See, what I understood that you are trying to do some kind of a land suitability classes,
Yes.
right? But it will be even more important if you can classify this a little bit further,
Okay.
because basin scale management, if somebody is going for a land management, then what is that land suited for?
Okay.
Okay, so I think you can go one step further.
Yes, sir.
Otherwise it does not make sense to say that this is high suitability, how low suitability.
Yes.
But then you must say that, okay, this is suitable for forest management, this is suitable for urban infrastructure, this is suitable for something else, and so on.
Okay.
Then your study will make more sense.
Yes, sir.
Okay.
Okay. Thank you, sir.
While doing statistical analysis,
yes, sir.
Why don't you show the scree plot so that it can be better to understand?
Sorry, sir.
Scree plot.
Sir, actually, script plot I have made, but I have not included in this map. I have made the script plot.
Okay.
Yes,
that
sir.
understands which factor we should consider
Yes,
right
yes,
at
yes.
this moment. Okay. Overall, as anyone like to have any query? If no.
Thank you.
Thank you, sir.
Which software you are using for PCA, principal component analysis?
Sir, I have used it Statistica. Statistica. Okay, sir. Thank you.
Uranium contamination and its impact on groundwater security in YSR Kadapa, Anantapur district by Smita Priyadarshini Oza, Anvesha Roy, Mangaraja, Rao Bhavara, Maitri Roy, Maulik, Surendra Kumar Singh, Rani Bhiar, Vijay Madhusudan, Aditi Vishwas. Who is going to present? Smita. Okay.
Good afternoon, all of you. Myself, Smita Priyadarshini Oja from Geological Survey of India, and today I'll discuss on uranium contamination and its impact on groundwater security in YSR Kadapa and Anantapur district. Coming to uranium contamination, it is nowadays a national concern as states like AP, Telangana, Rajasthan, and Chhattisgarh, and also these states reported uranium contamination in groundwater more than 30 ppb, which is the permissible limit of WHO. This long-term use of this water is actually carcinogenic in nature. They have nephrotoxic in nature, and long-term use of this actually radiological effect. So in coming to in Andhra Pradesh district like YSR Kadapa and Anantapur, they heavily rely on groundwater because these are semi-arid region. So geologically this area is mainly a part of Kadapa basin, which is a proterozoic basin of India and hosts a number of mineral deposits including Tumarapalli uranium deposit. Coming to Tumalapalli, it is actually located in YSR district of Kadapa and it is one of the largest uranium mine in India. It is operated by UCIL since 2012 and in July 2011, AMD calculated the reserve as 49,000 tons, which they have revised in 2014 as 85,000 tons. Here, uranium occur within the Bhempali dolomite formation of Kadapa supergroup and the mineralization is mainly strata bound, tabular type and basically carbonate hosted uranium deposit. So this is the area of concern and this is the UCIL mine and this is the UCIL trailing pond. So coming to geological map of the area, here actually two types of rocks are exposed, mainly the rocks of PGC and the rocks of Kadapa supergroup. The rocks of PGC are basically composed of granite and biotite gneiss, and the Kadapa supergroup of rocks are basically the conglomerate, the dolomite horizon and the Tadpatri shale, where the UCL mine and UCL trailing pond is present in the dolomite horizon. So these are few of the field photographs which shows the dolomite near Tumalapalli uranium mine, then dolomite showing concentric growth of stromatolites and dolomite and alternate layer of shale, and this is the microphotograph of dolomite. Coming to hydrogeochemical environment, here actually the easternly flowing Mogenaro-Iru river forms the major drainage pattern in this area. The aquifers are mainly semi-confined to confined in nature and hosted within fractured dolomite, shale and granite and quartzitic units. Groundwater occurs mainly under phreatic and fracture control condition with depth ranging from 30 to 360 meter below ground level. This is actually a collaboration work between GSI and CGWB where we have collected groundwater sample, soil sample, petrological sample as well as petrochemical sample. So this is the point anomaly map of uranium in pre-monsoon groundwater sample, which where you can see that in this area the uranium is high more than the permissible limit. Even in the PGC also the uranium is quite high, which range up to 1315 ppb. Coming to the post groundwater anomaly map, here the values are a little bit less in comparison to pre-monsoon sample, but still the values are high in this area, even in PGC as well as in shale, and the values goes up to 635 ppb. Coming to hydrochemical characteristics, here the groundwater in the study area exhibit moderate to high salinity and the EC ranges from 670 to the 4900 and the alkaline pH is ranging from 6.9 to 9.8. These actually high alkaline and high bicarbonate favors the formation of uranyl carbonate ion, which is more soluble, and this enhances the uranium mobility. Coming to the dominant cations are calcium, magnesium and sodium, while bicarbonate and chloride are the prevailing anions in this area, and these phases are influenced by dolomite dissolution and ion exchange. The wide variation of EC and TDS in this area reflects basically the lithological influence and as well as the anthropogenic inputs such as agricultural return flow, fertilizer leaching, mine dump. Coming to Piper diagram, here in the post-monsoon water sample, majority of sample falls within calcium, magnesium, bicarbonate field, indicating carbonate weathering and fresh recharge from Bhempali dolomite units. In the post-monsoon, there is slight shift towards sodium bicarbonate field, which enhance the ion exchange process and dilution due to monsoonal recharge and longer water-rock interaction. Coming to Durov plot, in pre-monsoon, Most of the sample plot along the carbonate dissolution mixing trend, which indicate active weathering of dolomite unit of Bempalli formation, and the dominance of bicarbonate and calcium and magnesium reflects recharge from carbonaceous carbonate aquifer under oxidizing condition. In post-monsoon, the sample shows a similar trend, but there is a slight shift towards sodium bicarbonate phases, implying enhanced cation exchange and fresh recharge after rainfall. The persistence of bicarbonate dominance confirm the carbonate weathering as a major part in controlling the process. Coming to the Gibbs diagram, here the dominant mechanism is the groundwater and rock interaction, particularly the carbonate dissolution and cation exchange process. Evaporation effects are secondary but still noticeable as this is a semi-arid kind of condition. The higher TDS value in some of the sample attributed to prolonged residence time and limited recharge in deeper aquifer. Anthropogenic contributions are also locally enhance the value of sodium, chloride and sulfate, concentrating the shifting of some of the points towards the evaporation seawater field. These are some of the BSc images. Although we have not found any uranium phases in this area, but a number of thorium bearing phases like babanite, bastnasite and monazite are found in the ACM phases. Coming to source of uranium contamination, here actually the geogenic source and anthropogenic source plays hand to hand, as the primary source is the local lithology, particularly the dolostone hosted strata-bound uranium deposit in Vempalli formation. As I have already told, the uranium in its more soluble hexavalent form, uranyl ion, which is readily leached from the mineralized horizon and enters into the groundwater system. The anthropogenic influence, like the Tumalapalli mine, also increased the leaching of mine waste as well as the in situ leaching, which increased the uranium contamination. Coming to multivariate analysis, the PC1, PC2 and PC3 here combine up to 70%, and the PC2 implies that strong association of uranium with bicarbonate, sodium and fluoride under alkaline pH, forming uranyl carbonate complex, which is basically geogenic showing the geogenic uranium mobilization. Coming to PC3, the anthropogenic contributes like fertilizer and wastewater infiltration shows that anthropogenic causes are really there in that area. Coming to the key finding, here the uranium contamination is primarily geogenic, which is aggravated by the anthropogenic influences. The carbonate dissolution and oxidizing condition enhance the uranium solubility. The ion exchange and bicarbonate dominance indicate strong water-rock interaction. The PC2 and PC3 in fact that the geogenic sources as well as anthropogenic sources are there in that area. Coming to mitigation and management measures, we have to really focus on to construct some lined waste disposal site and trailing pond to prevent percolation of uranium bearing effluents. We have to strengthen the effluent monitoring system of UCIL so to maintain the strict pH and alkalinity control. We have to install mine water treatment system. Then we have to establish peripheral monitoring wells around the mine site and waste disposal site for early detection of contamination. We have to develop artificial recharge structure and we have to regulate the phosphate-based fertilizer to limit the anthropogenic uranium mobilization. We have to encourage blending of high and low uranium groundwater for irrigation to maintain level below 30. Then you have to provide household filtration unit in affected village. Then we have to conduct periodic uranium surveillance. We have to develop a uranium vulnerability index to identify and prioritize the high risk aquifer. We have to enhance the awareness and capacity building among the local communities. Thank you.
Thank you. Very good presentation. Actually, that area, Pampali limestone or western part of Kadapa basin and eastern part of Naisi complex is showing higher concentration of uranium all along that, and above that, from starting from Kurnool to Anantapur, entire area is affected. And now I invite questions from audience.
If you come to slide, madam,
coming to your anthropogenic effects, which fertilizer is more utilized here?
Actually,
Phosphate
the
fertilizer or?
phosphate-based fertilizer.
Okay, what is the correlation?
Actually, where they have using the phosphate-based fertilizer, there we are seeing that uranium is quite high compared to other
And
area.
there is no use of nitrate.
No, the use is there, but there is less use of nitrate as compared to the phosphate-based fertilizer.
Okay, okay.
So the primary source is phosphate.
The primary source is geogenic.
One is geogenic.
Yes,
the
sir.
other
Other one
one
is
is
phosphate based.
So where from these material they use? So from the Arabian countries or like that?
Sir, I have to read about that. I mean, where they are.
If you have to study the anthropogenic, then nitrate and phosphate, for that you have to do speciation studies and redox conditions.
Okay,
how
ma'am.
uranium is
Leaching.
migrating from its source to other areas.
Okay, ma'am.
Thank you, ma'am, for this information. It's rather a query. I have because it's related with human and ecological health. So, can we tell up to what extent it has been affecting the health?
Actually, there the locals have skin irritation, and they are actually long-term use of that maybe leads to carcinogenic and nephrotoxic. But what we have marked that they have skin-related disease because they are using those water for their daily purpose. So it is started like that, but in future you don't know what will be the condition.
Actually, I wanted to know that whether the contamination factor, pollution load index, and ultimately the hazard quotient, they were calculated or not? Because eventually hazard quotient needs to be calculated, and then
Okay,
we
that
can.
will do. That we will do. That we will
That
do.
I was asking you.
Okay, thank you.
Yeah, thank you, ma'am.
As we are now done with the presentations, I request our chairs to kindly conclude the session.
In this session, there is a theme, Geological Insights for a Thriving Earth, the critical zone. There is up to the level of groundwater bottom interactions. We have scheduled 6 lectures, but out of that only 5 lectures performed. The keynote lecture gives an idea, the detailed idea of the river course, changing river dynamics, sedimentation rates, and river flows, and the shifts and the controlled use of the riverbed material, because it affects the life and the broader sense the social life. uh, River erosions, it is uncontrolled erosions can cause more damage to the environment within the surrounding environment. That is already a brief uh, narrated by Professor Rajiv Shina. In addition to that, we have groundwater sustainability challenge in Rajasthan, decadal analysis of recharge and extractions by Preeti Pandey from Central Groundwater Board. We have noted, and she also assured that they have taken some, they have recommended measures, mitigation measures. Now it is the society and the governance that depends upon the rechargeability. In addition to that, Acacia nilotica, there's a re-evaluating, because it has, this plant has some negative impact also. But Madam Parvati has given some positive outputs, the utility, and her works depicts that this particular plant has helped to develop the coastal protections. And now the last one, Sharnendu Datta, no, last before one, there is the integrated morphometric assessment of the semi-arid Uttagan River Basin. Yes. For that particular thing, I feel we have must do one aspect, more statistical utilities, because many other statistical parameters perhaps he has to come out, bring out, and and as Professor Rajiv Sinha recommended, that for each land site, the purpose and how the land can be better used, that recommendation we are expecting from him. In his future work, we must see that he will come up with those ideas. Now, uranium contamination, this is also done by Smita Priyadarshini Oja. It's already known these contaminations, and she has said that contamination, the primary contamination is geogenic. Yes. In addition to that, some secondary contaminations. So, particularly the tailing side management, that we can do. We can do the tailing side management, because many of the things can be beyond our capacity, because we need uranium, right, for energy, for that. But at the same time, human health is definitely an important issue. So tailing management and phosphate fertilizer utilizations, that may be taken care. So all such, or if I conclude with all the five lectures, every lecture gives us a different ideas how the critical zone of the earth is being used and how we can have to monitor for a better sustainability. Thank you for my end.
Thank you, sir, for giving elaborate description of what has happened in the last 2 hours. One thing I will say, that all the lectures are from different places of our country, starting from one part in Bihar, UP, to another eastern part of Rajasthan like Bharatpur, and western part of Rajasthan, and Gujarat coast, and one from Andhra Pradesh. But all the five or the lectures have one thing in common. These are directly related to our human activities and our day-to-day life. So how life should not be affected by our human activity, and it should be controlled. So all the lectures were very good, and starting from the keynote lectures, I was very eager to meet him, Professor Sinha, because based on your document, I had prepared that short video, documentary video. So it was nice to meet you, and your lecture was very good, and other lectures were very good information, and they were really useful. And thank you all from my side.
Thank you, sir. Thank you so much for sharing that valuable feedback and your perspectives with us. Now I would request Shri Lalit Mohan Singh Mora, Deputy Director General and Regional Mission Head to WRGSI, to kindly come up for the felicitation of our respected chairs. Thank you so much, sir. With this, we have concluded this session. You are all invited to proceed for high tea, as we will now take a short break. We encourage all the participants to visit the poster session and exhibition during this time. It is requested to you to reassemble here at 17 hours positively, so we can start with our final session of the day. Thank you. shed some light on the theme titled Below the Waves, the Oceanic Enigmas. To guide this session, we have amongst us Dr. N.M. Sharif, Deputy Director General and HOD MCSD, Geological Survey of India, and Dr. A. Anil Kumar, Director PSS, PNM 1 GSI as our respected chairs. I am pleased to introduce here Dr. N.M. Sharif, an accomplished marine geoscientist of the Geological Survey of India. He has undergone prestigious foreign deputations in marine gravimetry in the USA and multi-channel seismic data acquisition in the UK. Dr. Sharif has authored several notable publications in marine geology and coastal science. His wide-ranging contributions span research vessel management, exploration, seabed mapping, heavy mineral studies, paleoclimate investigations, and tectonic assessments across various places in India. Our co-chair, Dr. A. Anil Kumar, Director, Policy Support System, PNM1, GSI, is a distinguished geologist of Precambrian rocks with key publications or mafic dike swarms, granitoids, anorogenic granites, and crustal evolution in the eastern Dharwa Craton and Andhra Pradesh. Their professional work spans RE mineralization studies, geochemical data compilation, proterozoic mapping, and base metal reconnaissance. He has also contributed to mission planning, technical coordination, and IT and geoinformatics support in the GSI. May I now invite Dr. N.M. Sharif and Dr. A. Anil Kumar to kindly come up and begin the proceedings of this session. I also invite the session rapporteur, Shri Sulal Enil, Superintending Geologist, GSI Western Region, to join us and report the proceedings of this session. We will now proceed with the technical presentations for this session. We have a total of 5 presentations and I request each speaker to adhere to the allotted time. Sir, I will also request you both to kindly moderate the presentation timings. Okay, sir, you may now proceed the session. Over to you.
Good evening, ladies and gentlemen. We have a session now. This is Below the Waves, the Oceanic Enigmas. I suppose there are 5. In fact, we have given 4. It is given here, but then I think only 2 or 3 presenters are there. How many are there?
Sir, I have received 2 presentations as of
Okay.
now.
It's very unfortunate. Maybe since it is the concluding session, probably people might have been tired. Anyway, straight away, I request whoever is going to present to restrict to the timing, whatever allotted time, and make it very brief. Thank you.
I request the first presenter to on the topic high resolution characterization of microbialite morphotypes in late Pleistocene Hawaiian reef system by Purnima Karki. Yeah.
Good evening, everyone. Dear panel members, all the dignitaries and delegates. I am Purnima Karki. I am from Indian Institute of Technology, Gandhinagar. I am working on a small part of the I'm working on the microbialite component. Here I'd be talking about the high resolution characterization of microbialite morphology in the late Pleistocene Hawaiian reef system. My samples come from the time frame of marine isotopic state 7-6, and I'm working under the guidance of Professor Pankaj Khanna. So to begin with, microbialites are organosedimentary deposits. These are formed by benthic microbial communities, and they are formed either by trapping or binding mechanism, or they form a site for mineral precipitation. They play a very vital role in reef building. And talking about the types of microbialites, I think the most well-known type of microbialite is stromatolite, which has a very laminated internal structure. Other than these, thrombolytic, dendrolytic, leolytic type of microbialites also occur. And why studying microbialites is important because they are very sensitive to changes in the environmental parameters, light conditions, sea level fluctuations, nutrient levels. And as we know that for the past 500 kilo years and more, there has been various glacial interglacial cycles, and which are depicted in the figure B here. The interglacial cycles are depicted by marine isotopic stages, odd numbers, and the glacial ones are depicted by even numbers. And my samples come from the MIS 7 interglacial and an MIS 6 glacial stage, which ages back to 243 to 130 kilo years back. And to show how morphology of microbialites can play an important role in understanding the sea level changes, that an example comes from the Tahiti microbialites, where it is seen that as the sea level rises and the corals fail to keep up with the sea level rise, they are encrusted by algae. Then the algae is further encrusted by different morphologies of microbialite, and a specific type of microbialite called dendritic one depicts the sea level rise. And this succession is in Tahiti is a very ideal succession which shows the changes in the sea level. And so microbialites formed during glacial degradation times would preserve signatures of the sea level changes. Coming to my study area, it comes from the Central Pacific Ocean, the Hawaiian island, which is an archipelago formed because of the hotspot volcanism. And my study area is the big island of Hawaii that we see here. It has several round reef terraces. Major 12 terraces have been found in this area, and my samples come from the H2 terrace of minus 400 meters below the sea level. And the island undergoes consistent subsidence and sea level change, because of which the accommodation area is large and we get a high resolution of data set to work upon. My data set consists of two sets. One is the high resolution line scan images that comes from the cores that have been drilled from the sites shown in the map A. The sites are on the leeward side, that is the drier side of the island, is the site M97, and on the wetter side is the site 102 and 104. The data set come from these two sites, and the data set is the high resolution line scan images and the hand samples. So the workflow is that I'm using the line scan images for the identification of morphologies and quantification of area, and hand samples for the petrographic analysis. I'll be talking about morphology and area quantification here. The figure B shows the position of the well from the 97 site from which this particular core has come. And we have segmented the image into corals, algae, and microbialite, and further different type of microbialite morphologies have been identified from these cores. And then we have also tried to quantify the 2D surface area from the line scan images to understand what abundance of microbialite is there in both the sides of the island, and if there is any variation in terms of area or morphotype. These are all the different type of morphologies that I have observed from the windward and leeward side. A thing to note here is that the difference in coloration between the microbialites from the windward and the leeward side, the ones with the dark color are the microbialites from the windward side of the island. Then preliminary results show that we have, on the basis of mesoscale microfabrics, we have classified all the morphologies that we have observed into the 7 different classes. The classes are laminated microbilite, laminated columnar microbilite, dendritic microbilite, structureless microbilite, structureless columnar, microbilite coated debris, and interskeletal boring filling kind of microbilites. Uh, Out of all these, laminated columnar dendritic occur very abundantly, and the least abundant ones are structureless columnar and microbilite coated debris. These are the results for the 2D surface area from various sites. The bars represent the occurrence as well as the abundance of the microbilites from each site. And yeah. So concluding my talk, these microbilites, what we have found out that these are not the kind of microbilites that are built up kind of microbilites. They fill in the cavity of the reefal and the algal framework in the Hawaiian reefal architecture, and they play a very crucial role in the reefal architecture because they are abundantly present there. There have been a consistent difference in coloration between the microbilites. The darker ones come from the windward side, reflecting the enhanced volcanic and terrestrial input, that being the very wetter side of the island. And the fabric has been divided into the 7 classes of 7 morphologies of microbilites. And so far, we have not seen any distinct trend in the abundance of microbilites from various sites. And again, out of the 7 classes, the 2 classes that are least abundant are structureless columnar microbilite, followed by microbilite coated debris. These are the references that I used for the talk, and I would like to thank all the like my institute for providing me the facilities, IOTP for the samples, NCPOR for facilitating my professor to go there and collect the samples, and GSI and Ministry of Mines to be here and present about my work. Thank you so much.
Thank you. Do we have any questions from the audience? This session we have one or two advantages is that one is that we have you thank you first for completing your presentation on time, well within the time frame, and we do have advantage of I think only 2 presentations, so I can take some time to ask a few questions.
Yeah.
Okay. See, you have these studies are based on drill course, right?
Yes.
But you have focused only on one particular MIS 7.
Yeah.
What about whether the course do have the records of the later events and the past events, or you are just you want specifically to the MIS 7? What is the logic behind that?
So the samples have been divided, like certain people are working on different aspects of the sample. So we have been allotted this particular.
This was what I understand is your project was specific to MIS 7. Is it like that?
Yes.
I mean that entire core has got the entire records,
Yeah.
and you are focusing on MIS 7.
The samples that I am working from the H2 reefs,
Yeah.
that are from MIS 6-7.
Okay, and you were showing the logs of the cores from both the windward and the leeward side. What was the logic behind that? You expect variations on both the sides.
We were expecting some variation in terms of morphology from the windward and the leeward side. Because in the windward side, there was more terrestrial input as well as in the Tahiti side, the Tahiti analog, people had found that there were more volcanic clastic input in the windward side. So we were expecting those kinds of results from the windward and leeward differentiation. And we could see if the changes in like the terrestrial input or like the difference in the island position would lead to any changes in the morphology or abundance as such. So that is why we wanted to compare it.
Okay, okay.
Yeah.
So my curiosity, I mean, since you're saying that there will be morphological variations,
Yeah.
still you're assigning it as a single species or any species changes?
Sorry, I did not.
You have morphological variations, right? We're expecting morphological variations in the
Yes.
windward side and
Yes.
leeward side. But when you have changes in the morphology, and if it is an adaptation, Basically what we are expecting is changes the species, no, right?
Species?
Yeah, because these are the microbial communities,
Yes,
right?
yes.
So are they going to be the similar?
Are the species?
Yeah, because you have the morphological changes.
Yes.
Any morphological change should render it into a different species classifications, right? Normally that is the practice in micropaleontologies, in
No,
fossil
but
studies.
in terms of the species change was not there when we were comparing the Tahiti ones. The
Mm-hmm.
changes was in terms of when there was more sediment load in Tahiti,
Mm-hmm.
more dendritic type of microbialites were forming.
Mm-hmm.
But we did not we have not compared it yet in Hawaii. We have to compare it more. But in terms of microbialite species, they did not find any difference in the windward and leeward side.
So it is only a situational adaptation, right? I mean,
The morphology.
yeah.
Yeah.
Okay, fine. I think I can only suggest is that if you can make more of related studies, just not just confining to one event.
Yes.
That will give a broader picture. Okay, thank you.
Thank you.
Can we call the next presenter? Uh, do we have Rakesh Yadav? Just wait. Benthic foraminifer diversity and oceanographic changes during mid-Pliocene. Do we have the presenter here?
Sir, I think they are not here.
Okay.
They have not submitted their presentation
Then
also.
the next one, the paleoproductivity variability in the northwestern Arabian Sea over the last 70,000 years from the ODP hole 727b.
It's lost 70,000 years.
Yeah.
Please take the column mic from there.
Who is the presenter?
Please connect the screen. Sir,
Yeah.
he's coming. He is getting his column mic attached.
Yeah.
Okay.
Thank you, sir.
Yeah.
It's I'm the Selvaraj Kandasamy. I'm the presenter.
Yeah.
Okay.
Please go ahead.
Yeah. Thank you for the opportunity. I'm very thankful to GSI for giving me an opportunity to present our topic now. So this is my topic, that is paleo productivity variability in the northwestern Arabian Sea over the last 70,000 years. So the samples are from the ocean drilling program hole 727b from the Oman margin. Okay, just to introduce what is productivity, how to define that, that is production of organic matter by marine organisms, very particularly phytoplankton, primarily through the process of photosynthesis. This particular process converts inorganic CO2 into organic carbon through the equation like this. So it means the photosynthesis directly affects atmospheric CO2. Therefore, it controls the Earth's climatic conditions on longer time scale like glacial interglacial time scales. So we all know that the Arabian Sea is one of the world's most productive oceanic region. Therefore, it is an ideal region for reconstructing past productivity variations. So everyone knows that upwelling in the Western Arabian Sea boosts productivity. That is completely driven by monsoonal intensity. That is a very strong Indian summer monsoon and associated climatic shift. So this ODP whole 7 to drill site from the Western Arabian Sea upwelling, because when it hits the African coast, the surface water deflected offshore, inshore, so that the deep water will come and occupy that places. So that deep water is very colder, and at the same time there is a lot of unutilized nutrients. When it comes to the surface, it supports the high productivity in that region. Anyway, this is the what is that relationship between monsoon versus primary productivity. One can see that this is like
biogenic silica flux in that region for the last around 1 year duration, and that is compared with the upwelling velocity and sea surface temperature. When you see that there is a high biogenic fluxes, you can see the sea surface temperature decreased. That is an indication of very strong upwelling. That means deeper colder water come to the surface. That is the meaning, so that the sea surface temperature declined. So this particular, when there is a high productivity that is very closely matches with the southwest monsoon in the Western Arabian Sea. So the modern productivity is estimated like this, for example, like 100 gram carbon per square meter per year, according to studies from NIO, National Institute. Therefore, my aim is that to reconstruct marine paleo productivity trends in the northwestern or western Arabian Sea over the past 70,000 years by analyzing geochemical proxies. Very particularly, we are interested only two proxies. One is biogenic silica, and another one is the total organic carbon in sediment subsamples from the ODP hole 727B. So these are some of the objectives. So total organic carbon was measured to assess variations in primary productivity and organic matter preservation in the study area, and biogenic silica content was measured to interpret past fluctuations in siliceous plankton productivity, and also we try to establish the relationship between productivity, monsoonal activity, and global climate fluctuations. So that is the one. So if you look at that, this is the study area. So you can see that this is the one IODP that ocean drilling program has recovered many different sites, almost around 8 sites from this region, like off Oman. In this particular region, we call it as a Somali upwelling region. So we selected the core 727 from this one, and you can see that the core was from the water depth of 915 meter. This is the lat long of that region. When you look at this one, this is exactly below the oxygen minimum zone. So it means where you can see high productivity when organic matter goes down in the intermediate water column because of degradation of organic matter, it consumes oxygen, so that it brings the low oxygen region in that place. So that anyway, the core sample was shared by Dr. Prakasham from Wadia Institute of Himalayan Geology for our students' dissertation work. Okay. Anyway, there is some materials and method. What we have done, we have measured around 74 sediment sample from the core, and we measured total organic carbon and biogenic silica, only 2 parameters. Then we use some transfer function given by Santhian et al. For the estimate of paleo productivity. So for that, we use barial flux of these 2 parameters, sedimentation rate and water depth. So anyway, these are some of the details of determination of biogenic silica using simple spectrophotometric method. So all the 74 samples are under this one measured through this method. And also the determination of TOC, we used the total organic carbon analyzer, that is elemental analyzer available in Wadia Institute of Himalayan Geology to complete this particular work. So this is the one primary productivity calculation. We use this particular formula, for example, given by Santhian. So you can see that these are some of the PP means the paleo productivity in terms of gram carbon square meter per annum, and this Ca is the barial flux of TOC, and this S means sedimentation rate on TOC free basis, and Z means that is the water depth in meters. So this particular formula normally we use for the low latitude regions. So there is some high latitude, there is a Stein et al. And one more formula is available. So this is the age model, very simple age model we followed based on the ODP core. On board they suggested one age model that is published by Takahashi in 1997. The same age model we used, for example, around 12 meter core goes around roughly 80,000 years of sedimentation history. So that's the one. This is our data. For example, total organic carbon in the left side, you can see that, and right side the mass accumulation rate of total organic carbon, and this lines the mean of for the past around 70 to 80,000 years. So these are all our measured data. So one can see that very high concentration of total organic carbon during the last 10,000 years, that is marine isotope stage 1, we call it as Holocene. And also you can see that high accumulation rate of TOC during the marine isotope stage, that we call it as last glacial maximum, probably more sedimentation rate during that place. So when compared to the interglacial glacial period, you can see that interglacial period, you can see the last around 20,000 years, you can see both accumulation rates are high as well as concentration of total organic carbon increased. This is our biogenic silica time series. So you can see the glacial interglacial variation, and one can see very high mass accumulation rate of biogenic silica during the last glacial maximum. That is consistent with marine isotope stage. One can see that very strong winds during the last glacial. So probably that is a wind induced upwelling. So likely we can expect that. So why we have seen high biogenic silica concentration during that period, very particularly deglacial and Holocene period when compared to the previous glacial intervals. So if you look at the mean value of this one, you can see that almost before 20,000 years, you can see that lower values than the mean value, but then last around 21,000 years, you can see that many higher values. It seems that there is a increasing biogenic silica productivity and preservation in this region. And this is, for example, flux we calculated. Flux also, you can see that biogenic flux is extremely, it's high during the marine isotope stage, which is consistent with the last glacial maximum condition, that is giving that glacial high productivity. We have theory that glacial region, we have high productivity than interglacial. So that is very consistent with this theory. So during that remaining period, you can see that the values are lower than the mean values. And this is carbon flux also. You can see that the carbon flux increased roughly from the deglacial period to the present when compared to the previous. But you can see there are some higher than mean values you can see in some places in the organic carbon, but biogenic silica is not giving that kind. So once you can see that there is an increased flux since the deglacial period compared to the previous marine isotope stages. So therefore you can see both proxies are giving there is an increasing productivity or increasing preservation of organic matter and biogenic silica since the last glacial maximum in that region. So this is, for example, estimated paleoproductivity. Again, you can see that the paleoproductivity is like from here you can see that there is a high productivity both in the total organic carbon parameter and biogenic silica productivity. So that is quite interesting. But when you see the biogenic silica productivity was relatively lower, for example, during marine isotope stage 3, 4, and 5 when compared to 2 and 1. But there is very less fluctuations in the biogenic silica productivity when compared to total organic carbon productivity. It seems that siliceous productivity increased, for example, last around 20,000 years in the study area. So these are some preliminary results. So therefore, my concluding remarks: enhanced silica productivity during marine isotope stage 2, that is consistent with the last glacial maximum, and also marine isotope stage 1, that is the present Holocene, suggests an increased wind strength from the LGM in the study area. That is our interpretation. And also one can see fluctuating organic productivity during the marine isotope stage 2 and 4, that is followed by enhanced organic productivity completely during the Holocene period. That confirms the productivity regime change in the Western Arabian Sea, last at least 2 marine isotope stages when compared to marine isotope stages 3, 4, and 5. And one can see TOC based estimate display more pronounced fluctuations, so indicating higher sensitivity to upwelling intensity and nutrient availability in the study area. These are some preliminary conclusions we made based on these two proxies. Anyway, thank you very much. This is my scientific publications related to marine sediments and geochemistry and other stuff. And thank you very much, and I'm very happy to take 1 or 2 questions. And it is an outcome of graduate dissertation work. Thank you very much.
Thank you once again for sticking on to the time frame. And I'll get the questions from the audience, but I also have 1 or 2 questions because we have time. Okay.
Thank you. Yeah.
See, you were working on the Western Arabian Sea, right?
Yeah.
And you have shown the data saying that for the southwest monsoon you have a means that you have a direct proportional relation. When there was a intensified southwest monsoon, you are getting high productivity records.
Yeah.
But in contrast, on the other side, or the western margin of India, we have an opposite record. During the periods of the high monsoon intensification, okay, we have a low productivity records on the eastern, means on the west coast of India.
But it is not an upwelling area. No? Probably that
No,
is the
I'm
reason.
saying about the,
Yeah.
it's a long debated topic that whether it's a preservation or it's the production that is, leading to the
But
higher organic carbon.
but you are right. But we cannot talk about preservation in that place because that particular 915-meter water depth, there is no direct river discharge to preserve the things. So probably it is something related to really increased productivity, and at the same time the proportionate organic material preserved in that region. I feel like that. Yeah.
Yeah, if you have gone through the papers of Dr. Nakwi and all, na, that what they say is that when there is an excess rainfall, there is excess runoff to the oceans. These runoff creates a freshwater layer on the sea surface that prevents the upwelling. Okay, so when on land we have an excess rainfall, but this is not that because of the freshwater input to the oceans, the upwelling is less, and that because of that the productivity is less. So that there is a theory to justify why we have low organic carbon in the sediments coinciding with the high intensified monsoons. So means that is the case in the eastern side of, means the other side of the Arabian Sea.
But it's correct. But however, we have to think about where our core is. It is depends on the water depth. So
there are multiple papers on
and
this.
yeah, of course. But another quite interesting thing is that the western Indian rivers are really not that influence the freshwater. I don't think so. It will really give some layers on the surface waters. Okay.
Yeah,
Okay.
the problem is when you see the plenty,
Yeah.
we have the problem of confusion. Like,
Yes, yes, yes.
if you see the influence of Indus fan, even up to 6,000 meters, we have siliceous materials.
Yeah, that is there.
Okay,
That is
so we
really
have
huge.
the freshwater forms also. So transportation mechanism, dynamism in the sea is not only influenced by one or two rivers. It is a complex situation. So just concluding something based on one or two, I don't know whether that will be doing justice to science.
Yeah.
So that is the only question. And then since you have already mentioned about the productivity versus preservation, the biological silica,
Yeah.
whether it is really productivity term will be more apt or preservation will be apt, that you'll have to think.
Yeah,
So I
you're
will not
right.
comment on that. It is only a suggestion. You have to make a
Sure,
conclusion
sure,
on
yeah.
that. Okay, thank you.
Thank you, sir. Thank you very much. Thank you. Yeah. Thanks. Yeah.
So you can give the
Yeah, sure.
Thank you.
Thank you so much, our presenters. As we have now come to the end of the presentation, sir, I would request you both to kindly present your concluding remarks.
Yeah, I'll just start. In fact, the plenary speak lecture on under this theme we had in the morning, that is was to adjust the time difference, because we had an eminent speaker from the USGS. So on his request, we kept the session in the morning so that it will be appropriate time for him. And like the theme, under the waves, we had, though there were only one plenary and two tech lecture that covered the entire, globe as well as the time frame. The first speaker was on focusing on the MIS 7. The other speaker was, speaking about MIS 1 to 5. So we covered a very large spectrum on the time frame as well as the geographic. We have covered the Arabian Sea, Indian Ocean, Pacific Ocean, so and they're almost all the globe. So it was a though we had a very limited gathering in terms of audience, the coverage was wide in terms of the topic we handled. Yeah.
Thank you, sir.
Yeah.
Director General, Geological Survey of India, to please come on stage for felicitation of our respected chairs. Thank you so much, sir. With this, we conclude not only this session but also this seminar. I cordially invite you all to reach to the main auditorium at 18:30 hours for the valediction ceremony, where we will formally bring this seminar to a close. Your gracious presence will add honor to the concluding session. But before we move, I want to extend my heartfelt gratitude to all the esteemed delegates, distinguished dignitaries, and participants whose presence and insights have made this event truly enriching. We remain hopeful that the GSI will continue to make the nation proud, inspiring generations to pursue excellence, empowering young minds to realize the full potential of scientific knowledge, and encouraging the world to recognize GSI's capabilities and seek meaningful collaborations. Thank you all for your support and participation. Namaskar.